the show. So we are
Okay.
live now on YouTube, and we have an interesting conference today, huh, Tim? Some news to share before things get started here, so people can have some time to join up and smash that like button and ring that bell and spread this link around so that we can get some people watching. It's been an exciting week for UAP, and I think this was perfectly timed to do the conference, to not really have to take a break from the kind of purely propulsion technology kind of stuff and get into some what we're kind of all really interested in on the side a little bit, especially with the news that's going on, and we might as well talk about it and get some expert opinions on things and the language being used. And I got all kinds of comments to make on this, but it should be fun to see what all the other people from our conference have to say about it as well, because I'm interested to hear their perspectives and our
Well,
audience's perspective as well. So
sorry, I didn't mean to cut you off. I'm excited about this too. The UAP thing is interesting. What's interesting about that, and I'm sure you'll agree, Jeremy, is a lot of times you'll see a story like this in the news that'll come and go, right? And with the UAP thing, this started what 2 or 3 years ago now. It kind of came and went. They released the video, and it's almost like it's been percolating. And over the last year, it's been growing and growing. And then over the last week, we had this was maybe a week, 2 weeks ago, John Ratcliffe, the former head of the, was it director of national intelligence, right? He reported to the president. He came out and gave a preview of what's going to be in the report. And have you read his comments? I don't know. Have you read those, Jeremy? Or?
no, I haven't got a chance to read that yet. Do you have a link?
Okay.
And
I can look it up in a moment when Michael is on. But if you look that up, John Ratcliffe came out and it's what they call report preview. And what he said was, he said, this is material we wanted to declassify, and we just didn't have the time during the Trump administration. And he had said that we've got multiple sightings, multiple sensor data. It's all over the place.
I really
So
feel like this was supposed to come out like before, but they kind of held back because of Trump for some reason. That's why I almost feel like was going on behind the scenes, because they almost like bet on Hillary winning and thought that Hillary was going to win, and then Trump won, and they were like, "Oh God, well we still have to come forward with this, but we kind of got to put it on a different timeline." And now we're kind of approaching that timeline that about 4 years late.
it could be. I mean, then so in
Yeah, I know.
addition
There's
to
so much thinking about it. Like, I don't know. I talked about these think tanks that thought about a lot of this stuff and where to look for information on UAP in my presentation that I put together. And but yeah, go ahead with what you had to say about this.
what is your opinion on the black triangle? That got me, and the reason that got me, before you respond, the reason that it bugs me, because okay, we've got saucers. They're silvery shaped. They could be mistaken for tic tacs. You know what I mean? Everything is tic tac and orb shaped, and then all of a sudden you get this periscope video on the sun, which isn't highly reputable, and then the DoD confirmed it.
Yeah,
And that was the part where, and the Fox News story, it's like DoD confirms triangle video, and I'm like, okay, well, you get this periscope, and I'm like, I'm looking. They said it's a pyramid. Well, yeah, but then when he zooms out, there's three others. What it is a black triangle with lights at the corners, and I'm like, you know what I mean? It's like one of these things is not like the others. So I don't know.
have you seen the Mick West did a video on it? Have you seen that yet?
I have not. I have
Well, I'm
not.
gonna play it for everyone so you can see his latest one that he put together, and I guess a lot of people hate this, but it's
This
like
UFO.
a lot of people haven't watched it and really like taken it. So I don't know. I'm just gonna play that, and we'll and talk about some of the people's comments about this. But so let me you can hear my audio. I don't know if it shares it with the.
Video does not show a pyramid. There's a triangle shape, but that looks exactly like an
Well, we can
effect
hear you
caused by a
fine over
bright
here.
light being out of focus, and a night vision camera with a triangular iris, like this one,
I'm gonna do
or a
share
triangular
screen.
lens cover, like this one. This effect is known as bokeh. It's also probably a plane because it blinks in the same pattern as a Boeing 737, and the ship, the USS Russell, was directly under the route for planes flying into Los Angeles from Hawaii and Asia. There are a couple more triangles in the scene. Those are probably stars, because they look exactly like stars taken with a night vision camera out of focus with a triangular iris. There's some bright lights at the start of the Pyramid UFO video. That's probably Jupiter and some stars because it matches exactly where Jupiter and some stars were on that day. They don't show up as sharp triangles because the cameraman has not zoomed in yet, but they look the same shape as the supposed flashing pyramid does when it first arrives. There's some points of light in the video that sometimes look like stars. They are not stars. They are random noise, stray electrons in the image intensifier tube. They change from frame to frame. They don't show up as triangles
Jeremy,
as
what
they
did
form
you
in
hear
the image
about Mark
intensifier tube,
McCandlish?
which
Where'd
is
that story
behind
come
the
from?
iris, so they are not affected by it. I first saw this video 1 week ago, on April the 8th. I instantly realized it looked like a plane from the flashing lights, and quickly figured out that bokeh was the best explanation for the triangular lights. But I had no evidence, and no night vision binocular, and couldn't find a night vision binocular that had a triangular iris. So I tried duplicating it by taping a triangular hole in the front of my regular camera. This gave nice triangles for lights and stars when out of focus. I also found that taping holes in the front of night vision binoculars was actually something people did, although I couldn't find any triangular shapes. Then, a breakthrough. Jesse3959 on Metabunk took a look at his night vision binocular and discovered, hey, it has a triangular iris. I asked him for some footage of lights and stars and he delivered. Then using a styrofoam holder, he recorded the output with his phone. He changed the focus, and that changed the size of the triangles. And when he filmed the darker sky, you get exactly the same faint stars and sparkly noise that you do in the Pyramid UFO video. Then, another breakthrough. A friend told me he had a military-style PVS-14 night vision binocular. He taped a triangular hole on the front and got just the same results as with the triangular iris. Lights took on a triangular shape that changed with focus. Stars looked like the faint objects in the Pyramid UFO video, and we get the exact same noise. This PVS-14 footage also shows a circular glare around the triangular bokeh, something that appears in the Pyramid UFO footage and that people thought was evidence that it was actually triangular shaped. But it's not. The circular glare is just spreading light. It happens all through the camera so it looks round and even. The triangle is a different thing, only affected by the front iris or lens cover, so the triangle and circle are independent. So why couldn't the Navy figure this out? Why did they confirm the videos were real? Why does it show up on a slide for the UAP task force described as an unknown unmanned aerial system at 700 feet? Well, the key thing here is that the task force investigates sightings that were initially unidentified. This includes examinations of incursions that are initially reported as UAP when the observer cannot immediately identify what he or she is observing. And I think that's what we're seeing here. These are some lights in the sky that a Navy observer filmed with an accidentally out-of-focus night vision binocular and a phone. Initially they were unidentified. Maybe they still are. Maybe some were Chinese drones at 700 feet. Maybe someone misidentified planes heading for Los Angeles. But one thing is pretty clear. They were not pyramids.
Another thing is they're triangles, and he repeatedly uses the word pyramid, 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 and he will not use the word triangle. And one thing with programming, language is super important in any of this stuff, and also search terminology and that kind of stuff is another really important piece of this, and hiding information, which is another argument people have made for why they changed the term from UFO, which is a perfectly good term, to a UAP now. It has to be UAP. I thought that was interesting, but the whole thing is that now when you search for flying triangles or UFO triangle or triangle UFOs, all you get is this stuff now. All the old stuff on triangular UFOs that I've covered before, like TR3B and all that Ed Fouché story and all that stuff, and the Mercury plasma drive and all that stuff, it's gone. It's wiped from the internet. You can no longer find it anymore, and it's like,
you know, it's an interesting clip. I appreciate you playing that. And so it's possible, I guess. Then it raises some other questions. Number one, he selectively edited the footage that he showed. Towards the end of the sun clip, it showed three triangles showing together, and it showed what appeared to be a mass between them. It looked like they were on the tips of a black triangle. It looked like one vehicle. It didn't look like just a light, right? So that he has selectively edited that to show what he wants. I think the other part that bothers me a little bit is you would think, I mean, again, this is the Navy. They use these things all the time. They're looking at it through a scope, right? Wouldn't they know? I mean, you know what I mean?
Yeah, they got some explaining to do about why they've confirmed this video, why this is what's being released and being shown to the public is what's going on behind these closed doors in these Senate Select Intelligence hearings to talk about this stuff. Honestly, it really boils down to, I think, money with a lot of these situations. It's the big money players that are really talking behind the scenes and stuff. From what I'd really love to know what goes on in that behind the scenes meeting with my senators. I try to include some of the financial aspects of this in my in my presentation with regards to the science budget, which Biden has greatly expanded the science budget. And I'm hoping that they do, the government puts more research into this. And I'd mentioned in my presentation as well, kind of like that 1938 Einstein letter, the letter that Einstein wrote to President Roosevelt, to basically warn him about German advances and say that we got to get working on this Manhattan Project and build an atomic bomb. That's sort of basically the letter that I'm trying to send. I think we all should send as our little community right now to the UAP task force, along with this message. There's this big phone home thing that this guy Lewis UFO Celebrity Review is his channel. UFO Celebrity Review. If you guys want to go check that out, he has a big phone home project. I actually called my senator during that, and offered to brief my senator on what I know about this, the briefing that I put together, pretty much with my senator in mind, of what I'd like to look into with regards to a reinvestigation of UAP, including Roswell and other things, and where to look for that information, which military contractors might be the best place to start digging, where the FOIAs of 70 years of information stonewalling has failed to drop any information on this. It's kind of where I stand, where I was coming from on it. But that's certainly interesting that Mick West edited that one clip up, and then he offers that as just what it could be, and it's not necessarily what it was. But then do you have a link to the other video? I want to see the one that was on Fox News.
So you know what?
Actually, let's cut out on this. I think we have some other news and stuff to.
Yeah, well, we're almost at the top. We've got about 4 minutes left. I just pasted the link in there to the Sun video, and that's the original, right? That's the original video. And there is a Fox News one. Let me find that. Actually, that's
I also have some news to announce since we only have 4 minutes left. I got a message this morning from a friend of mine. It was actually Dan Bankert who sent it to me. It was an obituary for a dear friend of ours. And I don't know, Tim, do you want to?
Well, again, I should probably announce that because we haven't officially started yet, right? So
Yeah.
So
I reached out to the funeral home and got a message from like a Google a voice recording, so we can only speak to them on Monday. I also reached out to Mark on Facebook, and I called his phone. It went to voicemail, and the voicemail was full. So that's all I know so far. Hopefully somebody in the group here will be able to confirm whether that's true or not. It supposedly happened on the 13th of April, which was 4 days ago. And the last message he posted on Facebook was 5 days ago on the 11th, or 6 days ago, actually. He's very active on Facebook. So as a
Yeah.
which, but it's at the moment it's unconfirmed.
Yeah, and so I will mention that. So guys, I did post some links in there. Jeremy, the Guardian link that I pasted in chat, that has the statements from John Ratcliffe, and again, he reported directly to the president, and he seems to be pro UAP. He's not saying they're aliens. He's saying it's stuff that we don't understand, right? So, but to me, again, it seems like if they could explain it easily, they wouldn't open themselves up to criticism, right? That's the way I would look at it. If you could write it off as something really easy to explain, you wouldn't put it out there in the news. I mean, that would make them. Again, they've got to do budgets every year. They're not going to expose themselves to look idiotic over something that could be easily explained. And that's one of the things that bothers me about the debunkers, right? There was another one. There was one in the Drive. There was an article in the Drive that just came out where he was talking about. He said it's miniature drones and it's balloons, and I'm like, you know what? If it was that easy to explain, or another one is maybe it's a secret aircraft. The DoD would say, you know what, we've got this. Don't worry about it. Just go away. But what they're saying is, we don't know what this is, so.
Yeah, these guys do some really good reporting, Tyler, and I'm trying to get Brett Tingley on the show sometime next week. Maybe we could see about getting Tyler on as well. That would be great to get. These guys would know about all the stuff that's going on in these programs. They're pretty into that and pretty up on it. But if it's something that's deeper than this that they don't really know about quite yet, I don't know. It's hard to say. There's still theories that we recovered something out in 1947 at Roswell, and it's been hidden at Wright-Patterson all the years since. Senator Barry Goldwater tried to go after it before, as I pointed out in my presentation. So this is all stuff that needs to be looked into, in my opinion. Not just going back to the ATIP stuff, which is super interesting, and these recent Navy videos that were released, but going back to Battelle and the Rand Corporation and some of these older contractors, much older than Bigelow, that have been in this game a lot deeper and already have the facilities. They didn't have to remodify their facility, recently for the ATIP program. They already had these facilities set up and have had these facilities since, the very early days of this stuff.
Yeah. Well, Jeremy, let me, in fact, everyone, let me do this. Let me mute everybody out, and I will do the announcements, and then we will hand it over to the esteemed Mr. Boyd, who is patiently waiting and who has an in-depth slideshow for us. And then I think we're going to have one heck of a Q&A session later on, though. That's for sure. Not just Q&A, but open discussion as well. Okay, so I will mute everyone. And in 3, 2, 1, welcome to APEC. It's April 17th, and I'm your moderator, Tim Ventura. I'd like to thank everyone for joining us on this call, along with everyone watching us on YouTube. In today's session, Michael Boyd will discuss UAPs and gravitomagnetism. Franc Milburn will be talking about UAPs and the Catalina Island incident, and Todd Desiato will present the derivation of gravity from the uncertainty principle. After that, we'll catch up with the latest research from the Falcon space team, and we'll be wrapping up the event with open discussion and ad hoc presentations. A couple of quick reminders, and then an announcement. You can view conference replays, details, and speaker info on our website at www.altpropulsion.com. Again, go to the website, check it out, share it with some friends. Please save your questions for the Q&A session after each presentation. Go ahead and type any of those questions that you have in the chat. We'll go through them after each presenter finishes. I also want to mention, as an announcement, we have an unconfirmed report that Mark McCandlish may have passed away on April 12th. Mark was a good friend. He was a really valuable part of our community, and we were honored to have him speak at APEC late last year. We're going to continue working to try and confirm this. And I hope that this is a mistake, but there is a legacy.com obituary notice for Mark McCandlish in Redding, California. We're just trying to confirm that this is the correct person. So on that note, let me introduce you to our first guest. Michael Boyd has an impressive 40-year career as an engineer and scientist, starting in 1982 at the Hughes Aircraft Company. His expertise has spanned component manufacturing, development engineering in the medical device, microelectronics, telecommunications, semiconductor, and hard drive industries. Michael has a BA in physics from UCSBM and has published research in numerous technical publications, including the International Society for Optical Engineering, the National Institute of Standards and Technology, and the Journal of Vacuum Science Technology. So Michael, welcome, sir. It looks like you're already unmuted. Okay, let me hand it over to you.
Hello, everyone. Thank you for this opportunity to present some of my research today. I'm feeling pretty stoked about it. First, I guess let me see if I can. So do I just go share screen and then run the slideshow? Is that how it works? Let's see here. Okay, can everybody see that okay?
Perfect. Yeah, it looks great. So yeah, go right ahead, sir.
Okay, hold on a second here. I have another, my desktop over here where I see what's going on. I got the chat part on. Bear with me for a second.
Well, and Michael, thank you for sharing this. Thank you for sharing this with us again. I know parts of this you have shared before in the ad hoc presentations, and I'm glad that you found the time to actually give us the entire presentation and walk through on your research, because I know you span a lot of different areas. You're looking at UAPs, you're looking at gravitomagnetism, you're looking at hard drive platters and stuff like that. So thank you, because this is very welcome.
No, I'm like I said, I'm stoked to be able to have this opportunity. So let's see, the first slide. Oh, I see what's going on here. I gotta put the video part of it down. Okay, so what I'm going to start off with is I want to talk about basically I have 3 jobs, and one of the jobs is I'm a physicist, I'm an engineer, and more recently I'm an archaeologist. And as an archaeologist, basically what archaeologists do today, it's not like Indiana Jones. It's more like being a construction worker, except that you don't actually do any work unless you find something. And so, for example, I have my hard hat here that I'm showing, and what I have is these stickers here from different tribes, because when I'm monitoring, what I'm doing, if you look at my image, I don't know if you guys can see it because I'm in the share mode, but if you can see my image, I have this yellow hard hat, and it has these stickers. So one of them says Yosho Dishi, and the other one says Essalon. And so when they're digging in an area that's sensitive, they have to look out. They have to look out for resources, maybe a burial from a prehistoric burial from the past from one of the tribes. And one of the problems that you run into is there's a cultural difference between the tribal groups, and and the archaeologists and the construction workers. So because of that, I had to learn about what's called nonviolent communication. Essentially, when our culture is basically built on this system of what I call reward and punishment. It's like it's built on violence. So basically, if you're good, you get rewarded. If you're bad, you get punished. But in most other species, let us say, it's more built on empathy, because you depend on each other's for your survival more. And because of what happened with agriculture, basically back in the past, there was what was called the agricultural revolution. And that created where we had haves and have-nots. The people that had food, they were the haves, and the people that didn't, they were lesser humans. Okay, and we like to categorize, and that's created what's also called intergenerational trauma. So we learn how to deal with stress from our parents, who learned it from their parents, and so on and so forth. And it's all built throughout our culture, throughout the world, on this system of reward and punishment. And what nonviolent communication is about is love. It's about compassion for each other. It's really, I think if there's any extraterrestrials or whatever out there, that they're afraid of us because we're so violent and our culture is so violent. And if we could learn nonviolent communication, well, maybe they'd be more comfortable with communicating with us. Right now, I don't really see any reason why they would want to be. So, but in any case, nonviolent communication is essentially expression is about you, and empathy is about others. And there's basically 4 principles. There's observation without judgment. There's feelings. How does it make you feel? There's needs. Well, you feel this way because you need something. And then there's requests without judgment. Now, I personally have the most problem with the judgment part. Okay, the without judgment is difficult for me. And I think that's because of our culture. But so I just wanted to first introduce you to this idea of nonviolent communication. Now, what I'm going to do here is I'm going to talk a little bit about my job experience and how it's relevant to this. But first, if you look up here in the top, you'll see there's this link here to my that's to my CV, and I'm going to open that up. Let's see if you guys write that down, you can. What I'm going to do, the reason I'm opening this is I want to show you first, if you don't have your CV on this website, it's something you might consider. And then also I want to show you how it works, because it's a little different from most in that it has, it's real basic, but then there's a tab to pull down. And if it ever opens, maybe, oh, here we go.
Yeah, well, and Michael, I hate to interject, but we're getting to be about 12, 13 minutes in. So,
oh, okay, I'll make this rapid. I don't even know if it's going to work. So let's skip. Okay, so what you hear, this is the relevant, what I thought was relevant. I worked in Santa Barbara Research Center 1982 to 91 as a senior development engineer, fabricating these infrared detectors like you're seeing when you're watching the UAP imagery, like FLIR 1 is a detector device that I probably helped fabricate. And then I got a job in place which was an environmental test lab. So I broke stuff for a living. That was kind of a fun job. And then in 96, 98, I got a job for this test equipment manufacturer for hard drives. And that's where I first discovered gravitomagnetism. And then below that, I have some of my patents. You can see the most recent one in 2019 is a device and method to generate and capture of gravitomagnetic energy. So enough about me. And this, I just thought was kind of funny. It kind of reflects how I feel about academia, let us say. And basically what it says, along with antimatter and dark matter, we've recently discovered the existence of doesn't matter, which appears to have no effect on the universe whatever. So, I mean, what I'm trying to show is that I'm not necessarily right. I mean, I'm just, hopefully my guesses are just more educated. So now what I have here is I'm going to talk about semiconductor diode physics. And this includes a little video here about that discusses how they work. A diode is a semiconductor material with a PN junction connected to two electrical terminals. The P side of the junction has an excess of protons called holes and also called acceptors. The N side of the junction has an excess of electrons called donors.
Junction diode, properties and uses. Formation of the PN junction. The P-type semiconductor has an excess number of holes. Therefore, holes are the majority carriers of charge in P-type semiconductors, as shown. Similarly, N-type semiconductors has an excess number of electrons. Therefore, electrons are the majority carriers of charge in N-type semiconductors, as shown. The combination of P-type and N-type semiconductors results in a junction. This combination has many applications in electronic devices. When a P-type semiconductor is suitably joined to an N-type semiconductor, a contact is established between them and is called a PN junction. Formation of depletion region. The PN junction formed out of the P-type and N-type semiconductor separates P-type semiconductors from the N-type semiconductors. However, because of the contact, some of the electrons from the N side enter the P side. Similarly, some of the holes from the P side enter into the N side. So at the junction, these electrons and holes combine with each other. The hole and electron neutralize each other on such recombination as shown. Therefore, in the region close to the junction, only negative ions are left behind on the P side and only positive ions on the N side. This results in the formation of a narrow charged region on either side of the PN junction. The N-type semiconductor close to the junction becomes positively charged, and the P-type semiconductor close to the junction becomes negatively charged. On either side of the junction, the region D becomes free from mobile charge carriers.
The region D is an event horizon.
On the N-type side of D, no free electrons exist, and the P-type side of D, no holes exist. In the region of D, only immobile donor and acceptor ions exist. The region close to the PN junction is depleted of mobile charge carriers and is called the depletion region. Since on either side of the junction J, stationary positive and negative charges exist, there is an electric potential difference of VD between the edges of 1 and 2 of D. This potential difference VD across the junction is called a potential barrier, as it prevents further movement of holes and electrons.
Now that region D is important because that's or the potential barrier, as it's called, is we'll talk about that more later because that's what we're talking, the barrier we're talking about when we're talking about what's called quantum tunneling or the tunneling effect. So now what I have here is a design specification drawing for my invention, the mass spin valve. This is the head disc assembly. And what you'll see here is on the left here is a pattern of nanobumps and nanopits. This top region is nanobumps. And it's like the top, there's a 40 micrometer times 40 micrometer square nanobump. And that's at 1.8 inches. And then a radius. And then at 1.45 inches, at that radius distance is 40 micron by 40 micron nanopit. And so what I did is I made nanobumps and nanopits with a device called a focused ion beam, which essentially is an electron microscope, but instead of using electrons, it uses ions. To remove material, I used a beryllium ion. To deposit bumps, I used a tungsten ion. I picked tungsten because it's anti-ferromagnetic material. So it shouldn't be, it's kind of like aluminum. You can't magnetize it. And then over here on the right is the disc. And then there's this little device called a slider. It's called a slider because it looks kind of like a sled. And here's a representation of a side view of the slider. The disc is spinning counterclockwise at 500 inches per second. It's roughly 27 miles an hour. And then if you look here, I have two sensors on my device. I have a giant magnetoresistor, which is this little tiny region on the bottom of the slider. And that's a special resistor that's sensitive to changing magnetic fields. On the top of the slider, I have a thing called a piezoelectric crystal. And what that is a crystal, if you tap it, it produces a voltage signal. And so basically I use one to measure the magnetic force or the magnetic field strength, and the other I use to measure the physical motion of the slider. The slider, like you can see, is a little arm that's sitting over the disc as it's spinning. Now this is, I'm not going to spend a lot of time on this, but this is basically examples of my test stand. On the right is what's called a spin stand, and it contains a thing called a spindle, which turns the disc, and then there's, like, on the left you can see more details there. I have like the actuator arm. I show where the head is. Up here on the top left, I show some of the circuitry, the basic circuitry involved in it. But essentially, this is a representation of the test bed. And you'll notice over here on the left, there's a little note, floppy drive. Now, how many people still use floppy drives? That just shows the antiquity of this. So now let's get into the physics of nanogravity. Gravitation is slower than the speed of light in the context of frame dragging. Examine the difference between gravitomagnetic induction and electromagnetic induction. A GMR read head is observed from a 10 micron by 10 micron square bump of around 32 nanometer tall on a hard disk platen, spinning at a constant linear velocity of 500 inches per second. The disk is spinning counterclockwise. So we observe the first electromagnetic induction signal on the left under the GMR sensor. The upward magnetic induction is induced by a 90-degree change in the angle of the edge of the bump at the speed of light. This is followed by a downward gravitomagnetic signal of a bump 1 microsecond later. traveling at the speed of gravity. We observed the downward polarity second electromagnetic, this little pulse here, signal that's on the right of the gravitomagnetic signal as the square nanobump moves under the GMR sensor 0.8 of a microsecond later, traveling at the speed of light. In this example, we observe the gravitational frame dragging is 1 microsecond, which is this time difference between the first pulse and the gravitomagnetic signal. Voltage is in millivolts. Presence of matter moving produces a pull force and a negative polarity gravitomagnetism. This image is a cross-sectional view of the GMR read head with a piezoelectric crystal mounted on the backside of the head slider. The GMR read head is sensitive to magnetic field changes, while the piezoelectric crystal on the back of the slider is sensitive to the physical motion of the head slider. A 10 micron by 10 micron square bump of around 32 nanometers height measured results are shown. On the left, below the cross section, is the piezoelectric glide head signal, where we observe an undampened physical pull against the head slider against the force of gravity as shown. I have the force of gravity is down here relative to the slider. On the, hold on, I lost myself. On the right, the GMR sensor shows a negative polarity gravitomagnetism. And I skipped some. On the left is, okay, on the right, sorry. This infers the presence of matter on the spinning disk produces a physical pull force and a negative polarity gravitomagnetism. In this example, we observed the gravitational frame dragging is again 1 microsecond. The absence of matter moving produces a push force and a positive polarity gravitomagnetism. The image is a cross-sectional view of the GMR read head with a piezoelectric crystal mounted on the back of the side of the head slider with a nanopit on the surface of the disk. A 10 micron by 10 micron square pit of around 52 nanometers depth measurement results are shown. On the left is the piezoelectric glide head signal, where is observed a short dampened physical force, push force against the head slider, against the force of Earth gravity. On the right, the GMR sensor shows a positive polarity gravitomagnetic signal. This infers the absence of matter on the spinning disk produced a push force and a positive polarity gravitomagnetism. In this example, we observe the gravitational frame dragging is again 1 microsecond. This also infers there exist 2 different time frames, one for matter, or the lack thereof, and another for electromagnetism, or EM. Context of space-time moving relative to the GMR sensor. So we have, these are 2 AFM micrographs of the nano bump in the nano pit that I'm showing data from. Atomic force microscope is a device that it's a little nano-sized lever, kind of like the head sits on, but it has a little sharp tip on the end of it. And on the back back of it is one of these little these piezoelectric crystals that goes back and forth. And there's a laser that shines on the tip of the thing, and as it moves, it measures atomic force by using fringes that are measured with a laser, essentially. And it's a way, it's also, if you take that little tip and you coat it with a magnetic material, you can make what's called a magnetic force microscope, which is what I did to calibrate my measurements. So above are the 3D images that were taken with what's called a Park Systems atomic force microscope. And you can see that's where I got the 52 nanometer depth and the 32 nanometer height, is I measured it with a, and so what my hypothesis is, as the pit goes by the GMR sensor and the force sensor, it's creating expanded space-time, because the distance away is only 100 nanometers. It's really close. And the other, the bump does, it's the opposite. It's denser space-time. So and what's going on is we have a change in medium between denser and expanded space-time. We exist in something in between those two. Now, I took all that data, like I showed you at the beginning, from the nano pit disk, and then I normalized it to the magnetic force microscope data. So I could take the peak signal of the GMR readback and say, okay, 1 volt, 1 nanonewton force is equal to 1 volt of readback signal as calibrated from that MFM measurement. And so what I did is that then I take my data and I put it into this plot of force, which is the x-axis, versus volume, which is the y-axis. And that's when I discovered that what I had was a gravitational junction. So by varying the area of the nanopits and the nanobumps on the surface of the spinning disk, the graph of the measured gravitational forces derived from the gravitomagnetic induction signals recorded. A gravitational diode curve is observed for variable area pits and bumps. The P side of the gravitational diode is the acceptor side of the junction, producing positive gravitational induction and a push force, which you can see over here in this area, which is a third order polynomial of a hyperbolic force, like that of a balloon. Now, this is important. This balloon you'll see later when we start talking about UAPs. The N side of the gravitational diode is the donor side of the junction, producing negative gravitational induction and a pull force with a second order polynomial of a parabolic, like normal gravity. Normal gravity is a parabolic. Now we're going to talk a little bit about gravitation is faster than the speed of light in the context of quantum tunneling. Tim, how's my time?
Oh, so just about halfway there, but if you run over, that's fine, because we've got a long Q&A session.
Okay, cool. Okay, so so in the barrier is where this entanglement, the barrier is this part in the middle. And in the barrier is where the entanglement occurs, but the protons don't really move. They don't go anywhere. They vibrate. You might say they sing and dance to the same tune. Quantum tunneling is an example of a quantum entanglement phenomenon. Quantum tunneling is the quantum mechanical phenomenon where a subatomic particle passes through a potential barrier, again, e.g. an event horizon, instantaneously. The hypothesis is that matter, e.g. mass or gravitons, as having properties of both waves and particles. Notice again, this is a type of event horizon. So when we talk about a barrier, we're talking about an event horizon. Now I have this little video that I found, which I think is really excellent in explaining how quantum tunneling works. But the important thing I want you to notice, pay attention to, is there's the signal that gets through the barrier. One hypothesis is this is what's called a pilot wave. And it's essentially The hypothesis is we're back from the future. Time is retrocausal. So the future is pushing back. And if you watch this closely, you'll notice that she talks at the end about this phenomenon.
Have you heard that quantum mechanics is impossible to understand? You know what? That's what I was told too when I was a student. But 20 years later, I think the reason so many people believe one cannot understand quantum mechanics is that they are constantly being told they can't understand it. But if you spend some time with quantum mechanics, it's not remotely as strange and weird as they say. The strangeness only comes in when you try to interpret what it all means. And there's no better way to illustrate this than the tunnel effect, which is what we will talk about today. Before we can talk about tunneling, I want to quickly remind you of some general properties of wave functions, because otherwise nothing I say will make sense. The key feature of quantum mechanics is that we cannot predict the outcome of a measurement. We can only predict the probability of getting a particular outcome. For this, we describe the system we are observing, for example, a particle, by a wave function, usually denoted by the Greek letter psi. The wave function takes on complex values, and probabilities can be calculated from it by taking the absolute square. But how to calculate probabilities is only part of what it takes to do quantum mechanics. We also need to know how the wave function changes in time, and we calculate this with the Schrödinger equation. To use the Schrödinger equation, you need to know what kind of particle you want to describe and what the particle interacts with. This information goes into this thing labeled H, which physicists call the Hamiltonian. To give you an idea for how this works, let us look at the simplest possible case. That's a massive particle without spin that moves in one dimension without any interaction. In this case, the Hamiltonian merely has a kinetic part, which is just the second derivative in the direction the particle travels, divided by twice the mass of the particle. I have called the direction x and the mass m. If you had a particle without quantum behavior, a classical particle, as physicists say, that didn't interact with anything, it would simply move at a constant velocity. What happens for a quantum particle? Suppose that initially you know the position of the particle fairly well, so the probability distribution is peaked. I have plotted here an example. Now, if you solve the Schrödinger equation for this initial distribution, what happens is the following. The peak of the probability distribution is moving at constant velocity. That's the same as for the classical particle, but the width of the distribution is increasing. It's smearing out. Why is that? That's the uncertainty principle. You initially knew the position of the particle quite well. But because of the uncertainty principle, this means you did not know its momentum very well. So there are parts of this wave function that have a somewhat larger momentum than the average, and therefore a larger velocity, and they run ahead. And then there are some which have a somewhat lower momentum and a smaller velocity, and they lag behind. So the distribution runs apart. This behavior is called dispersion. Now, the tunnel effect describes what happens if a quantum particle hits an obstacle. Again, let us first look at what happens with a non-quantum particle. Suppose you shoot a ball in the direction of a wall at a fixed angle. If the kinetic energy or the initial velocity is large enough, it will make it to the other side. But if the kinetic energy is too small, the ball will bounce off and come back. And there is a threshold energy that separates the two possibilities. What happens if you do the same with a quantum particle? This problem is commonly described by using a potential wall. I have to warn you that a potential wall is in general not actually a wall in the sense that it is not made of bricks or something. It is instead just generally a barrier for which a classical particle would have to have an energy above a certain threshold. So it's kind of like in the example I just showed with the classical particle crossing over an actual wall. But that's really just an analogy that I have used for the purpose of visualization. Mathematically, a potential wall is just a step function that's zero everywhere except in a finite interval. You then add this potential wall as a function to the Hamiltonian of the Schrödinger equation. Now that we have the equation in place, let us look at what the quantum particle does when it hits the wall. For this, I have numerically integrated the Schrödinger equation I just showed you. The following animations are slow motion compared to the earlier one, which is why you cannot see that the wave function smears out. It still does. It's just so little that you have to look very closely to see it. I did this because it makes it easier to see what else is happening. Again, what I have plotted here is the probability distribution for the position of the particle. We will first look at the case when the energy of the quantum particle is much higher than the potential wall. As you can see, not much happens. The quantum particle goes through the barrier, it just gets a few ripples. Next, we look at the case where the energy barrier of the potential wall is much, much higher than the energy of the particle. As you can see, it bounces off and comes back. This is very similar to the classical case. The most interesting case is when the energy of the particle is smaller than the potential wall, but the potential wall is not extremely much higher. In this case, a classical particle would just bounce back. In the quantum case, what happens is this. As you can see, part of the wave function makes it flow to the other side, even though it's energetically forbidden. And there is a remaining part that bounces back. Let me show you this again. Now remember that the wave function tells you what the probability is for something to happen. So what this means is that if you shoot a particle at a wall, then quantum effects allow the particle to sometimes make it to the other side when this should actually be impossible. The particle tunnels through the wall. That's the tunnel effect. I hope that these little animations have convinced you that if you actually do the calculation, then tunneling is half as weird as they say. It just means that a quantum particle can do some things that a classical particle can't do. But wait, I forgot to tell you something. Here you see the solutions to the Schrödinger equation with and without the potential wall, but for otherwise identical particles with identical energy and momentum. Let us stop this here. If you compare the position of the two peaks, the one that tunneled and the one that never saw a wall, then the peak of the tunneled part of the wave function has traveled a larger distance in the same time. If the particle was traveling at or very close by the speed of light, then the peak of the tunneled part of the wave function seems to have moved faster than the speed of light. Whoops! What is happening? Well, this is where the probabilistic interpretation of quantum mechanics comes to haunt you. If you look at where the faster than light particles came from in the initial wave function, then you find that they were the ones which had a head start at the beginning. Because remember, the particles did not all start from exactly the same place. They had an uncertainty in the distribution. Then again, if the wave function really describes single particles, as most physicists today believe it does, then this explanation makes no sense, because then only looking at parts of the wave function is just not an allowed way to define the particle's time of travel. So then how do you define the time?
So to simplify David Bohm's hypothesis, there is evidence for a pilot wave, and it's pushing back. It's pushy. So how else do you get something from empty space? So that kind of leads to what I call the postulate for the theory of everything. I was going to use a Sharpie and put this on my big toe, but then I looked at my toe and decided that might not be a good idea. And I went with this instead. So the postulate of theory of everything is gravity is a property of matter, but not a property of electromagnetism. The hypothesis is that protons, what are called holes in the semiconductor junction, and all forms of matter in their presence in our location in the universe, this is the source of the attractive force of gravity in the vicinity of matter. The other novel thing is the absence of matter produced a repulsive anti-gravity force that is much weaker than gravity force in balloon light. Electrons, however, do not contribute enough mass to really affect gravitation in any significant way. The geometry of matter, or the lack thereof, caused a force field to be produced that I could measure. Now I'm going to talk a little bit on black holes, general relativity, and special relativity, GR and SR. Excuse me. General relativity, GR, is the theory of gravitation that was developed by Albert Einstein between 1907 and 1915. According to general relativity, the observed gravitational attraction between masses, something happened. Sorry. According to general relativity, the observed gravitational attraction between masses results from the warping of space-time and time by those masses. General relativity is developed into an essential tool in modern astrophysics. It provides the foundation for the current understanding of black holes, regions of space where gravitational attraction is so strong that not even light can escape. Okay, this next paragraph I'm stumped at. I don't know how to say this word in German. So I'm gonna skip it and say Einstein's On the Electrodynamics of Moving Bodies was received on the 30 June 1905 and published 26 September of the same year. It reconciles Maxwell's equations for electricity and magnetism with the laws of mechanics by introducing major changes in mechanics close to the speed of light. This later became known as Einstein's special theory of relativity. Consequences of this time-space frame of moving body appearing to slow down and contract in the direction of motion when measured in the frame of the observer. This paper also argued the idea of a luminiferous ether, one of the leading theoretical entities in physics at the time, was superfluous. There's still a lot of controversy over that one. The manifold of events in space-time is a substance. This has also been called what's in philosophy space-time substantialism. Einstein focused too much on the speed of light and not enough on the holes all around him. That's where the gravitation is. That electromagnetism is in space-time IA, let's call that EM space-time. And this is what Einstein's On the Electrodynamics of Moving Bodies describes, which reconciles Maxwell's equations for electricity and magnetism with the laws of mechanics by, again, introducing these changes to mechanics close to the speed of light. This later became known as Einstein's theory of special relativity, SR. And then if you look below here, I have in fine print, unfortunately, and it's in German, all the links, all the papers that I'm referencing the actual papers here for you. That gravitation is in space-time B, let's call that space-time B general G space-time, and that's what Einstein's general relativity GR describes. According to general relativity, the observed gravitational attraction between masses results from, quote, warping of space and time by those masses. When I write about this manifold of events in space-time, our substance, which exists independently of the matter within it, this manifold of events in space-time is the property that makes time as we measure it the emergent positive arrow of time. Therefore, time is a vector whose direction depends on your position in our universe, which is created by a change in energy states between gravitation to electromagnetism and vice versa. So that was a lot of space-time depth. So I thought this would be a good point to pause. If we have time, maybe take a break or What do you think, Tim? Tim? Is there anyone there? Hello? Hey, I see you. Okay. I'm just making sure that I'm not talking to dead air. Okay, I'll keep going. Thank you. Okay, now what I'm going to do is show some examples of natural gravitational diodes. It's not basically this is something I believe is just part of nature, and so I have 4 examples of this. The first is what's called ATP synthase. It's what powers life. It takes protons and it uses the spin of protons to create power in the cell. The second is positive terrestrial lightning in the form of elves, blue jets, and sprites. The third is solar flares, the relationship between the time it takes for the solar flare to hit the Earth, about 7 minutes, and the coronal mass ejection to reach the Earth 2 to 3 days later. But there's also we've also find an example of this later, which I talk about, of how that there's a pre-signal, or like we saw with the tunnel diode. It goes on with the CME as well. The fourth thing is a supermassive black hole centered local universe, which is sort of my hypothesis. So do protons power life on Earth? In the semiconductor, the flow of protons is known as hole flow, while the flow of electrons is known as an electron flow. It's because of the movement of protons or holes that ATP synthase powers everything. That's alive on Earth. Animal, vegetable, even fungi have ATP synthase. This image here on the left is a live ATP synthase. The scale here is about 100 microns. So that little ATP synthase is rather small. A postulate is gravity produced by the spin of protons is the basis of all life on Earth, using this gravitational motor using protons to power protein motors in every cell on this planet. I have this little video of ATP synthase represented through human motion. The molecular motor moves protons, which are here shown by H+, the power plant in the cell. Now, a few things to note. In this case, there's a barrier too, and it's a membrane. And it's an event horizon, and it's in your cell. And this is what it looks like using human motion. You'll notice at the end here, it spins backwards. I think that's cool. Okay, next, let's talk about positive terrestrial lightning in the form of blue jets, sprites, elves, and accelerated protons. Now, here we see a blue jet, and it's going up to like an altitude of 50 kilometers. Here we see sprites, which are going up to like 90, 80, 90 kilometers. And then elves, they'll circle. And those are up at around 100 kilometers. Now, typically you'll see the elves first, and they don't talk about elves in this little short, but you'll see the elf and then you'll see some blue jets.
A view from above is helping scientists figure out how blue jets are born.
See
this
the elf?
Is a visualization of one over the Pacific Ocean. Blue jets are like lightning, but they shoot straight up from storm clouds into the stratosphere. The gases there give the lightning its blue color. But it's the flashes that appear before the blue jet that have scientists excited. They think these flashes somehow cause blue jets. But what causes the flashes is still a mystery.
So my hypothesis is blue jets are expanded space-time or an anti-gravity representation electromagnetically. So something's pushing up. Next are sprites, which are also a form of positive lightning. And this little video is about
This
that.
is an incredible video of a sprite. Now, sprites have been captured on film and images a lot in the history of humanity or modern man, but they've never been captured with a 10,000 frames per second camera on video like this. And you can really see it's an incredible sight. And it was captured in Japan. And what a sprite is it's basically an electromagnetic charge that's up in the upper atmosphere above a lightning storm. And so what this is going to allow for is researchers to look at this video and maybe use this technique to capture more sprites in the future and learn how a sprite affects lightning and how a sprite is created and what causes it. It's really incredible. There have been pictures of sprites, video of sprites taken from way above from the International Space Station before, but again, never in this detail. And you can just really see its beauty and its power and the fact that that is definitely something that neither you nor I has ever seen before. This is an incredible video of a sprite. Oh. Now, sprites have been captured.
Looks like it started again. So the next thing is this relationship between a solar flare and a coronal mass ejection. A solar flare isn't just an explosion of hot gases. It pushes out waves of light at the speed of light. That includes light we can't see, including radiation in the form of X-rays and gamma rays. But another solar event called a coronal mass ejection can cause serious problems for electrical systems on Earth. During a CME, the fluctuations in the sun's magnetic field cause a large portion of the surface of the sun to expand rapidly, ejecting billions of tons of particles out into space. Unlike a solar flare, a CME doesn't produce intense light, but it does produce a magnetic shock wave that extends billions of miles out into space that takes days to reach Earth as compared to 7 minutes for a solar flare. If the Earth is in the path of the shock wave, our planet's magnetic field will react to the event, and the magnetic shock wave from the sun will cause the alignment of the Earth's magnetic field to shift unpredictably. So besides the proton and its bigger sister, the black hole, the mass spin valve or gravitational rectifier occurs in the relationship between the solar flare, photons of EM, and the coronal mass ejection, ECME, gravitation, that follows showering the Earth and sun's proton flux. Now, interestingly, solar flares are known to affect the radioactive decay rate, it turns out. And then there's this article that I found that talks about it, the strange case of solar flares and radioactive elements. On December 13, 2006, the sun itself provided a crucial clue. When a solar flare sent a stream of particles and radiation towards Earth, Purdue nuclear engineer Ger Jenkins, who measured the decay rate of magnesium-54, a short-lived isotope used in medical diagnostics, noticed the rate dropped slightly during the flare, a decrease that started about a day and a half before the solar flare. This is an example of the sun's anti-gravity pre-signal, back from the future again. And here's a little video about that.
Thunderbolts Project at thunderbolts.info. For many years, a scientific controversy has been brewing far from the spotlight of mainstream media. How constant are physical constants? For decades, the scientific consensus has been that true constants, such as the speed of light and the gravitational force, remain unchanged over time. But in recent years, more and more evidence has challenged this assumption. A telling example is now posed by observed changes in supposedly constant radioactive decay rates in relation to solar flares.
In 1904, Ernest Rutherford wrote the book, Literally, on radioactive decay. In this book, he states, in no uncertain terms, the constancy of the rates of radioactive decay. This allegation was initially shown to be consistent with experiment, and so was generally accepted, not to be double-checked for another 8 decades. It was only 3 decades ago that a rogue experimenter from Brookhaven National Labs published the results of a 4-year study into the decay rates of silicon-32 and chlorine-36. His results were astonishing. He found a seasonal variation of about 0.1% in silicon and about 0.3% in chlorine, in addition to a monthly variation. Physicists of the day were not amused. How could radioactive decay rates, long known to be constants, possibly vary?
At present, physics has no mechanism for radioactive decay. It's just a probabilistic theory. And very early in the piece, when Ernest Rutherford said the decay rates appear to be constant, this was taken as a license for geologists in particular who've been looking for means to date the age of the Earth to suddenly register geology as a hard science instead of a descriptive science like geography. And ever since that time, any anomalies in decay rates and so on have tended to be swept aside.
The Brookhaven National Labs report caused a small yet intense splash at the time, but discussion on the topic ceased for the next 12 years, and they were largely forgotten. In 1998, the PTB in Germany broke the silence by announcing the results of a 15-year study. Seasonal and monthly variation was confirmed in radium-226. Only 3 years later, Falkenberg announced a seasonal 0.37% variation in hydrogen-3. As if the announcement of annual and monthly cycles weren't enough, nature had yet another surprise in store for a pair of Purdue researchers.
While searching for new methods of random number generation via nuclear decay, Jenkins and Fishback recorded 3 drops in manganese 54 counts of about 0.1%, corresponding with the 3 December 2006 solar flares.
One of the effects that was discovered was on the night side of the Earth, the radioactive decay decreased roughly a day before a flare appeared on the sun. And this effect was noted a number of times, so it was reproducible. The question then was, how do we get an effect happening on the other side of the Earth, on the night side of the Earth, away from the sun, being registered through the Earth?
The Purdue researchers who discovered this correlation initially tried to avoid speculating about this problem and published just the correlation, but their submission was rejected on the grounds that there was no known mechanism for radioactive decay counts to decrease in anticipation of a solar flare. Being forced to come up with a mechanism, they were later able to publish a paper where they suggest that a massive increase in solar neutrino production prior to the flare is responsible for the decreased counts. The reasoning is that the neutrino weakly interacts, and beta decay is via the weak force. Unfortunately for that theory, it was already established in 1998 that variation is present in substances which alpha decay, which is via the strong force. Neutrinos can't be the effector. So are there better explanations to be had in an electric universe?
The point is that all matter is connected in the universe. All of this suggests that it is much simpler than the neutrinos. It is this direct connection between all matter in the universe. And if quantum theory is telling us anything at all, it's telling us that it's due to resonant effects in matter, so that the atoms that are disturbed on the sun leading up to a solar flare, that disturbance, that change in the resonance of those atoms is available to radioactive atoms on Earth. In other words, this direct connection can invoke a change in decay rate. And this appears to be what's going on. And when it comes to quantum resonance effects, it also suggests, and this has been borne out by some experiments which have been forgotten about, and that is that low frequency electromagnetic resonances would induce changes in radioactive decay. So what we're looking at there is being able to influence the dance of the nucleus, if you like, by sending in a signal which beats with that nucleus. And in the process can either increase the instability, that is, increase the radioactive decay rate, or slow it down depending on the interaction. It does give us the opportunity of thinking about getting rid of radioactive waste in a more sensible and simple fashion than trying to bury it. This means many things to science. It means that quantum theory...
Well, now let's go to some evidence for central black hole universe. The black hole is a type of mass spin valve or gravitational rectifier, which is best described as a gravitational equivalent of a semiconductor junction, a gravity diode. The technical description is what's called a Maxwell's demon in thermodynamics. It's called that because it violates the second law of thermodynamics, i.e. entropy. Now, this is some evidence for a central black hole. These two perfectly concentric Einstein rings in the universe's electromagnetic microwave cosmic background, as reported by Sir Penrose in 2010, shows we exist in the jet of a supermassive black hole. Otherwise, we wouldn't see them at all. If we were off to the edge, we'd only see part of it. And the source of the paper, the Penrose paper is at the bottom of the page here. I've included the link. Supermassive black hole centered local universe. Space-time is a substance that flows, and in a certain reference frame, a black hole's jet, it expands to an outer event horizon, and in others, moving towards the black hole's inner event horizon, it contracts. We assume there's no zero time. Time as a direction, and space-time is dynamic, always moving inward or outward, depending on your frame of reference. Now, this image source I have here is a video called Cosmography of the Local Universe at 14 minutes and 20 seconds into the video. And there's a link there to the bottom. It's a real short one. The image of our local universe above shows that space-time is a substance and our universe is a gravity diode. It flows from the past, shown on the left, and into the future, shown on the right, and back again. The region on the left is denser space-time. The region on the right is expanded space-time. The expanded space-time region is actually pushing back against the past. This suggests that our region of space-time is a superposition of the past, denser space-time, and the future, expanded space-time in the here and now. Wait a second. So now I'm going to try and connect this all together for you. Now I don't know if any of you folks know, probably heard of Hal Puthoff. Hal wrote this paper back in 2010 called Advanced Space Propulsion Based on Vacuum. What is it? I'm going to try and open this thing. Basic hypothesis, here we go. I have this video where he describes the harmful space-time metric engineering consequences. Now, how do I get it to go to the video? I guess I escaped from this.
Is there anything you can learn from this that can help us in terms of evaluating observations in the world associated with unidentified aerial phenomena? I'll just give you one example. I have about 1,000 I could give, but that would take a
You guys can't see the video, right?
In this room, most of the electromagnetic energy you can't see. Why? Because it's in the infrared in the form of heat.
Okay. Let's just go back. Is Tim, are you there?
Yeah. What can I help you with?
What do I do to, I'm trying to show this video of Hal Puthoff, but.
Oh, yeah. And so Todd typed in there, he said, move the video to the same monitor. So it may be displaying on a different monitor.
Yeah, first I can't see. Okay.
And I should mention that we're at 111 right now too.
Okay. Yeah, I'm going to skip it. I just need to get back to the PowerPoint, I think. Let me go back to where I was. I'm sorry about that.
No, but you're doing great. Thank you for presenting this. You have a ton to go through. So,
yeah. Okay. Now I'm back. Let's see. Just insert.
Intervals project.
Okay. Now. Okay, let's just focus a little bit about this slide. So what I did is I took this table out of Hal's paper, and basically the hypothesis is this. denser space-time. In denser space-time, which is like a typical stellar mass. So say we're on the sun. Time gets slower. I mean, time slows, but length gets shorter. And that's a gravitational effect. So, I mean, when you're on Earth and you're using your GPS, the GPS has to correct for the fact that the satellite in orbit, time is faster up there than it is down here. Because on Earth, we're in this gravity well. Now, expanded time is the opposite of that. It's where, think of like emptiness, okay? Time, think of the protons are like moving farther apart for the same area. And that expanded time shrinks, length dilates, and that's where you have this pushy anti-gravity effect. So if you look over here at his table, he describes that. He has on the top here variables, the stellar mass, typical stellar, and the space-time engineering metric. Space-time is where you're creating expanded space-time, which is what I think is going on with the Tic Tac. So basically, in one case, time slows, in one case, time's faster, in one case, length stretches, in one case, length shrinks. So now I was talking to Hal a little bit about, I was exploring time travel in the discussion with Hal. Let's assume the speed of light is our fixed time reference. We'll call that t equals 0 on the right. That's our first electromagnetic pulse. Let's assume that that's fixed. That doesn't change, whatever the reference frame, whether expanded or dense or space-time. With expanded space-time, time shrinks and length dilates. So an anti-gravity pre-signal would signal. We observed this effect for our 10 micron square nanopit. As shown, you can see there's this pre-signal here. Right there. Likewise with denser space-time, with our nanobot. Time dilates, length shrinks. So a post-signal would be observed. We observed that effect here with our nanobump nanopits. Now this is where we get into the Tic Tac space-time metric engineering GR effects. Greater G-force means times dilates, length shrinks, gravitational energy, while lower G-force means time shrinks, length dilates, anti-gravitational energy. This is based on the principles of general relativities, Einstein's theory of geometric gravitation, and the data. Now what we have here above is some frames I captured from the Tic Tac video from the Navy. And you'll notice that over here, this is an important number to pay attention to. This is the magnification. Most of these effects that I observed were at the magnification of 1. At 2, the infrared sensor's field of view decreases, and the bandwidth or the spectral characteristics change too. So now what I'm going to do here is using my data and Hal's hypotheses, I'm going to try and explain what we're seeing here. You'll notice over here, there's on this top, that's our balloon, our anti-gravity balloon. We're going to drill down on some of these other things. Over here is an area where it's brighter. That means there's denser space-time there. Over here, this anti-gravity region is expanded space-time. Over here on the left, this region is also expanded space-time. Then we have this kind of interesting region where it's kind of a mixture of the two. In your junction, in your semiconductor junction, in the depletion region is where this charge exchange goes on, which is called generation recombination mechanism, where the different charges, the positive and the negative, are exchanged. And that's what's going on in the semiconductor. And my hypothesis is that's what's going on here in this region. Now let's drill down on this a little more. Over here, let's start with, we have our Tic Tac. And then here we have our dark torus shaped balloon. Let's go back to that and look at that balloon. Watch it. It's rotating counterclockwise. Now, we also, so we have under the house, what's happening here? Under House hypothesis, this is expanded space-time. This is what I call Boyd's anti-gravity balloon. It's the P side of the gravity diode. These dark regions to the left of the UAP, the expanded space-time, P side. Then there's this small, it's just kind of interesting, there's this little oval shaped thing that appears to be rotating clockwise below the UAP, but it's dark, so that makes it the P side. And then here's this balloon-shaped brighter region with moving darker regions to the right and under the UAP is warmer on the IR sensor and appears as a, what I said, generation recombination region. And then the balloon-shaped brighter region to the right of the UAP is warmer on the IR sensor. And this is under Puthoff's hypothesis is the denser or the N side of the gravity diode. Now, this next slide is Tic Tac space-time warp drive special relativity effects. Exactly. So above the UAP is the anti-gravity balloon. The left of the image is where a wormhole is open, and on the right side is where the UAP is space-time engineering what I call gravitational bow, like a bow and arrow, where the UAP is the arrow, and the video shows the arrow being released. That's the warp drive. So also notice, I notice that mag here is 1 throughout this. And when the thing at one point, that balloon disappears, and we'll drill down on that a little more later. So now let's talk about some of these special relativity features. Now I noticed that this Tic Tac wasn't going straight. It looked like it was going like spinning like this. And that's what I'm representing here to show that it's somehow using angular velocity to create this expanded space-time situation where time shrinks and length dilates. You can see you can see over here how small it is. And then look at how its shapes change depending on the direction. So like when it starts to turn around, it looks like it shrinks again. And then here it looks like it's almost twice as long. So I believe those are special relativity effects that we're observing. And it's using the fact that angular velocity, omega, this is little omega, is not constant using this loop-de-loop. There's an angular acceleration in which the angular velocity changes. In the equation form, angular acceleration is expressed as alpha equals delta omega over delta t, where delta omega is the change in angular velocity and delta t is the change in time. If omega increases, then alpha, or the angular acceleration, is positive. So it's using this loop-de-loop to create a positive acceleration. Now I'm going to drill down. Basically, what I have here is little individual slides, and I'll go through this pretty quick. But here we have dark torus-shaped balloon rotating counterclockwise above the UAP, dark region to the left of the UAP, small dark oval-shaped balloons rotating to the right below the UAP. Basically, those same things we saw before. Here's another one. You notice these changes. You can see the rotation there. It's still. Now, the dark torus-shaped balloon above the UAP disappeared. UAP appears to be moving at a high rate of speed. Look at how that shape changed. It looks like it's spinning around. And then, right after that, the IR detector array appears to be saturated by heating the detector array fan out. The detector sits on this metal mesh, let's say. That's called the fan out. And somehow that's getting hot. And so the detector saturates. But the odd thing is it's in a cryogenic vacuum chamber and it's cooled. So how does it get in there? Then right after that, it disappears from the sensor, it goes black. And then we start to see that it appears again, but look at how shrunken it is. It's like tiny. And notice that how the background's kind of saturated, kind of like it's trying to cloak itself so it won't be seen. Again, next one, still there. Notice the mag change. It's 2x now. 2x. It moved over. Now it's moved it left and up. But notice it's like it's trying to avoid being detected. And then again, and now you notice that the lock from the sensor detector, that's what those little hatches are. And it shrinks again, gets more saturated. Keeps doing this for a while, for several frames. Now, it starts to look like it's moving really fast again, and it shrank. And the balloon, the anti-gravity, notice these features are showing up with the balloon and it's like it's getting ready to fire up the thrusters or something. And then it goes black, changes, and then it goes totally black. And now it's coming back. Now let's go back up to that one. Look at how small that is. Now it's almost like it's faced towards us, and then it turns. And now this is where it starts to go into this loop-de-loop thing that I was telling you about. And now watch, it's doing something. And now it takes off like that. So now this is another odd thing I captured. The Tic Tac seems to be hitting a EMP, sending an electromotive pulse. It hit the aircraft, and it saturates the IR detector array. And you can watch, you can see that. So now that's my presentation. Only thing I was going to show you guys is what my next step is with this. Is I have a 5th patent that has been published, and I'm waiting to get granted to use my invention for what I call quantum gravity cryptography. And what you have here, this little image shows your hard drive has this region in the center where your disk, the head slider, sits when you're not using it. It's called the landing zone. And it has these little nanobumps that are made with the laser. And so what this device does is it uses that landing zone to create an immutable key, what's called a private key, public key pair. And so basically this is what it does. The key pair requests by the system. A map is made of the hard disk texture zone. The map data is split up into sections. A single section is arbitrarily selected. A public key is derived in an algorithm. A public key is available for use. The location of the private key is stored in memory. The public key is used for access requests. The algorithm for deriving the public key is applied in reverse. The private key location is loaded from memory. The hard disk texture at the private key location is read by the Gravitomagnetic sensor for the private key. Do they match? Output of not authenticated if they don't, output of authenticated if they do. And that's it. Now, I did notice a little chatter about Dr. Tajmar, and I wanted to share some of my communications with Dr. Tajmar, starting with this first one, where I basically tell him how much I appreciate his work, and mention that basically it's mentioned in my patent on page 1 and 2. And he was very, I would say, he didn't necessarily think what I was doing was what he was doing, but he was very supportive, and I have a lot of respect for him. So I just thought you guys might want to see this. Just spend a couple minutes. I'm explaining to him how things work, like I just told you now with the landing zone. I explained that. Basically, he was asking how I knew it wasn't electromagnetism. Is one of the reasons I knew is because I could measure it from nanobumps made of glass. Essentially, glass. That's what's different. It's not electromagnetic. It's a actual physical property of the presence or absence of matter. And like here, I shared with him some data from, this is like what texture zone image looks like, 50x, 2000x. And he was asking me if it was a chasm, what do you call it? The vacuum energy, sort of like Hal thinks it's the vacuum energy. But I asked Hal about, well, does the vacuum have a band gap like a semiconductor? And he didn't think it did. So I mean, obviously we can't agree on everything. It's by disagreeing that we figure out what's actually going on. So, and so, and the last but not least is questions and answers. And so I basically, part of my belief in nonviolence is, basically we're all seekers of truth. We're seeking to find out the truth, and that's a dialogue, not a debate. A debate, is one where opposing arguments are put forward, and it's more important to be seen as correct than defining the truth. And so I'm looking for finding the truth, and I need all the help I can get. I don't think I got any monopoly on the truth, that's for sure. And now let's leave it with that. I look forward to your questions.
Well, Michael, thank you. And so let me do this, actually. Let me mute you out really quick. And what I'm going to do is put it on gallery view. And everyone, please give Michael Boyd a giant hand. Thank you, sir. That was enormous and remarkable presentation. I know you've done parts of that before. So, okay, so let me go back on speaker view. And now I will, okay. Okay, so Michael, I'll ask you to unmute, and I will, let's go to questions. Okay, and let me see.
I hear crickets.
Yeah, oh, no, you know what? That's me, actually. It's not giving me the... Ah, there we go. Okay. Okay, so that, yeah, it hid my menu. I'm sorry about that. Okay, so let me see. I have a bunch of them in here. Let me see. So Richard Mueller had a bunch. Richard, do you want to go?
Yeah, there you go.
If he's in here still. You know what? He may not be in here anymore.
Go next.
Okay. Let me see. Ah, okay. Let me see. Paul Murad, sir.
Yes, I have some questions about these things. These bubbles, for example. I would assume if they had some propulsion capability, the bubbles would stay, close to the UAP. They don't move. Now, the question I have is you show some bubbles there and bubbles that aren't there. I'm curious if the direction of the aircraft is in the same direction or if it went to 90 degrees. And my viewpoints are
90 degrees, 90 degrees. The balloon above the UAP is to counteract the force of gravity pulling the UAP down. It's literally like a balloon. You know, it's a buoyancy that's keeping the thing aloft.
Yeah, but what I would assume is that if there's a bubble involved, it would stay with the UAP and not in a location out there. So what I'm suggesting here is that this might be an artifact.
It did stay with the UAP, except when it actually moved at a certain velocity to the left. At that point, it disappeared. And the other complicating factor for me, just so you know, was they would switch back and forth between 1 and 2 mag, and you wouldn't see these effects in the double mag because the field of view of the detector is now 1/4 of what it was before.
Okay. I guess the one question I have is, in terms of these bubbles, is there any idea how to figure out what the electrical field is or the magnetic field?
Well, we know it's a positive magnetic field.
Why?
Well, because the Earth is considered a negative magnetic field relative to it.
Well, the Earth is a dipole.
Well, not when you're sitting out there in the air. It's like the Earth it's not electromagnetism. You can't really consider it electromagnetism. It's not like
well, wait a minute.
Negative charge.
Can you say that? Because, first you're talking about gravity magnetism, and then now we're talking about the effects of it. And then how could you say that it's not electromagnetic?
Because I could, I would suggest you look at my patents, and I have all the figures there that show it. But basically what I could do is I could take and vary the magnetic field direction, because see, it's a magnetic recording disk. And so if I wrote with a positive magnetic field on the surface, it would make a positive field direction on the surface of the disk. I could also
so then you got to say that the gravitation is affected by magnetism, right?
Well, not
Come on,
directly,
come on.
indirectly.
Oh,
It's a byproduct of magnetic. The gravitomagnetic induction has electromagnetic effects at the edges, is what I would say. But it's not the same thing. I can change the direction of the electromagnetic field without affecting the direction of the gravitomagnetic field, is the simple answer. And the other reason I know is because a piece of glass will produce the gravitomagnetic field, but no electromagnetic field. There's no little pulses with a piece of glass. Follow? It's not, there's no edge.
No, I don't follow that.
I guess I could show, if I could show them.
Let me, if it's okay, let me move along. Because we're yeah, and I'm sorry about that. Actually, I had a quick one too. If I could ask you to elaborate. Someone had mentioned, and it may have been an APEC, it may have been in another conference. They had said, in their view, there was no such thing as anti-gravity. There was only positive gravity, and that a Tic Tac would create lift by creating positive gravity above it. It sounds like when you describe this bubble, it sounds like that might be what's happening. Is that what you're?
Yeah, positive gravity. Gravity, to be anti-gravity is positive. Gravity is negative. It's a negative direction, field direction, and one is a positive repulsive field. So yeah, he's right. But what Hal's addition, Hal put us adding to it, is that the positive gravity is a different kind of space-time. It's expanded space-time. The negative gravity, when you're in a stronger gravitational field like a star, that's negative gravity, not positive. It's stronger negative gravity, and that's why you see GR effects like time slows down on the planet Earth compared to outer space.
So it's possible then that and again, I'm not using a good thought example, but it's possible that the UAP is, instead of pushing against the Earth to stay aloft, it might actually be pulling itself up.
Exactly. It's pulling itself up. And so essentially when it's creating a warp drive, that's what it's doing. On the left side, that dark region, it's creating that pull field. It's creating that expanded field. And then on the right, where you see the lighter, the brighter regions, that's where the gravitational field is getting stronger. So one side it's weaker, and one side is stronger, and it creates the mystery in my mind is the bow. How does it pull the bow? How does it create this buoying force? And I kind of thought about it. It's kind of like if remember when you were a kid, you'd go on the whirly-go-round in the park, and you'd go run around the edge, and then you'd get on it and it'd spin around. And then if you got off, you'd be all dizzy. Do you remember that? Well, think of that. Some of them, they have like a bar that goes to the center. And if you got that thing spinning around really fast and you're at the edge, and then there's four of you and you all pull yourself to the center, what happens? The thing goes faster, okay? That's how it's using torque basically to make the thing spin up. Well, I think that's what's going on with the UAP. It's doing that to create this acceleration that it needs.
Okay.
Kind of like in the video, remember the movie Back to the Future, when they got in the DeLorean and then they get it accelerating, they get it up to a velocity, I think it was 88 miles an hour or something like that, and then they boom, then it disappeared. Well, it's back to the barrier problem in the tunnel diode, except that instead of tunneling in, we're tunneling out. You can tunnel both ways.
Ah, okay. And I just had a note from Todd Desiato. But let me go to other questions. Does anybody want to raise their hands in chat? I have a lot of comments that I'm sorting through for questions. That's why I'm struggling a little bit here. And so here's one from HT Avarez who'd asked, and sir, do you want to ask that directly? HT. Here, let me ask to unmute. Okay, it looks maybe his connection is bad. He was asking, does writing or reading a cavity on a bump or reading cavity or a bump on the disk cause a nanopropulsion force on the magnetic particle on the disk?
Okay, say it again.
Oh, sorry. So he was asking, I think he was asking when you're writing or reading a bump on the disk, does it create a nanopropulsion force on the particle?
Writing or reading. Well, write and read goes in my mind when I think of read and write. That's what the head has a little magnetic coil called a transducer that you put an AC signal into it and it writes and it makes a little magnetic domain on the surface of the disk that matches that. And then what I'm using is the read sensor, which is a special magnetoresistor, it's called, and it reads back the data as a positive or a negative direction, polarity, magnetic bit, it's called. But the bump I didn't make with the head right transducer. I made it with a focused ion beam. It's an actual physical feature on the surface of the disk. So I can't erase it. But the other thing that's kind of interesting that he raises is, in order for me to do this, I had to erase the disk. I couldn't do this if I had all this data written on it, because all I'd see, it'd be swamped out by all that data. So what I did is I actually erased the surface of the disk, which erasing is basically making it so all the little magnets point different directions so that there's no magnetism on it. So in any case, I don't know if that answered his question or not, but that's the best I think I can do.
Ah, yeah. Absolutely. You know what? Let me go to Gravity Alchemist, and I think that's Bill, I believe. Sir?
Let me unmute. Hi, do you hear me?
Yeah.
Okay, great. Hey, that was a great presentation, man.
Thank you.
Way over my head. Like I said, I'm not a trained scientist, but I do have an aptitude for science. But so I look at a lot of stuff on the internet, and this one fellow's always talking about pressure mediation. So to me, it seems like it's like a pressure mediation of gravity. In other words, your gravitomagnetism is in Einstein's idea that when I read about his theories about acceleration is basically no different from gravity. And I always think that those are pseudo forces, but they're real. You feel them depending on which frame of reference you're in, if you're in an inertial frame of reference or not inertial frame of reference, these kinds of things. So this gravity, magnetogravity, and acceleration, do you see those all as the same thing? Is in other words, I'm trying to get my head around this. Is magnetism some type of accelerative force that's pressure mediated in your construct of that balloon above the Tic Tac? Or am I making any sense?
Yeah, no, that's a good. I think that's a fair way to conceptualize it. It's kind of like I said, it's kind of like a balloon. like a physical balloon. You know, you go
So-
on a balloon ride. That's the first anti-gravity craft we developed. Right?
Yeah, I think in really basic terms, like I can understand your merry-go-round analysis. I love merry-go-rounds and the whole idea of what are, you know, like Newton's spinning bucket, you know, really, what are those? What is really happening?
You could look at, so let's talk about the spinning bucket. Okay, you could imagine that, okay, this let's go back to the whirly-go-round. Okay, you're sitting on the edge of this thing and it's spinning and you're holding on the bar there. Okay, what happens if you let go?
You fly off perpendicular to the axis of rotation.
It literally pushes you off, right?
Yeah, at a 90 degree, you fly 90 degrees.
And what's, okay, and follow that up with what's at the center of gravity of the spinning disc you were on? Nothing. It's empty.
Correct.
There's nothing there. So how does nothing push you off that spinning disc?
Exactly.
Okay? Well, think about it. Okay. And
yes,
then
sir.
think about how long did it push you off? Well, only for a few millimeters, if that much, if even a millimeter, that's where it was pushy. Once you're let go, you fall on the ground. Gravity takes over and you fall on the ground. Okay.
So I see that as a steady. You go back to
empty space is pushy.
I see you go into a steady state. You don't feel any forces when you let go, and all of a sudden that force isn't on you anymore. You're in a steady state. And
okay,
then
let's
if you
do the
if you let
bucket
go,
problem now.
and
Do
you,
the bucket problem.
Grabbed it.
So you have these amusement park things where you get inside this big giant tin can, okay, and you strap yourself up against the wall, and the thing starts spinning around, and then the floor drops, okay. Well, something's pushing you up against the wall. Well, again, what's at the center of gravity of that spinning can? Nothing. Nothing's at the center of gravity, and it's pushing you up against the wall. Now, what happens if you push yourself? Say you had a spring on your back, and you could just like push this little button, and it would push out a little bit. What would happen? Same thing. You'd go boing, 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 hit the ground. Okay. It's only strong at the membrane. It's only strong for a very small distance. Okay. And it's associated with the absence of matter. So there you go, all around you.
Awesome. Okay, so I should apologize. I'm trying to get through these. Jacob Helvey had asked, Jacob, do you want to go? Yeah, there we go.
Let's see here. Oh, yeah, it's just really just a quick comment.
I like your background, Jacob.
Thanks. That was really, I thought that video, the background, not mine, but from the video is of the ocean. Am I incorrect on that?
The background of
I thought the perspective, yeah, the Tic Tac video.
Well, I believe it was at like 20,000 feet. So I don't really think that would be an issue. And in fact, there were two other videos that they had, the Navy released, that were more.
Might have been the other one, because
and those other ones were right close to the water. And I couldn't see, I don't even know if those are real, to be honest with you, because those don't show any of those same effects that I thought in the 2004 Tic Tac video.
I was just thinking, it's just a comment, if that was the case, that it could have been some sort of surface reflection from the ocean, if that was the...
yeah, but not at 20,000 feet.
Right, so this could be a different video.
Yeah.
That's all.
No problem. I appreciate your question.
Awesome. Oh, let me go to Wayne next. Wayne, go for it, sir.
Hi, I apologize. I wasn't able to hear most of the presentation. One thing I've been wondering is how would you recommend measuring gravitomagnetism in an experiment? Because I'm going to be looking for those kinds of effects very soon. I'm going to be working with superconductors.
Sure.
Just wondering how you recommend setting up instrumentation to detect.
My recommendation is this: you go and you find some old hard drives, okay, and you take the lid off the hard drive, set it up in your computer like you're going to use it, right? You know, you can buy these adapters that let you plug it in external to it using a USB connector. Take the lid off. learn the electronics, fit where the head is, where the read write. There's wires on there, and there's like certain wires that go to the read head. It's a little resistor, microscopic resistor, and then it goes to what's called a post amplifier. So you want to find these electronic components. The first way to start though is find your data channel. You know, just take it and hook it in and find out there's like a data channel. It's like 2 wires on the output. And you should be able to hook that up to your oscilloscope and look at the data as it's coming. It'll look like little square waves. Then you trace it back to where this wire is that's coming from the read-write head. And now when it's sitting in the middle of this thing, it's parked over this region where these nanobumps are. Every hard drive on the planet has my invention in it, okay? We just don't know what's there, okay? I found it in '98, so I didn't even know what I found. So, but in any case, if you can get to look at the data channel and then read it and go back to those 2 wires that are in the read head, then you're in a position to see if you can see the nanobumps in the texture zone. Now, what I had to do to make it work, the only secret sauce was there's a bias current on the read head that I had to adjust a little. I had to increase the bias current a little bit for those nanobumps to show up. But basically, that's how you do it. You could do it just basically using existing stuff.
Huh. So it just picks up little spikes or whatever on an oscilloscope.
Well, first what you do is you'll see like what data looks like. It just looks like a bunch of little square waves. It's a 0, 1, 0, 1, 0, 1. It's not going to be like perfectly square. But you want to trace it back to, so that's a digital output. So basically, this analog signal from the read head goes into a thing called an analog to digital converter. Okay.
Yeah.
So that's why you can't use that part, but you can trace it back to that A to D converter, and then there's an analog signal coming out from that post amp to the A to D converter. That's where you want your connection. Okay. But then you're also going to need to figure out where the 2 wires are, because you may need to add a little bias current to get it to see the gravitomagnetism. That's basically the simplest way, simplest experiment I could describe it.
Okay. Okay, thanks very much.
Sure, you're welcome. Good question.
Appreciate
awesome. Thanks, Wayne. So before I go back to Gravity Alchemist, actually, I had a quick question about, so Michael, you'd said that you thought that the UAP was trying to overwhelm the sensor to try and disappear or use some kind of a stealth.
Yeah.
I mean, I guess what's your take on that? That's not necessarily a technical question. I guess that goes more towards intent, but.
Well, it is kind of a technical question, because I think that, I can't remember, you know, Jack Sarfati?
Yeah.
He's one of my heroes. I really respect that guy a lot. I think that's what he's talking about a lot of times when he's talking about different refractive indexes and negative refractive indexes and stuff. That's what I think's going on there. I think it's changing it's optically changing the way you're viewing it, and it's not doing it by, it almost looks like it's changing its surrounding somehow, so that it looks, that's why I said it was kind of like stealth. But the thing about infrared is it sees heat. And so that's why I don't think it worked. And I think that whoever controlled the UAP wasn't happy about that. It almost seems like we weren't communicating with them in a non-violent manner. And that makes me feel concerned for our well-being as well as theirs.
I see what you're saying. I see what you're saying. So let me go back to Gravity Alchemist then, and thank you.
Okay. You had a slide on that had an expanded space-time showed an indentation. And then your dense space-time showed a little bump.
Right.
So your space-time definition with those two slides, could you tell me a little more about that? Why was the dense space-time had a bump and the expanded space-time had an indentation? What looked like they sort of fit together.
Okay, so well, they would fit together, and that's why I picked those dimensions. Is because what I found is it's really more area dependent than it is depth dependent. So that's why I wanted to show two of the same area, so that you could see that the time dimension was the same. I could see the same prop delay between the electromagnetic signal and the gravitomagnetic signal, 1 microsecond for that area. So that was what that meant is if the time was constant, then something else had to change. And what changed is you had more space when you had a pit than you had when you had a bug. And that space was between the sensor and the feature, as I call it, the pit or the bug.
So you're saying, so then in a sense that, well, I've seen videos too. I watch a lot of videos. The space between all these whatever the liquid superfluid or whatever space-time is, the spaces get smaller between. I can't really determine what I'm talking about as far as space-time goes. Is it?
Think of it like this. You can have water and you can have mercury. Okay. Mercury is liquid too. The space-time in the mercury is denser than the space-time in the water. Okay. I can boil the water and it'll turn into vapor. That space-time is even less dense than the liquid water, and so it's a medium. Okay. We're talking about the medium changes. So when I think of empty space, like out in outer space, I don't think of it as empty anymore. I think of it as having an intrinsic proton flux. Just like in a semiconductor, there's what are called extrinsic and intrinsic semiconductors. Well, I think space-time is like that. There's a certain density of protons flux in outer space, and it's different than from Earth because what's missing is electrons. Okay, so you have, and that's why when I show the universe, I show the futures where it's all empty space, because that's what happens, and that's because of if you think about the proton flux affects radioactivity. Well, if you think of the past when we were close to the black hole's event horizon, all matter was stable. Even uranium and plutonium, all that stuff was stable matter over there. But as you get over to the left, to the right, where the emptiness is, all matter becomes unstable, and all you got left is a bunch of protons.
Well, Michael, thank you, sir, very, very much. Let me lower Eric's hand here. Eric, I owe you an apology, and Gravity Alchemist, I owe you an apology for muting you out. We're at 2:01, so we're a little bit over our time. But again, let me put it back on gallery view. Everyone, a giant hand for Michael Boyd. Thank you, sir. That was a big presentation. Thank you for sharing that whole thing with us.
Sure. Sorry for all my technical glitches.
Oh, no worries at all. No worries at all. Thank you again. Okay, so let's go to Franc Milburn. Sir, Frank, you with us? He is with us. He's muted out.
I'm here now. Can you hear me okay?
Perfect. You look wonderful.
Great. Great. Do you guys want to have like a bathroom break or something before, if you've been sitting around for a bit?
Sure, we can.
I'm just putting it out there.
I mean, does everybody want to take a couple of minutes, or?
I'm easy. I'm good to go. Whatever's good for everybody else.
Let me see. Randy said 15 minutes. I don't think we can do 15, Randy. We can.
Okay. Wait, I was going to say, Tim, in the meantime, can we just make sure that I can share my screen? Okay, get that bit squared away.
Oh, sure. Absolutely.
Can we just go for a test now?
Yeah, let's do that.
I'm going to do, hang on. I've got to remove that. I need to share my screen. And
yeah, I know what the bathroom break is interesting because I drink my caffeine all. So
how's that?
So I can't see that. I still see you, but I can see it's displaying in your other monitor.
Sorry, you don't see a PowerPoint, no?
No, it's still you. I think it's on your other monitor.
Right, let me just square this away. Okay. So select the one that you want to.
Perfect.
Yeah. So can you see what a load of slides, yeah?
Yeah, no, it looks great.
Yep. Okay, let me move, because I've got two monitors. Let me move you guys over to the other one. And there we go. So if I click on the first slide, you should have first slide up. Can you see that?
Yeah, it's showing the slide and then it's showing notes also. I'm not sure if that's what you wanted.
Okay, so let me just get rid of the notes. How's that? Is it still showing notes?
No, it's just the slide itself.
It's just showing the slide now. So you're not seeing any notes, no?
Yeah. No.
Sorry, is that a yes, you are seeing notes, or yes, you're not seeing notes?
There are no notes. There are no notes.
Okay, perfect, mate. Perfect. So yeah, just tell me and I'll kick off when you want.
Let me see. I think it's probably been about 2 or 3 minutes. I would say get started anytime, sir.
Okay. Well, I'd say thanks very much for the invite, Tim. It's nice to be back. And yeah, so I'm going to just go through this presentation. If everybody could hold any questions they've got to the end, it should be fairly self-explanatory. If anybody wants me to go back over any of it, I can do that. But yeah, okay, so here we go. So Tim's very kindly invited me to ask about the July 2019 Catalina sightings. So I said, yeah, I'll take that on. So I just want to do kind of like a proviso at the beginning, or a disclaimer. Okay, so it's not a forensic investigation. I am a contributing member at SCU, the Scientific Coalition for UAP Studies. But this isn't an investigation, like they did on the Aguadilla, Puerto Rico UAP USO, or in the Nimitz case, because they did two, big chunky reports on both of those. So I don't have all the answers. What I'm really looking here to do is, to keep an open mind, and really what I want to see, what I've learned from doing this presentation is that I really, need to see a lot more data. There's a lot of theory and supposition out there, so I'll present facts when they're facts, and theories and supposition will be presented as such. Okay, and then everybody can decide for themselves what they think is the most likely theory that fits. Okay, so to give a brief overview, is the sound okay for everybody? Okay, cool. So in July 2019, there was, basically a flotilla of US naval vessels which encountered what were put in deck logs as drones or UAVs. These were multiple craft sightings, July 14, 15, and then later on again, 25 and 30 of July. These craft were operating at night in low visibility and over, above, and around, and in the general vicinity of the vessels. They were operating for long kind of duration periods, over 90 minutes in some cases, and the maneuvers were described as brazen. Okay, so the ships involved, there were 5 Arleigh Burke class destroyers, and there was also a case with another vessel, which is an Independence class littoral combat ship, which whose logs actually put it in the same vicinity during some of the sightings, and had its own has some own imagery associated with it, which I'll cover later on. Okay, so the sightings saw deployment of imagery intelligence or Snoopy teams, which is basically guys with cameras who aid in the tactical evaluation of threats to the vessel. So they come out with, like NVGs, night vision and commercial cameras, and they take additional imagery. And this later prompted investigation, which included the Naval Criminal Investigative Service. Okay, so they do criminal investigations. They also do counterintelligence. And then the Office of Naval Intelligence got involved. And later, as we'll see in the presentation, the UAP task force. Okay, and I've written a separate paper on the UAP task force if anybody's interested. The Coast Guard and the FBI also got involved. And later, this came to the attention of the Chief of Naval Operations, who is, the senior uniformed officer in the Navy and a member of the Joint Chiefs. So there's been some very good articles written about it and some not good, so good articles about it. The initial article was prompted, was this Warzone article, multiple destroyers swarmed by mysterious drones off California numerous nights. Then there's another very good soft rep article about it, which gives some different theories to the other article. Here's the one about the CNO getting involved and his comments. Okay, and then what was problematic is later on, you had this sort of like this cut and paste journalism. So on the one hand, yeah, it's great that, the Telegraph in the UK is following up on this report. What's not so good is they're just cutting and pasting what somebody else has said, and they haven't actually done any research, and they look pretty stupid. Okay. So the information requirements really looking at this case are, what are the craft? What are the technologies behind them? Who's responsible for them, who's in charge, and what are the intentions. So I and others, and I will discuss who I've been talking to about this as well. So we looked at different things. There's some kind of like advanced unmanned aerial vehicle. Are these like sub-launched, air-launched? Were they launched from terra firma? So whose are they? Is this US Navy? Is it Air Force? Is it adversary? Is it commercial, or is it criminal? And criminal in this case, I mean, somebody with a commercial drone who wants to harass, like aircraft or vessels. Okay. So what are the intentions? Are we talking intelligence, surveillance, and reconnaissance, and potentially target acquisition as well? Is it harassment? Is it a prank? Is it a military exercise? Or some kind of test? And, I've discussed these with various people. Are we looking at human and sensor spoofing technology? And there's been a lot about, written about this recently. And this has been going back decades as well. Electronic warfare, projects Bluebeam, Nemesis, Palladium, which are all, use different methods, whether it's holograms, drones, balloons, to basically spoof sensors, and also to spoof humans' sensors. So is it one of those sort of more prosaic explanations, or is it something more exotic, as in, UAP, unexplained aerial phenomena, not from here? So again, provisos, hard to be sort of 100% of any theory really without access to the video, and also, as will become more pertinent as well in the presentation, the eyewitness testimony, and also establishing the provenance of the film imagery, and also getting hold of sensor data, right? If that were available, sort of like a infrared, radar, sonar potentially. Okay, the kind of things that the Navy aren't going to give away, but those would all be very, very useful and would provide an understanding. It's useful to go over the area of operations. Okay, so this is the South California offshore complex down here. Okay, so it's a very large area of space, water, and subsurface area. It's a major range complex in a series of other complexes which serve the Pacific Fleet. Okay, this is up here. You got LA. Okay, so you got Santa Catalina Island, and you've got San Clemente Island, and this is the Gulf of Santa Catalina. So these are two sort of dominant features offshore, these two islands. This island is a big range complex, as I'll come to. Okay, you've got St. Nicholas Island up here. And the sightings take place both inside the Gulf and outside the Gulf. So really it's to the landward and the seaward side of the islands, okay? But this is, as I will go into more detail, this is a very, very, the water gets deep here very, very quickly. Okay, so if we're looking at an air chart of the area, we see immediately it's a pretty busy area. This is the US Air Defense Identification Zone. So most of the sightings occurred well inside the US Air Defense Identification Zone. Okay, and you can see around here, because it's a range area, this whole island is like one range area. So you've got various warnings. And, the vessels are operating like in the vicinity of this island. Okay, some of the range areas, there's a lot of them. So I've highlighted some of the, more interesting ones. So the Navy and others, they can, do everything from, anti-submarine warfare training, electronic warfare, testing areas, mine testing areas, amphibious warfare. Okay, you get the idea. It basically serves Marines as well, and also naval special warfare. And also as well, obviously the airborne elements of the Navy. Okay, San Clemente Island, which is the southern island that we talked about. It's one big range area, and it's very sophisticated. Okay, you've got an area where it can basically launch simulated missile launches of SAMs called Smoky SAMs. It's also got like an artillery bombardment area, and it's got a special warfare training area here. This map up here, okay, there's the island like in miniature, but this just shows like there's a huge electronic warfare range off the south of the island. Okay, and then to the west of it, you've got an anti-submarine warfare range. But if you look in relation to the other islands, St. Nicholas Island and Santa Catalina Island, you can see that, this is a huge offshore series of ranges. Okay, and now I've marked down some of the types of exercise that they run on this island, and air defense exercise, or ADEX. That's what one of my sources believe that the 5 vessels were involved in doing, because they're Aegis equipped. Okay, so I spoke to both Dave Beatty and Mark Cicciotti. Oh, let me go back. Mark Cicciotti was one of the authors of the Warzone article. Dave Beatty is a filmmaker and journalist. He came up with the great animated film about the Nimitz encounters, and also interviewed a lot of the key witnesses like Kevin Day. Okay, so Mark Cicciotti and his partner in the exercise for the article, so they went ahead and FOIA'd the deck logs. After Dave Beatty had originally got hold of the USS Kidd logs, because that was I think the first one that was involved in incidents. And also Dave Beatty, through a third party, he got in contact with some witnesses from some of the vessels, which I'll talk about in a bit. Okay, so emails got FOIA'd as well. And also the Mark Cicciotti and his partner, they got hold of ship tracking data. They reconstructed the positions of both US naval vessels and commercial vessels. And they also put together, from that, the drone sightings and movements for their report. Okay, these were some of the messages that Dave Beatty was getting from, people who'd been on the vessels. So they're basically saying, well, some of them thought they were drones, some of them thought they were Chinese, some of them talking about the lights that were seen. But I think the important thing about this is to take away that there really needs to be witnesses who actually go on the record, because this is just basically, screenshots of people's mobile phones. Yeah. So the importance of having eyewitness testimony to sort of nail down exactly what happened in these cases. Okay, so if we have a quick look at the platforms that are involved as well. These are the Arleigh Burke class destroyers. Okay, so they're absolutely gleaming, full of sensors, and all kinds of like electronic warfare kit and decoys. Okay, extremely well armed as well. In the context of like small aircraft, missiles, and drones, for example, operating in close proximity to the vessels. Okay, so you got the Phalanx Sea Whiz, Bushmaster cannon, 50 cals, and my personal favorite, the M240, which is a 7.62 belt fed. And all of those would be good for blasting drones out the sky. And we'll talk about a little bit more about this later. They do also carry aircraft as well. So that should be noted really in the context that if they were drones, then they could be construed as being not only a threat to navigation, but also a threat to air safety as well, if there were aircraft operating. Okay, this is night one of the incident, and I lifted this map from the Warzone article. So what's interesting is they have these sightings, so they immediately deploy their ship nautical or otherwise photographic interpretation and exploitation team, which is a Snoopy team. Okay, then they go to River City 1, which is emissions control, which is where they basically shut off their broadcasting their ship's position, and they shut down all electromagnetic emissions. Okay, basically they go dark. The interesting thing here is there are reported sightings between the ships, white lights hovering over a flight deck for 90 minutes. One of the objects is moving at 16 knots. We're talking very low visibility, 1 nautical mile. Okay. There's various commercial vessels in the vicinity, but having the automatic identification system on isn't mandatory. So it's possible that there were other vessels in the vicinity that wouldn't be picked up in that manner, although they would be populating, surface search radars. So then, according to Dave Beatty's source, the objects were not drones, and the crew was freaking out. Okay, but this is again underlines the need to have witnesses going on the record and providing testimony to actually nail down the events. This is the night 2 of the incident in July. So July 15. So again, Snoopy teams are deployed. And then on from the USS Russell. So you're talking about drones dropping in elevation, apparently moving forward, backwards, left and right. Okay. So then they contact a commercial vessel, or they get contacted by a commercial vessel that basically says the drone's not theirs. Okay. And I'll talk a little bit about that later. And then the USS Peralta reports 2 and then 4 UAVs nearby. And this is a 3-hour event duration, craft unidentified. Okay, so this prompts investigation after the 15th. So you've got the Coast Guard, NCIS. They report to the command of the Pacific Fleet, and also to they send a report to Compact Fleet and also to the Chief of Naval Operations. So the initial focus of the investigation is on the possibility that it's commercial vessels and associated drones. Okay, but they in the emails that were forwarded, the vessels were in question. They've got very limited capabilities for their drones. Okay, and they were also a fair distance from the US Navy vessels. Then the Office of Naval Investigation gets involved, and then the UAP Task Force. Then drones are ruled out by the US Navy. But the Warzone, for their article, they couldn't foil a classified briefing on unidentified aerial systems from the Navy. Dave Beatty, when I spoke to him, he told me that he'd foiled ONI for all Snoopy team reports from July, but he'd got a reply back saying that they were classified. Okay. And so then just as this report is kind of like, gathering steam, there's renewed sightings July 25th and July the 30th from USS Kidd. Okay. So then there's that first article that I showed you, one of the first articles I showed you, and it was talking about the Chief of Naval Operations. So he's asked if the Navy had positively identified any of the craft involved. So he's like, no, we have not. These findings have been collected. They're still being analyzed. We do have a well-established process in place, blah, 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 to collect that data and to get it to a separate repository for analysis. So that's the CNO, the senior Navy guy. Okay, so some of the observations that came out of that, and I'll tell you what the Warzone guys said and what I think. Okay, so the Warzone guys are saying commercial drones not capable of generally of flying, such long durations, flying in speeds of excess of 45 miles per hour. And then they actually estimate in one case that drones traversed at least 100 nautical miles on July 14th incident. So then they also say it's difficult to catch a destroyer traveling at 16 knots and less than 1 nautical mile visibility, at least 5 to 6 drones coordinated simultaneously. Okay, so there's a control issue there. So I asked, well, is it a question of line of sight control, or is it satellite? Is it pre-programmed? Is there some kind of drone that's acting as part of a swarm node, okay, to enable the other drones to operate? Where the drones launch from? And there's a possibility, okay, was there some kind of testing going on San Clemente Island? And it's noted then in the article as well, you know, there were strange events in the area previously, you know, the 2004 Nimitz encounters, okay, when you're talking about UAP. But let's still go with the more prosaic explanations. So if they were drones, where did they land, or did they ditch? Was it some kind of like expendable drone? Was it sub-launched, air-launched? Was it a launched clandestinely from a vessel, perhaps a fishing vessel or a small commercial vessel? How were the drones not detected earlier? Or, you know, do we know that they were not detected earlier? And also, you know, how was the launch platform not detected? And the other question is, you know, the power for the drone lights, because there are a lot of lights seen in association with the drones. So that would be a, power source that they'd require, as well as for general endurance. Okay, so in the war zone, they say, yeah, Navy's got a lot of data, and then they say there's, you know, they talk about the sophisticated surveillance capabilities, the advanced sensors, including the land-based sensors as well. And then they say, well, this might call into question the drone designation, you know. And I talked to Kevin Day about this, and he is a radar and air defense expert. He's one of the key witnesses from the 2004 Nimitz investigation, and he spent 18 years in these very waters throughout his career, and he's also now still sailing those waters. So we talked about underwater sensors, land-based radar, satellite coverage, and he basically told me that it would be very, very difficult for submarines, despite the depth. It'd be very, very difficult for submarines or surface vessels or aircraft to operate, with impunity in that area of operations. And ostensibly, for all intents and purposes, the US Navy owns those waters. Okay, so then there was another Warzone article, and the premise of this one: adversary drones are spying on the US, and the Pentagon acts like they're UFOs. Okay, and I've seen Tim and others debating this recently on email. Okay, so the premise of this article: swarms of drones harassed a number of US Navy destroyers. That swarm could have been and likely was sucking up or helping another nearby platform suck up all that sensitive ELINT, that's electronic intelligence data, on the most capable warships on Earth at very close range. So this article's coming down on theory, yeah, they're drones, adversarial tech. And then, yeah, the drone swarm could have come from a simple cargo vessel, wouldn't have had to even been within line of sight. Talks about how the destroyers themselves could have been tracked. And then going back to the drones, they can fly for hours, could easily be programmed to execute a certain route in the vicinity of where the vessels were going to be. And so this is the interesting bit, even potentially programmed to react to certain radio frequency emissions. Okay. So China in particular already has the operational capability to deploy large network swarms. Russia has focused on drone swarms that are, EW enabled. Okay, then there's another article which is very interesting, and I put a link because it's well worth reading. And this is by an ex-US Navy aircrew guy, and he's also an ASW specialist. So he talks about the premise of his article was that the US Navy knows a lot more than it's saying, and okay, that probably goes without saying. So he's saying emissions control reduces emissions signature, going quiet makes the ship's electronic surveillance systems work much better. So that the ships themselves would be hoovering up, all the kinds of emissions associated with the drones, as well as taking imagery of them. Yeah, and he underlines the point that the destroyers are, they're, intelligence gathering platforms as much as they are warships. My notes on this would be going quiet. It also reduces the possibility for target acquisition, because if we imagine the drones were operating in several possible mission modes: intelligence, surveillance, target acquisition, and reconnaissance. if you have been pinged by a drone, certainly if you were in wartime, okay, you'd go dark, because the next thing you'd be expecting, might it be a suicide drone? Might it be controlling or activating suicide drones? Or, are you going to be receiving a visit by anti-ship missiles or aircraft or submarines? So that's another reason why you go dark. Okay. He says, drone technology not very complicated. It would be possible to deduce, for the US Navy to deduce a lot of information about them. Okay, then he talks about their controllers. So that indicates to me he's coming firmly down the side that, yeah, they are, basically terrestrial control. It's terrestrial tech, and it's adversarial. And the fact that they were operating at night and in low vis was basically to make their intelligence gathering operations harder to detect. And that makes sense. Okay, so why weren't the drones shot down? So the SOFREP guy, and he's ex-Navy, right? So he's saying the drones weren't really endangering the ships. They're outside territorial waters, not committing an act of war, but they were within the American Air Defense Identification Zone. Okay, my notes on that. If you look at what happened to the USS Cole, okay, that wasn't a drone, it was a small boat. The Houthis in Yemen, their use of drones, both aerial drones to attack targets and also drone boats to attack vessels. Islamic State has successfully used drones to drop munitions on targets and to hit targets. Okay, and the Islamic Revolutionary Guard Corps as well in the Gulf, they've got thousands and thousands of drones. So the US Navy would be concerned about it for all those reasons. Kevin Day underlined this as well when I talked to him, and he said, going back to the 2004 Nimitz incidents, when he saw these objects dropping from high altitude to just above the surface of the ocean, he said the officer in the CIC wasn't that interested, but basically he forced the guy to act by saying that it was an air safety issue. So as soon as he said it was a safety issue, the guy had to act. Okay, so then the SOFREP guy's other point, imagery of drones and capturing their electronic emissions and intel gathering opportunity. And I'm like, well, yeah, but not at the expense of, vulnerability to drone attack or other missions. So you wouldn't want to be putting your ships in danger. I mean, if you're the captain of a vessel, you're going to be extremely concerned by any unidentified objects which are flying in the vicinity and around and on the decks of your vessels. You're going to be extremely concerned about that. So then his other point is shooting down mystery drones would provide a propaganda coup. And my reply to that would be, well, it's much better than losing personnel and assets and looking incompetent. Because if you had, say, a swarm of drones, and in these reports there are up to 6 drones at a time, you don't have to physically worry about destroying the destroyer. You can basically take out the radars, you can take out sensors. Okay, so you can take a ship out of commission. You don't have to destroy it. You could just basically neuter it and disable its ability to operate. So the question is then, so why is there no shoot down of drones, and why is there no use of anti-drone technology? So does this mean that there was something other than drones involved? Okay, so the SOFREP Navy guy, his theory, US Navy vessels tracked by satellite, the drones most likely Chinese and directed by satellite, that the drones, could have been operating basically from, sort of like marine militia warships. Another theory is that they could have been operating from fishing boats. And they would have turned off their automatic information system broadcasting their position, right, to get closer to where they wanted to be. So he says, yeah, if the transceivers are turned off, they'd easily be dismissed as commercial tuna or shrimping boats. My suggestion for this would be, if the Chinese were going to do that and they had the ability to surprise like a flotilla of US Navy vessels at sea, they'd really want to be holding that as a trump card for a scenario of transition to war, where potentially, in a situation, for example, where they were going to attack Taiwan, then they'd want to take out American assets, which are the other side of the Pacific, before they could get into the Taiwan theater of operations. So I think this is a trick that the Chinese want to keep up their sleeve, rather than advertise their capacity to do that. But that's just my opinion there. Then the guy says, well, if you were China and you wanted to sell your drones, it would be very good marketing to be like buzzing American vessels and taking pictures of them. Yeah, but it would also be awful marketing if they get shot down or captured, then you'd look stupid. And he says the Navy would not want to inform an adversary that we know and how we know it. And I said, well, it's a moot point if your vessel gets attacked. You wouldn't want to have your vessel being attacked, and you wouldn't want to have these things operating in, around, and over your vessels. Okay. Okay, now we get to the imagery that Jeremy Corbell has put out, has published, and has supposedly been leaked. The Pentagon spokesman has said, I can confirm the reference photos and videos were taken by Navy personnel. However, she's refused to confirm whether they're unidentified or used as some kind of training material. So this purports to see some kind of triangular shape hovering 700 feet over a vessel, but it's very hard to say exactly what it is from a photo. It's not a lot to go on. And as I'm going to describe, you really need to find out more about the provenance of this imagery. Okay, so Corbell says that this is like multiple pyramid-shaped craft that were seen by USS Russell, and this comes from his website. Okay, then he actually goes on the news, Fox News with Tucker Carlson, and you can see Dave Beatty here. He's pretty upset about it. He's like, who wrote that? Clearest evidence of nothing. Some person filming a helicopter, drone, or plane out of focus. Did anyone do 1 minute of analysis? And then, at the bottom, this is a very sad and low day in the history of this group. I hope things improve. So there's been a lot of upset about this. I haven't got involved in any of it. I'm not an imagery analyst. I'll let other people figure it out. And then when more data comes out, I'll go firm on that. Okay, so another Warzone article came out. This comes down firmly on the side of the drone theory. They seem to show either delta wing-shaped drones, another type of drone that is obscured by bokeh effect. That's the focusing issues. Once again, nothing appears explainable here. Quite the opposite, really. Okay, but there's at least one night vision expert who's not convinced by the bokeh theory. So the jury's out on that one. So there's a blog as well, which is quite interesting. So Corbell has said that this imagery and video came from an Office of Naval Intelligence classified briefing, but whether it was given to him, a leak, right? We don't know the provenance of it. So there's no more information about the vetting process. These are the keywords here, impressive provenance. That's what we really need for these images. And then he brings in this guy, Stephen Aftergood, gives a quote. He says, if someone can't reliably identify the source of that information because it's classified, then that would count against its credibility. And I'd have to agree. Could you guys just hold a sec? Just give me a break. My cat's going nuts outside the door. Sorry. Okay, thanks, guys. Sorry, he was driving me mad, just meowing, meowing, meowing. Okay, so where were we? Yeah, so we're talking about the provenance of this imagery and where it's come from. What's basically the trail of the chain of evidence, the chain of custody. So now Corbell goes on Fox again. This is probably the best UFO military film footage, certainly, that I've ever seen, but I also think that the world has ever seen, right? So that's a pretty big statement to make. And I would argue greatest ever footage, no. SCU actually did a report on 3 minutes of UFO and USO footage from Aguadilla in Puerto Rico. So there, they knew what the platform was. It was a Customs and Border Patrol aircraft. That should be CBP. Yeah, they knew the location of the platform that was taking the imagery. They knew the meteorology. They knew the exact camera system that was used, which was military grade. They knew the chain of custody of the imagery that was taken by that system. They spent 1.5 years of forensic investigation, over 1,000 hours of analysis, going pixel by pixel, to get 3 minutes of a UFO that becomes a USO and then comes out of the water and becomes 2 UFOs. Okay. So I'd argue if you wanted your greatest ever UFO footage, you're going to be hard to trump that one. Okay. That's obviously in the open source domain. Okay, Lou Elizondo, he's chimed in on this as well, on this case. So he's sort of talked about sort of drone specific characteristics, rotary versus fixed wing drones. But he said the US Navy have been using the term drones instead of UAP precisely because they knew that deck logs could be FOIA'd. Okay, and they don't want to get into the whole like UFO UAP scenario. He talks about the unique flight characteristics and erratic, performance of these drones in these incidents. He says that the US Navy has anti-drone tech. He says the US would use deadly force to protect their vessels, i.e. as in shooting down the drones, not killing a human, but destroying the drones. So he said that the US Navy not doing anything is an indicator that it's not conventional technology, that it's not drones. He says if it was Chinese, then the modus operandi would be very provocative, right? Swarming around US Navy destroyers. So then his sort of conclusion is very high probability, not Chinese. So I thought that was interesting. Although bear in mind the proviso that he wasn't actually there. But if you look at my latest paper, it actually talks about his and Chris Mellon's relationship to the UAPTF. This is my last paper on UAP. It also talks about his agenda for a Manhattan-style project to develop UAP, and it also does a deeper dive on the technology from both Elizondo and Dr. Jack Sarfati. Okay, so we talked at the beginning about spoofing tech. I know the war zone has been putting out a lot of articles about this over the last kind of couple of years. So there's various options, sub, air, land launched, drones that launch drones, drones that are basically, sort of expendable just for like EW and spoofing. Okay. So this is one of them, was his Nemesis, that shows like a whole kind of like internet system to basically like, fool, enemy systems. I spoke to Kevin Day. Like I said, he's an expert on the Spy 1 radar, anti-air warfare coordinator. He was a Top Gun air intercept controller. 18 years, I said, in the US Navy service in those specific waters. And he's logged hundreds of hours of air intercepts of suspect aircraft in training and on operations. Okay, so this is what he had to say. An undisclosed text layered over an operational exercise would break every single safety rule in the books. I wrote naval exercise scenarios for a living for a great many years, and that was never done, ever. And so if it was a test on ourselves, then I'd be very, very shocked and concerned too. Okay. So then we were discussing, we asked the question, well, why would the Naval Criminal Investigative Service and the Coast Guard and the Office of Naval Intelligence investigate if it were a US test, right? There wouldn't be a need to test. There wouldn't be a need to investigate. So there's easier places to conduct such a test, right? So you've got the South California offshore ranges, which I discussed at the beginning of the piece. So you've got EW, you've got radar, you've got airfield available. Okay, you've got like, really, really large ranges to do it in. An adversary would be wary of compromising their technology, endangering US Navy crews, and also creating some kind of military, political crisis. I think that close to America's shores. But, then you have, the Americans getting buzzed when they're in the Baltic or when they're in, sort of Chinese waters or Chinese claimed waters. So I keep an open mind on that one. Then Kevin Day again says, I believe this, the spoofing is actually a possible explanation. And this is why I really like him, because he keeps an open mind. I simply do not have enough information to make that call yet. And my mind remains open. So, I mean, that's really great. So then he relates that to his own experiences and limits. So he said, okay, the fact that we saw this on radar and then the other people, saw the Tic Tac with their eyes, this would have to mean that the spoofing tech was, incredible. Okay, so that's, a very fair point from an expert. Okay, so then we had another ship involved. And according to the debrief media, this ship was also underway in the SoCal range area, July 9 to the 19th. Okay, that was when so that would put it in the time frame for the drone events or these unidentified craft events. Okay, so it's a littoral Independence class littoral combat vessel. Okay, this is the imagery again from Corbell. So it says USS Omaha observed a possible UAS, spherical in shape, moving towards the surface of the water and then disappearing. Assessed the object had sunk. And then from Corbell's website, he basically says that it's a spherical craft and appeared to be a transmedium vehicle. As in, can operate in air, can operate in water. Okay, the war zone again, they're talking about, that event, and that specific imagery shows what some claim is a transmedium craft disappearing into the ocean. The stills provided prove nothing of the sort. It looks like a balloon or other object hitting the water as seen through a thermal imaging system. Okay, so need to see the provenance really of the imagery in the video, the imagery in the video involved in these cases. And what's interesting is that, as Mark Cicciotti pointed out, and I was thinking along the same lines before I spoke to him, that this incident and the drone performance are very similar to mysterious drone incursions that occurred over Guam, and that were reported previously. So that brings me to the end. If you guys have got any questions.
Well, Frank, that was amazing, absolutely amazing.
Thank you.
So I had no idea that you would break it down to that level of granular detail. So let me do this. Actually, let me stop your screen share.
Yeah.
And yeah, I think everyone owes Frank an enormous applause.
Thanks, guys.
Yeah, thank you very much. So let me see. Let me unlock the muting thing. We have a ton of questions.
Okay.
So
I'll do my best.
Yeah, let me start with Sergio. I think Sergio is new here. Sergio Moragreja. Sergio, do you want to go first? And I'm asking him to unmute. He would have been asking about. We'll give him a sec. So what he was asking was, did the Tic Tac show any electromagnetic signature, basically? Did the drones have a...
Well, one, we don't know that it was a Tic Tac. According to Dave Beatty, one of the guys, because he was speaking to a guy who said his brother-in-law was on the vessel. So according to him, the guy who was on the vessel, like some people were saying that they were Tic Tac shaped object. I don't know. And that just goes to, you need to have, identify who the witness is and have them on the record, or at least have a witness statement, right? And, some kind of like, the guy's an ASW operator or an anti-air operator or whatever. You need to have some kind of provenance for a witness statement. The second part, where were we? EM emissions from the object, electromagnetic emissions. Well, we don't know because we don't have access to that sensor data, but I mean, there would be emissions in terms of, okay, obviously there were light emissions because they took imagery of it, if we believe the imagery that we've seen. As far as anything else like RF or radiation, I don't know. But, those vessels, I mean, we looked at them at the beginning of the presentation. I mean, they are basically floating, electronic intelligence platforms and signals intelligence platform. I mean, they suck up everything. So I'd imagine that, the original article, the Navy basically knows a lot more that it's letting on. Yeah, they do, because, these are highly sophisticated warships.
Oh, okay. Let me go to Eric Hermanson next, who has a ton of questions. He has just been pounding them out in the chat. Eric? Oh, and okay, it looks like Eric lost his connection. He's gone gray. So if Eric comes back in, one of the things Eric was asking was, I could just ask it for him. Let me see. One thing he was wondering was, is there a longer version of the video? I know that we haven't seen it. He's asking about the pyramid video. He's saying it's around 5 seconds long. He's wondering if there might be a longer version.
I don't know, but I would assume that there was, because I can't imagine if you've got like, just putting myself in the position of deck crew, right? If you've got unidentified aerial phenomena like moving around and basically swarming your vessel, you're going to be taking as much imagery as possible. You're not going to just be doing 5 seconds.
Yeah. Well, and this whole thing goes to the now you'd said that one of your sources said the objects were not drones. So they were saying they were Tic Tac shaped, but there was some confusion over the actual shape, or?
Yeah, I mean, look, I think this is up in the air. I mean, my own personal opinion, I keep an open mind to it. Like I said at the beginning, I don't have all the answers and I don't have access to all the data. It would be nice if I was sitting, in the UAPTF and to know actually a lot more was going on. But I'm pretty sure that the US Navy know exactly what they were and that if they were adversarial or not. I don't think the American Navy aren't stupid. I've worked with the American military a lot over the years, and they're very far from stupid, and they've got the most sophisticated assets on the planet. So they will know what's going on, whether it's an unknown or whether it's an adversarial platform.
Yeah, well, and I think you made an excellent point. I mean, these were ships that were outfitted to identify all of that, multiple ships. So it sounds like these were maybe the best of the best, or at least close to it. Let me go to Mark.
So I was just going to say as well, I mean, you've got to bear in mind, drones are a big threat. Okay, not all the US services are kind of caught up to it, but I mean, if you look now, like the Army, okay, they want to have portable anti-drone systems, okay, and they develop them. The Navy, obviously, is a very big issue for them because of what not only like a sort of troublemakers like Iran have, state actors, but also like non-state actors. Because if you look at what was going on in Iraq, with Islamic State, I mean, Islamic State were basically operating with impunity, kind of like under 1,000 feet, right? So you had the US aircraft and allied aircraft flying overhead attacking IS, but below that level, IS were using drones to attack people. So and then also as well, the Houthis, that's another very, very big issue, in terms of both their aerial attack capabilities. And also they've been attacking like warships, UAE warship and Saudi warships with, drone boats, laden with explosives. So it's a big issue, drones.
Yeah.
For ship safety.
Let me go to Mark next. Mark?
Hey, Frank, thank you for a great presentation. I just had a quick question. There's a highly anticipated report that's coming out supposedly in June for Congress. Do you have any inkling of what's going to be in there and what sort of information we're going to learn?
Sure, I wrote a paper about it. It's got 58 pages long. The short answer is hello. Yeah, the short answer is nothing. There's going to be nothing in the report that's going to compromise sources, methods, platforms, capabilities. Okay. It's been set up to inform Congress. They've been obligated to. This UAP task force report, the UAPTF isn't there as a clearinghouse for like UFO Twitter and UFO investigators and people who activists who advocate for UAP secrecy, ending UAP secrecy. Okay, it exists there to inform basically Congress, in terms of this report. So there might be interesting things in it, but from what I hear, it's like underfunded, lack of personnel. How are they going to comb through 70 years? I mean, the old data is obviously not as relevant as the more modern data, because you've got the incredible sensor systems of like the last couple of decades. But how do you untangle all the kind of mess of the last 70 years, right? In a report, and they've had like 6 months to do it. So I would say, yeah, there might be interesting things in it, but there's going to be nothing in it that's going to help the likes of China, Russia, North Korea, Iran. Yeah.
Do you think it's going to bring up more questions, like their Congresses are going to request another report?
I think it'll bring up questions like, what have you been doing all these years? I mean, as in, the DOD, I mean, how are these things operating in our airspace with impunity? I think that's going to be the key question that it's going to bring up. And if, for example, in a case like this with, like a flotilla of some of the most highly sophisticated warships on the planet, if you have objects operating in the vicinity of them, with impunity, then it's like, well, if they turn out to be adversarial, it's like, what the hell are you doing? I mean, within the US Air Defense Identification and 100 miles offshore, it's not really that far in terms of like geography. The US Navy is supposed to own that real estate. So it's going to basically say, well, what are you doing to defend the homeland?
Yeah. So let me go to Eric Hermanson next. Eric's connection is going in and out. Let me see if, there we go. Eric. Can you hear me okay, Eric?
Hear you, yes. Can you hear me?
There we go. There we go. Yeah, okay, we got you.
Hi, Frank. Can you hear me?
Hey. Yeah.
Hi. So
Hey.
you've got there's three things in your talk. There's the drones, the Tic Tac, and then the pyramid video.
Yeah.
So on the drones, what I'm trying to understand is, because there was also drones found invading an airport airspace. I think it was Denver, maybe.
Yeah.
Are we talking about the same kind of drones? Because those were thought to be just the standard kind of hobby drones that you can buy. Yeah. And when I hear the word drones, I think of either a store-bought drone or a drone that you build from a kit, which is essentially the same thing. Is that what these are?
The truth is, I don't know, but I know that case that you're talking about. I mean, the difference is that those could be very easily launched by some 12-year-old kid who's borrowed his uncle's drone or his dad's drone, right? So to fly over and harass like a facility. The interesting point about these drones operating at sea is they're beyond the kind of commercial drones, the normal ones that you expect that maybe like can hover around for half an hour. Because obviously, if you've got a fixed wing drone, then you've got positive lift. As long as it's moving forward, potentially, if it's got like a like the right engine, I mean, it should be able to travel 100 miles, like no problem. Yeah. The military versions, the commercial drones, like not so much. So that would tell me that, if these were drones in these cases, then they're not commercial drones, right? Because of the distances involved, because of the endurance.
Yes. I mean, but still you can have hobbyist drones. People build their own RC craft, and you kind of should keep it open to having that as a possibility. And they're not really operating with impunity. Well, I don't think they're really operating with impunity because the Navy is just deciding not to shoot them down. The impunity comes from the decision not to shoot them down. So I don't think that it should be phrased they're causing a threat when we really haven't been shooting them down. So I don't think that our defenses are as bad as people might say, at least in the case of these drones. Certainly, maybe in the case of other things, sure.
Yeah, I'd agree with you. But military people, right? If something's unidentified and it's operating like in close vicinity to you, you automatically are going to assume it's a threat until it's proved otherwise. So,
true.
I guarantee you, if you were on that vessel, and I've operated on Royal Navy vessels, if you had something operating offshore, on and around in the vicinity of your vessel like that, and over prolonged period, you would be extremely concerned as to what it was, especially in the context of tensions in Taiwan with the capabilities that we've seen that non-state actors have, like demonstrated in Syria and Iraq and the Gulf, Yemen, et cetera, et cetera. So you'd be extremely concerned about drones. I mean, they don't have the ability to sink your warship potentially, unless maybe it's like a really large drone. Okay. But then, why would you do that? You'd use an anti-ship missile, but they do have the possibility to really ruin your day and to put your platform, out of, basically unserviceable, by destroying, key assets aboard.
That's correct. Also keep in mind some of these drones, some people have actually used helium balloons to help the drones, increase their flight time. They don't have to lift, have as much velocity to lift. One final question on the triangle video. Is there a longer video available other than the one that's around 3 to 5 seconds long?
I do not know. But can I just say your point about hobbyist drones is quite interesting, because I mentioned in the presentation, what was the method of control, right? Are these controlled by satellite? Is there some, like in a swarm of drones, is there one drone that maybe you could have like an intermediary drone that so even if you don't have line of sight, it can still control the other drones? I mean, the technology's there, right? So presumably if somebody had enough cash, you could build like a more kind of like, sort of a drone on steroids effectively, or drones on steroids if you wanted to. I mean, I'm not a drone expert, but I imagine that you can do that. The tech isn't that complicated. It's about enabling it to basically fly. But then you have to have the endurance and the ability to hover, but also the ability to, to travel, long distances as came out in the report. And that's the thing that perplexes me.
Yes, the distances are more perplexing. But in terms of the control software, if you go to GitHub, for instance, where it's a software repository for all kinds of projects, you'll find dozens and dozens of drone open source code, flight software, programming software, and people are, will contribute to these projects and expand them, on a daily basis. And there are just some really sophisticated software packages available in open source, and a lot of these hobbyists are building, these complicated AI.
Yeah.
And some of them are small companies that want to, maybe have control over some of the commercial markets. But look, I'm not saying it's a bunch of kids doing this. All I'm saying is, don't rule out, the simpler explanations, especially when it comes to these drones that maybe are a little further away than you can't maybe see them as well.
Yeah, no, I agree completely. I mean, I keep an open mind, right, as to what it could be. I just want to see more data. So I'm not going to come down and say, okay, yeah, it was like, a UAP as in non-terrestrial tech until I've seen more data. I can't come down and say, yeah, it was definitely an adversarial drone without seeing some more data. And once we know the provenance of, the imagery that it came, and we know more about it, and maybe get, some eyewitness testimony. And I mean, like, radar data would be like fantastic if that ever came out. But I mean, the US Navy aren't going to want to compromise their capabilities. But, I keep an open mind to it. But I think, people saying it's one thing or another, it's too early to say. There's not enough data yet to look at. If you look at the difference between that and for example, the SCU investigation into the Aguadilla, Puerto Rico, UFO USO, well, you can see in that, the provenance of the data, the chain of custody of the data, the platform that it was taken from, the type of camera that was used. So you can say, that is, a genuine UFO USO, because there's no other explanation for it, and because it's been heavily analyzed. But in this case, you can't.
So let me go to Tony Robertson next, and let me ask him to unmute. Tony, you with us?
Yeah, I'm here.
Welcome, sir.
Can you hear me all right?
Yeah, you sound great. Go ahead.
I was on a telecon or videocon the other day, and the voice wasn't right, so I bought a new camera. So it's the first time I'm using it. You guys who are interested in this UFO or UAP stuff should look into the earlier work of Lake Marabou, and not his light craft work. His light craft work did get classified by the Air Force, but he also had something called a microwave beam craft that has a lot of similarities to some of the stuff you guys talk about if you throw the gravity stuff out of it. I was actually looking into Lake Marabou just recently, and apparently his website disappeared in 2014, but there is someone has some information out there. But I would recommend you look at that, because I think some of this UAP stuff may be an iteration off of his microwave craft that he had back in the mid to early 20s.
Okay. And Tony, did you have any questions for Frank while you were on?
No, I just wanted to point that out to if people want to collect some more information out there on this type of vehicles and stuff, they should look at Lake Marabou's earlier work, provided they can find it. Like I said, he's kind of disappeared after 2014.
That's interesting. Thank you very much for that.
Yeah, thank you. And actually, we've been trying to get in touch with Lake and had some of the same. He's just not communicating a lot right now, but I know he's
probably older than me. I've met Lake and went to his lab up at Resnier back then, but so.
Okay.
We work with him at NASA. In fact, some of the microwave craft stuff, some of what's in it came from us.
Oh, and you know what? Sean says that all of his info, we have some folks who are really good at archiving and collecting data. So Tony, why don't I'll have a couple of the guys look. We may have some stuff archived. They have a pretty good Google Drive going. So
you should try to get somebody, not me, but one of your younger guys to research Lake's work and do a presentation on it.
Okay. Yeah. Absolutely. Okay. Well, thank you, Tony. Okay, so let me see. Let's go next. So who else has a question? And I should mention, Frank, we're way ahead of schedule, and that's
Ron Keater's got his hand up.
Okay. Ron, do you want to go for it?
Ron, you have to unmute.
Okay, sorry, let me find him. I'll ask to unmute.
Okay,
There
in
we go.
terms of microwave beams, I used to go to a Princeton University SSI, Space Studies Institute, when it was at Princeton. And the big guy, the big name behind microwave beaming is W.C. Brown, Dr. William C. Brown of Raytheon. He has the patents on the rectenna, the lightweight rectenna. And also Lake Marabou used to go there. Lake Marabou is a good friend of Dr. Franklin Mead, who was a friend of mine. And the only thing is with beam materials, you would have to stay within a microwave beam. In terms of transmission, there have been a lot of tests done down in Bishop, California, where they beam microwaves at about 90% efficiency in straight lines. In terms of fitting any maneuverability, I don't know. It must have a certain spread to it, but in terms of what I've seen, but in terms of descriptors, W.C. Brown Raytheon rectenna will give you a lot of the basic information. There was a Kapton film rectenna. It's a dipolar unit that was lightweight. And what I'll do is, to find out where Lake Marabou is, I'll contact Franklin Mead, and he should know, because they were together with the Lightcraft. Frank Mead used to stop by my place on his way to Washington from California, and he bought one of the Lightcrafts with him. But that's laser. But I will see what I can find, and I will get back to you. But in terms of rectenna, W.C. Brown, Raytheon, that should give you a lot of information. Anything that Lake did was probably, well, they used to meet at SSI, Princeton. So whatever Lake Marabou is doing paralleled the work of the late W.C. Brown. So I will see what I can find, and that's all.
Okay. Well, thank you, Ron. So let me jump in real quick. Who else has questions for Frank? We're going off, and these are wonderful topics, but we're going off topic a little bit. I just don't want to waste Frank's time if we're on other issues.
No stress from me.
Well, Frank, we're way ahead of schedule too. So I don't want to grill you for an entire hour with Q&A.
I mean, do look, I penciled it in. So, I penciled in 2 hours easy. So, I'm here Saturday night. I'm not doing anything.
Oh, okay. Yeah. I just wasn't sure. Your presentation was absolutely amazing. You drill down so thoroughly on it. Right. But I guess a lot of that comes from your background. I know you have a passion for this stuff. And I know that you're hesitant to make any statements, but do you have a gut feel about this? Do you think that this is a terrestrial thing, or is this more of the bump in the night spooky stuff?
It's very, very difficult to say. If I were responsible tactically for the safety of those vessels, I'd have to come down on the side of its adversarial, like terrestrial tech. Just purely to protect the vessels. But like I said, I haven't seen enough data yet to make an opinion one way or another. I mean, I always try and go for the more mundane and prosaic, simplest explanation first. I know there's a lot of people on, UFO Twitter, etc., who really, really want this to be, these to be, UFOs and trans-medium vehicles and everything else. And look, hey, yeah, I'd love them to be as well. Which I actually think would be better than it would be those than sort of like Chinese advanced electronic intelligence gathering or attack drones. But I can't say one way or another. That's the truth.
Yeah. No, it's interesting. I mean, there are some other, one of the things, I didn't see this in your presentation. Maybe it was, maybe I just missed it, but I'd also read in the captain's log for the USS Kidd that they made a note about the Mark 87. And apparently that is a rifle that shoots a ball with a rope. And so the idea was they were trying to hook the drones with that. That was what the person who wrote the article suggested, I guess.
Yeah, there's been some speculation over that did it refer to that basically tool for sending a line between vessels for replenishment, or whether it was the sensor system, or whether it was a weapon system. So yeah, I looked at those, and that's why I didn't include them, because I don't have hard data on any of those, so I don't want to gauge like in idle speculation. But I mean, I would be very surprised if those vessels did not have, you know, like guys on deck with, you know, M240s, 50 cals, you know, basically like, you know, with a round in the chamber ready to rock and roll. I wouldn't be surprised. I'm just surprised that the drones weren't shot down or captured, that they didn't use some kind of drone tech to basically, you know, like down one of them and grab them, because you'd want to basically do, you know, technical intelligence exploitation of this technology. And that's, you know, why Elizondo's got a good point, you know, when he says, well, this looks to something else. Why didn't the US Navy act? I mean, you can imagine, okay, these are waters off America, but I mean, if this were in the Gulf and they were being swarmed by drones, they'd be shooting things down after giving a warning. They'd be firing warning shots like they do at the Islamic Revolutionary Guard Corps Navy, yeah? So, you know, a vessel at sea with these things swarming around, there's a threat to navigation, there's a threat to air safety. What would happen if, for example, a scenario where, you know, you had a crewman injured? That happens all the time. You've got a helicopter in the flight deck, if there were one embarked, or you'd want to get somewhere where, you know, you could be reached, because you want to fly that guy ashore as soon as possible, you know, if he could travel, right? So, you know, then there'd be an air hazard, right? An air hazard issue.
Now, do you think part of the, I mean, if this was, well, I guess it wouldn't matter if it was adversarial or something else. Do you think part of it could be because this is relatively crowded waters? I mean, they're what, 5 ships, they're in relative proximity to each other. Do you think that there might have been some concerns about opening fire because they might hit, I mean, God knows what, right? But
yeah, I mean, especially on the landward side of the islands, I mean, you've got major shipping channels, right? And the port of Los Angeles, you know, San Diego. I think, yeah, you wouldn't want to, you know, then you're not going to open fire for no reason. But these seem to me to be pretty exigent circumstances. If you have these things, especially when it's like a repeat performance and these things are coming back. So are they gathering intelligence? Is there some more sinister intent? I mean, quite easily, you know, what would happen if one of those things dropped the deck and something exploded, and then you've got like, you know, a massive, somebody's killed, or you've got a massive bill to like replace, you know, like an expensive radar. You know, these are the issues.
Yeah, no, that makes sense. Well, let me ask, let me see. Does anybody else have questions they want to put out there, or?
Tim.
Yeah,
Tim.
Paul.
My question is that
can I
when
get
you saw these drones coming in, did they come from the same direction, or did they leave from the same direction?
Yeah, it looks like they were coming from different directions, but I can't be sure on that. I mean, spread over the 4 nights that they occurred, because the vessels are moving around as well. So the guys who did the war zone report, they had quite a problem. Friendly fire time. Yeah, no. Yes. So they would have had a problem basically, sorry, when they were doing, because they're running off the automated information system, like the tracking data where the ships were. So sometimes some of the naval vessels had their system switched off, so they had to basically try and run it from like logs of other ships as well. So it's unclear precisely like, you know, the exact drone movements, but those 2 maps sort of give like their best case analysis of where the drones were and where they came from.
Did they scatter, or did they go up at all?
I'm not sure.
Okay, thank you.
Yeah, well, again, Frank, you've done an amazing job based on really spotty information, right? I mean, because I know this, I mean, I've read several stories on this, and it was just a couple of sentences here and there at the most. So,
yeah. I mean, there's a lot of things out there, but you know, there's always, you know, this kind of speculation, and a lot of people, you know, they make comments just because they don't understand, like, you know, for example, how the military operates. So I think there would be a different perspective for American warships operating, you know, whether they'd be complacent or not. I mean, I don't think a ship's captain is ever going to be complacent. It's like a guy, you know, flying a fighter jet, right? You've got an extremely expensive kit, and you've got, you know, in the case of a Navy vessel, you've got a lot of crew people, you know, a lot of crew members. You know, you're responsible for their lives, the commanding officer. So you can't ever take any chances that's going to put your vessel or your people at risk. But Elizondo's point, they didn't use drone tech because it's because there was some other kind of phenomenon involved. Okay, yeah, that's a good point. But it could also be, like the Navy, they knew what it was and they didn't want to open fire for whatever reason, or because it wasn't perceived as a threat. I just find it very difficult to believe that if something is buzzing around, that it wouldn't be perceived as a threat. You would be preoccupied at the very least.
Yeah.
I mean, imagine, you're moving along at 16 knots, right? That's a fair rate to go, right? So you're moving along at 16 knots, which is about half of what they can do max. I think they can do about 30 knots max, those vessels. So you're going along about, half the max speed of the vessel. So, and you've got these things buzzing around, it's potentially a threat to navigation, a risk to navigation.
Yeah, no, that makes sense. That makes sense. So let me see. Christopher Clark had a question, I think, about, he was asking about the, Christopher, do you want to ask? Here, let me ask you to unmute, sir. Oh, you know what? It looks like, yeah. So it looks like he's completely muted out. He was asking if there might be a standing order, but I think you've already gone over that. I mean, so, some of these questions are ground that we've already really covered. I think that's probably it for questions, Frank, to be honest. I think we've burned through everything. Oh, wait, there's Mark. Okay.
Yeah. During the disclosure project from Stephen Greer, we heard from a couple generals who were in charge of nuclear weapons facilities where flying saucers or some kind of craft came overhead and the rockets, the nuclear weapons went into no-fly situation, which seems like a much more severe and important UAP encounter than what we had here with the Nimitz in 2004. Is there any reason why so much attention is being given to this Nimitz encounter versus past encounters that we've had?
Yeah, that's a really good point. I spoke to Captain Bob Salas, who was involved in the Malmstrom incident. Yeah, he was the actual missile launch control officer. Yeah, who was, had basically 10 of his, a whole flight of his missiles were shot down, as you say. I think there's more attention being paid to it now because there's a lot more data out there. There's a lot more, data to assess, especially, with the Nimitz. You had the eyewitness, you had radar, you had other sensors. We don't know the full extent of the sensor data involved in Nimitz, but, there's a lot more out there. The Warzone's done actually a series of really good articles on how, the Spy 1 radar on vessels has improved on ships like, like the Kidd, another Arleigh Burke class, and also how aircraft sensors have improved, and that's why more UAP and stuff have been seeing. I mean, yeah, I'd agree with you. Strategic assets like nukes, be very, very high value targets that you don't want to have anything unknown flying around. But I would also argue, the carrier strike group is also like a strategic asset. It's your ability to project power around the world, and also as well, the carriers are nuclear powered too. So frightening potentially if that thing gets hit or it goes down.
Right. And how did the videos actually become public? Was it?
Oh, in the Corbell ones.
Yeah.
I think they were leaked, or he's saying that they were leaked. But in that case, then I would be asking, well, if there were ONI stroke UAPTF, if it was an ONI / UAPTF document, then NCIS would be investigating a leak. So potentially that would be a criminal investigation then, if the leak, if it had been, leaked without authorization. So that's an interesting point. But apparently it was a leak.
Was it leaked through ATIP and then through?
Well, actually, if I could jump in, Mark, I think you're conflating the original, the three Nimitz, right? The gimbal, go fast, and there was the other one, and those came through TTSA, and right. Then this new one, the Jeremy Corbell one, is the triangle, and that one just came out. But those are two different sources. So I think Frank was talking about the new one, and then those original ones. Yeah. So
I got a question.
Sure.
In any of these situations, was there any interference with the ships?
Sorry, what kind of interference? You mean electromagnetic?
electromagnetic or anything?
I don't know, and that sort of be a really, really fascinating thing to know if there was any kind of like, you know, jamming or. I think the thrust of the one of the war zone articles which came down the side of drones was that, you know, that they basically be kind of like hoovering up.
But the reason I'm asking the question is that if they did this to the nuclear facilities,
yeah,
what would they do to the Navy? And I mean something, I'm not talking about something small. I'm talking about something like an aircraft carrier.
Yeah, I mean, potentially, if you can shut down a nuke, then why wouldn't you be able to shut down, you know, the power systems on a vessel at sea?
Okay.
Deactivate its weapon system. I mean, we saw that. I saw in, like, you know, for example, in the 1976 Tehran case, and in other military cases where radars have been affected, the military radar, aircraft radars have been affected, the electrical systems, the targeting systems have been affected. So yeah, that's quite plausible.
Absolutely. Thank you.
Well, and those, you know, Frank, those are really interesting points too, you know, and again, I don't want to drag this out too long for you, but you know, I mean, there is data. You mentioned that the UAPTF, this report having to go back through 70 years of data. They do have data over, you know, stuff being shut down over silos and stuff like that. So it'll be interesting to see if they include that. Although I do wonder if maybe they'll just cut that off and focus on the Tic Tac, right? Maybe they'll just cut it off and focus on the Nimitz forward kind of a thing. But, yeah. Oh, sorry. It looks like you're.
There we go. Yeah, I mean, the provenance, I just saw somebody put up a note saying, yeah, you know, George Knapp, he verified the videos. Well, yeah, you know, the Navy has said that the imagery is legit, it's real, but what's the provenance of it, you know, and what are you know, is there more footage? Are there more images? You know, what about the sensor data that was going on at the same time that was being taken? What about the witness statements? Yeah, you need to have all of those to get like a composite picture.
Can I summarize what you're saying here? That
sure.
In all these incidences, there was no interference at all with the sensor performance.
I don't know, because I don't have access to that data. That's the thing. And I don't see the Navy giving anybody access to that data either.
Now, if I could jump in, Hector Serrano had a comment. Let me see. And Hector, could I get you to? Yeah, there we go. About passive FLIR versus jamming.
Yeah, I was going to say in the TikTok incident, if I am not wrong, they tried to lock on with the F-18 pilots declared that they tried to lock on with their radars target lock the TikTok incidents, and they kept getting jammed, which is why they switched over to the FLIR pods on passive mode. So basically they couldn't get jammed. And that's why you saw them like trying to get it to hone in on the moving target, and they had to do it manually. And basically the guy celebrates when he finally gets the system to automatically lock in and keep tracking. And that's why they did it, is because their radar was being jammed.
Yeah. Well,
yeah, that's so I was gonna say, I think, yeah, that's a good point. Same thing happened in the Tehran case that I mentioned. You know, as soon as the guy had, he was in a Phantom, he had radar homing missiles and he had heat-seeking missiles. As soon as he tried to get a radar lock, the weapons panel just went off.
Yeah, and that's along the lines of what the F-18 pilots were saying, was that they could not. They said, "quote, it was being jammed, actively jammed." That's actually a quote from the pilot himself.
Yeah, well, and that's not an aggressive maneuver, but it's not far from it, right?
No, but they obviously knew they were being targeted too. You know what I'm saying? When you got a beam of radar energy at you, they knew like anyone else, and stuff like that. And by the way, I've spoken to some people that are in the defense industry, and we all agree that the video on the TikTok, yeah, trust me, the Navy's got the real high definition video still, because they say, look, those FLIR pods, 4K ain't nothing for them. So yeah, there should be a hell of a lot higher resolution images that we have not seen yet.
Oh, interesting. Okay.
And these are the guys that work in defense with the pods.
Now,
telling me this.
Even back in 2004, though, I think some of
Yeah.
this was shot in 2004, right?
Yeah, no, the technology has not changed that much in the pod. They knew exactly what pod. They were like, no, there should be a hell of a lot higher resolutions than those images that you see on the video.
Well, and it looked like at least one of those, and having done some editing on versions, let me see, one of them was like a Windows Media format, and then the other two.
Yeah. So the guy, supposedly the guy that leaked those, said that when he got the video, I guess it's a copy of a copy or something, he couldn't get two of the videos to play, and he didn't know why. I'm thinking it's some kind of formatting issue. This was years ago, so you would think that by now it would have been resolved. And yes, to the account, dude, you do not steal you don't release anything from the NSA, from the Navy, without having a major command investigation and criminal investigation. That is a big chicken dinner in the making. So no, I am something else. None of this makes sense in the normal sense of how things are handled by the military and the Navy, because I was there. I've seen them. They go nuts over they go nuts over anything. Yeah.
Can I ask a question here? Is there any possibility that these people that were looking at this stuff that was back in the 2000 or so, review it to see if they could format it again to get something more?
I would think that whoever's got the video that supposedly wasn't, that they couldn't get the other two to play, I'm thinking by now they should be able to find what formatting issue was the issue, because it's more common now to be able to repair things like that. Back then, it would have been a little bit more, you would have had to been
technology has advanced quite a bit.
Exactly. So that's why I'm kind of stranged out by the fact that whoever released those videos said that and wouldn't be able to go back and fix the play error that's causing it in this day and age.
I wonder if, now that you bring that up, I wonder if we might see higher resolution or more media, different videos come out when this report is released, right? That would be a hope.
And that's that you guys got to also understand that the Navy is not going to just straight up military protocol. They're not going to put out anything that may inform or confirm for adversaries what the capability of our sensor packages are. Yeah. I mean, when I was in the Navy in my submarine, I can tell you right now, we could go more than 100 feet underwater, but that's all we were allowed to say that we could go. So it's just the way they do things. The military doesn't reveal, it's like, oh, spy one at this amount, power, resolution, beam. They're not going to give you all that information so that an adversary can turn it against us on a later date. So they have to be very careful. But I don't see why. But at this point, it's out there. So I don't think they can't deny that something's happening. They admit it's not their own. You hear too many people in very authoritative positions saying, yeah, there's a lot more, but I can't talk about it. I asked for it to be declassified, but I left the position before I could, before it happened. So maybe they'll reveal it now. So there's confirmation from multiple sources, credible sources, because they did the job, that they have a ton of information, a ton of sensors, both in space and in land, and vehicles have been used to track these things worldwide. So it's not just like, on the coast of California. That was just a show. That was just a show being put out there by them. I mean, and no, the US Navy does not fire on anything in times of peace unless it becomes an imminent threat.
Okay. Yeah. Well, so I think that was everything we had in terms of questions. If you guys want to just chit chat for a bit, I mean, that's, which is basically what we've been doing, but we have Todd at 4. We could do that too. In fact, we probably should. Why don't we see if Todd can go a little bit early? And let me see, Todd, are you with us?
Yeah.
There we go. Todd, do you want to present now? We're about half an hour ahead of time, but.
Yeah, it's fine with me.
Okay, well, why don't we do that then? And we'll come back to all the rest of the stuff in a Q&A session. So actually, you know what? Before I do that though, let me go to gallery view. And again, I want to thank Frank very much for a wonderful presentation. And it just absolutely, that was truly amazing, Frank. The drill down you did was just incredible. Okay, so let's go back to Todd now.
I was going to say, cheers, guys, and cheers for the discussion as well, because it's been enlightening for me too. And I'm probably going to go and get my head down now because it's like 23.
I know, it's getting late.
Okay, cheers,
Frank,
guys.
Thank you again so much. Thank you again.
Bye.
Bye-bye. Hey, okay. So yeah, let me do this. Okay, let me mute everybody out while you present, and I think we're all set. So Todd, take her away, sir. And are you doing okay? I know you had some back pain that you were struggling with.
Yeah, I'm all right.
Okay, well, go for it. And thank you for joining us, and thank you for the presentation.
All right. Well, this came about because I had a hunch, because I had a feeling that it needed to be expressed how the uncertainty principle relates to gravity, because the uncertainty principle is probably the most, the foundations of quantum mechanics. So earlier we got to watch Sabina show us about the uncertainty principle, probably better than I could ever do. So here's a video of a dog surfing. And essentially, these equations up here are Heisenberg's equations, and we can localize the dog on the surfboard. And he's like toward the back of the surfboard, but can we localize the wave he's riding? I mean, the wave is underneath him, it's in front of him, it's behind him, so this is, a behavior of waves, and it's natural the way this, that this came out in the uncertainty principle. So waves have a wavelength in space and in time, and you can think of that wavelength as the, twice the delta x, and the period of time is twice the delta t, and the values are complementary. So if you narrow delta x, the change in momentum, delta p, gets larger. And if you narrow delta t, the change in energy, or uncertainty in energy, however you want to look at it, gets wider. So, if you try to localize this wave, it's going to get large and the poor dog's going to get pounded. But whereas if you reduce it, and it's reduce the momentum and it spreads out, then it becomes a nice, safe ride. So Heisenberg's principle don't change just because you're in a gravity well or out of a gravity well. To an observer far outside the gravity well, he could, do some measurements of what's going on down the gravity well toward a black hole or toward a star, and he would determine that Heisenberg's principle hasn't changed. So in that sense, angular momentum, which is the right-hand side of those equations, doesn't change inside or outside of a gravity well. And in order to try to express this clearly, and you'll see why I chose to do it this way, I introduce just a scalar kappa, which is a scaling factor for these variables. And it just shows the complementary nature that if kappa is larger, then delta E over kappa is smaller, but kappa delta T is larger. And same here, if kappa is larger, then delta X over kappa gets smaller, but kappa delta P gets larger. And I believe these are what they call like the delta X and the delta E in this case are what they would refer to as a squeeze state. The kappa greater than 1 would be squeezing these variables. And then, but if you take the ratio of these in terms of creating units of force, you see that the kappas cancel out. So like angular momentum, the force is also doesn't change inside or outside of a gravity well. So these two constraints on our measurements, on our uncertainty, our ability to measure, and the behavior of matter are all that's required to derive gravity. And by that, I mean the relationships between space and time, energy, mass, acceleration, all that. So what do we know about gravity? Length is contracted in a gravity well. Clocks run slower inside a gravity well. And in terms of these relationships, the complementary values are scaled the other way by a proportional amount. So here, delta x over kappa gives us a length contracted x variable. X sub kappa gives us time dilation, t kappa, delta t kappa, but the momentum is increased and the energy is decreased. And again, kappa is just a scaling factor. So kappa is larger inside the gravity well. So scaling results in the reciprocal values or the complementary values, I mean, of momentum and energy to scale the other way. So next slide. So if we take the ratios of these, then we get velocity is inversely proportional to kappa squared. Power is varies the same as velocity, inversely proportional to kappa squared. And the ratio of momentum to position, or momentum uncertainty to position uncertainty, is a mass current, has units of kilograms per second. And force, as we just said, is invariant with respect to changes in kappa. And so we're just taking the ratio of those values and we see that, you know, how they scale relative to each other. So one unexpected consequence, and may not be unexpected for anyone who's seen the polarizable vacuum model, but since the force has to be invariant inside and outside of a gravity well, but space and time are not, then acceleration is not. And so acceleration scales as 1 over kappa cubed, which means that in order for F equals ma to be invariant, then mass must scale like m times kappa cubed, and then force doesn't change. So this is kind of unexpected to, you know, but it is if you know the other model, but it comes out here from the Heisenberg relationship regardless. And so now we're going to compare. The first column is just the observable values or expectation values. And then from the uncertainty constraints, I'll go back one. From the uncertainty constraints, we have length contraction and time dilation and the scaling of velocity and momentum, energy, frequency, acceleration, and mass. And in the third column, we have the Schwarzschild solution of Einstein's equation in the radial direction. It is the ratio of these metric coefficients, which can be treated like a refractive index, as in Hal-Puthoff's polarizable vacuum representation. So in that representation, it's easy to see the relationship. Kappa, or kappa squared, is equal to K, and K is the refractive index. And so looking at the relationships, the same relationships that we have for gravity are identical to the relationships that you get by matter obeying the constraints of the uncertainty principle. So right there in the foundation of quantum mechanics is gravity. It's matter obeying the constraints of the uncertainty principle. After I wrote this, I read a couple of papers, but none of them dealt with it this way. So I'm trying to present these relationships, all right? And so, but there's another relationship that is one that I've presented before at APEC and at Estes Park, and that is that you can treat the gravity as a damping factor acting on the oscillators inside matter. So zeta is a damping factor, damping function, and zeta squared represents that 2gm over RC squared in Schwarzschild's solution. So introducing damping into the phase factor of the stochastic wave equation, it has the exact same effects. And so, you know, what we've done here is move from a gravitational field described by a refractive index and to how that field affects matter itself from the perspective of a distant observer outside the gravity well. Gravity, or refractive index, acts on matter in a manner that is consistent with radiative damping or damping in general. In other words, the field acts as resistance to the harmonic oscillator circuits that make up matter. So if you treat matter as harmonic oscillators, then damping is like adding resistance to those oscillators. But if it was just adding resistance, then everything would basically collapse to nothing. But the commutation relations in quantum electrodynamics and quantum field theory are prevented from doing that by the 0-point field. So the 0-point field is like a source. And without that source, you know, the electrons would spiral into the nucleus and vanish. So you can't support atoms, you can't support matter. So there's a balance, an equilibrium between the 0-point field and the decaying resistance I'm talking about in damping of matter. So the damping and the source are in equilibrium, and that equilibrium changes depending on the distribution of matter and energy, just like the right-hand side of Einstein's equation. So you have to have that equilibrium to balance things out. But it's this balance that sets the scales of these relationships, the kappa and the K, the refractive index, because our rulers and clocks are scaled by damping in the gravity well. And so when we use rulers and clocks that are variable to damping, we measure space-time curvature. We measure the Heisenberg uncertainties. So here's a table adding relative damping, and you see the zeta, and it's just, you can see here that the refractive index and 1 over 1 minus zeta squared are the same thing. So it's just the, you know, written inversely, but it's the same exact relationships for length, time, velocity, momentum, energy, acceleration, and mass. So the uncertainty principles basically set up these rules for statistical observations at the quantum limit, and general relativity describes an identical set of rules as a result of the gravitational field, and the radiative damping model describes the identical set of effects, but as the result of damping of the harmonic oscillators in matter. So why does this work? And the reason is the core of quantum quantum mechanics is that we have quantized angular momentum. All of the fundamental particles in the standard model have quantized angular momentum. So it doesn't change inside or outside of a gravity well. Therefore, all the particles in the standard model must obey these same rules of relationships, you know, because when the angular momentum is fixed number, h bar over 2, then those relationships have to hold. And so, you know, fermions are spin 1/2, bosons are spin 1. All atoms, the ML quantum numbers are all describing quantized states of angular momentum. So because angular momentum is quantized, everything scales according to those relationships in the previous table. And that's, you know, the gist of the presentation. Now, what's next? What I have next, and before we go to Q&A, so I don't have to come back on, is some updates of some experiments and a really cool demonstration. Let me see here. I think I'm sharing the sound. This should work. Coils, which is setting up a background magnetic field, which basically is pointing from right to left. I have it set so that when the type in the chat if you can hear pulses, it pulls the beam of electrons toward it. The gradient coil's in the back. You can now see almost 2 full rotations, and you can see the diameter is getting bigger. You know, it's kind of going downhill because the coil is relatively small compared to the size of the Helmholtz coils. Give me another view on the top. In a nuclear magnetic resonance experiment, think of that spinning beam of electrons as your gyrating protons. And when the gradient is applied, they're going to lift in the direction toward that coil, just like this. And in doing so, they would lose weight. So it's the same experiment, just instead of spinning up individual protons, or in the case of alzaphon, individual electrons, this is spinning up a beam of electrons that, when placed in a gradient field, want to accelerate in that direction. Well, down the gradient. Hope that explains it. Now, how does this mimic a warp drive? Well, here I'm using the background coils. The background field is a pair of Helmholtz coils, which is setting up a background magnetic field, which basically is pointing from right to left on the screen. And then I am pulsing a coil that is behind the coil on the left to reduce its magnetic field, and thus creating a gradient. Right? So I'm applying the gradient field over a background uniform magnetic field. In space-time, we have a background relatively uniform Maxwell temporal field. It's a scalar magnetic flux density. If we apply a gradient field on top of it while initiating NMR throughout the entire vessel and everything we want to transport, then when the gradient field is pulsed, the ship and everything in it everything that's resonating under NMR and APR will accelerate forward. And that's the warp drive. All right, so what you saw there was cyclotron motion. It isn't quite a cyclotron because I'm not accelerating it on each loop, each pass through the center, but it's still cyclotron motion. And geodesic motion is what you get in general relativity when you take the derivatives of the metric potentials. And geodesic motion means that no work is being done. In other words, free falling is equivalent to an inertial reference frame. You don't feel forces as you're free falling in a uniform gravitational field. I mean, you do if you're in a black hole and falling toward a black hole and you get spaghettified, but in a field like the Earth, you don't notice that. In cyclotron motion, the magnetic field that I'm applying is not doing any work on the charged particles because the force is exerted orthogonal to the direction of motion. And as it changes scale, it's a torque, but angular momentum is conserved. And if we apply a gradient to the flux density from the Helmholtz coils, which is what I'm doing with the pulsing coil, the cyclotron motion of the particle will drift in the direction opposite the gradient or down the gradient, downhill. And since the force, because I'm still putting a magnetic field, and my goal, because I wound a big coil, bigger than the Helmholtz coil, to create the gradient so that I could get a nice uniform gradient. And the objective was that the magnetic field lines stay parallel and orthogonal to the motion of the electron at all times, so that no work is being done, and it's equivalent to geodesic motion. And I'm trying to conduct some experiments with this machine I got, which is a Lorentz force experiment demonstrator I got from Sci Supply. And it's pretty cool. I like it. It's fun. So at the quantum limit, at that spin 1/2 particles, fermions in general, we can write the angular momentum. And we see that, in the case of the cyclotron motion, the linear momentum is conserved. But when I turn up the magnetic field, the angular momentum decreases with the radius. And that's because the magnetic field possesses angular momentum. So when I'm adding magnetic field to it, the total angular momentum of the field plus the spinning electrons in that beam combine so that the total angular momentum is conserved, but the angular momentum of the electrons in the beam, not their intrinsic spin, but the spin of the beam, is losing angular momentum until, if the field strength were strong enough, that I can collapse that circle down to a single electron. Then we're dealing with this bottom equation here where the area is exactly like it should be in those relationships. So the scaling of those relationships is related to the scalar magnetic flux density. And that's what I call the Maxwell temporal field. And because gravity is not polarized like magnetic fields, but if you have a scalar magnetic flux density resulting from the divergence in the Lorentz gauge, and I use this as an example, it doesn't have to be Lorentz gauge, but it provides us with a nice conservation of magnetic flux, which magnetic flux is a quantized, count integer numbers of magnetic flux lines. It's quantized as Planck's constant over 2e. And so quantized magnetic flux, we have a conservation equation, and that is the Lorentz gauge equation. And so this equation on the right-hand side here is basically the divergence, and it's equal to 0, but that's a statistical average in quantum electrodynamics. It's not an absolute value. Over an average of many statistical observations, it'll average out to 0, but the instantaneous values are not 0. And so this divergence term is what I'm calling the Maxwell temporal field, because in using this, the magnetic flux, remember I said is quantized, but h bar over 2e squared has quantum units of ohms. So it acts as the resistance for the damping factor. So the scalar magnetic flux at the quantum limit acts as a damping factor, which causes the particles themselves to length contract and lose energy, lose power according to those relationships. And that's what gravity is. Excuse me. So, and the beauty of this is that changing the gauge potentials with a gradient while keeping the Lorentz gauge intact does not affect electromagnetic forces. E and B don't change. So the geodesic motion we were talking about is not the same as a regular, or I should say not the same as the electromagnetic forces, because those are not affected by a gauge field. But if you're applying a gradient in the scalar gauge field, then it's different. It's geodesic motion. It's changing those potentials of the gravitational field. And I'll get to more of that in a minute. Okay, so the scalar magnetic flux results in time dilation. And the hypothesis is that the resonant or Compton frequency of fermions is a direct result of the instantaneous scalar magnetic flux density in the local environment and the gyromagnetic ratio of the particle. The random flux acts as resistance, damping the natural frequency of the quantum harmonic oscillators that make up matter, providing the damping factor and the transformations as shown in table 2 and table 3. So the time dilation, you have a damping factor, and that damping factor we equate to this. And this is basically a gravitational potential. And why is this a gravitational potential? Because the gyromagnetic ratio divided by the resonant frequency, okay, the gyromagnetic ratio divided by the resonant frequency has units of 1 over Tesla, 1 over flux density. And the part of the hypothesis is that I'm assuming that the background field that sets the scale of the resonant frequency, the Compton frequency of these fermions, that scale is being set by a background field of scalar magnetic flux. And so that gamma over omega naught represents the denominator, which is the background field. And then in the numerator, we have the applied field, and it's applied like in the case of the Earth, we have the Earth's field. So the equivalent of the Earth's Maxwell temporal field would be about 700 kilotesla. And whereas in a previous presentation, the one in September and the one here on APEC, I calculated that the gamma over omega naught was a field of about 4 billion Tesla. So what's causing gravity is a gradient in this numerator part. And the background you can think of like, it's the 0-point field plus Mach's principle. So it's the 0-point field plus all the fields from everything else that happened to be there at the time. practical, or at least we'd hope so. So then installing this damping factor into our previous equations, now we see that, you know, Heisenberg tells us what we measure in space, you know, tells us why we measure space-time the way we do. And then the radiative damping model tells us why our rulers and clocks change in this field. And now this scalar flux density allows us to control it. It allows us to create these fields, which are wide bandwidth, multi-spectrum, very wide bandwidth, like the 0-point field kind of field, but scalar magnetic flux, not polarized magnetic flux like my experiment demo here, which is really for illustration to explain it. But the scalar magnetic flux density is something that can be created, and it can be manipulated with a superposition of fields to give us control over the damping factor, and thereby create things like warp drive, gravity, anti-gravity, however we like, because we have control over that variable. So Maxwell field is basically the gauge potential, which can be written covariant or contravariant as a 4-vector. We call it the 4-vector potential. And then from that, we get the equations of motion. And from the equations of motion, the way they're written here, they've been symmetricized, so they look alike. And so what you see here is how the Maxwell temporal field, or the divergence of the 4 potential, appears in the equations. And here it is again. So this is known as the Lorentz gauge condition, and it's the divergence of the electromagnetic 4 potential. And this is that part. And we're calling that the Maxwell temporal field because it controls time dilation, as I explained. So this choice of gauge renders Maxwell's equations generally covariant, so they're not in conflict with general relativity. It also sets the scalar magnetic flux density to 0 arbitrarily, as in quantum electrodynamics, where it is 0 as a statistical average. And it gives us a symmetry and a conservation equation for magnetic flux. As I said, magnetic flux is conserved. And if you consider that A is the magnetic flux per meter, then this equation basically is a conservation of magnetic flux, just like we have an equation for the conservation of electric charge. And since Maxwell's equations are gauge invariant, changes in this field have no effect on Maxwell's equations, just like they shouldn't in a gravitational field. Maxwell's equations don't change inside or outside the gravity well. And so the gradients in this field result in a gravitation-like effects, including gravitational lensing, geodesic motion, and that are identical to those that have been previously attributed to the space-time metric of general relativity. So here's a way to reproduce those effects using electromagnetism. So how is this connected to the refractive index? And I was asked to explain this briefly. The results of passing through a refractive index. So think of this gauge, this part right here. This is the gauge transformation. Okay, so we have a voltage, clicked it. We have a voltage, and from that voltage, we're subtracting the time rate of change in magnetic flux. And G here is the magnetic flux. So that gives us a new voltage, which is, it's the same as grounding at the positive side of the battery instead of the negative side of the battery. It just adds a scale to it. It doesn't change anything. And for the magnetic vector potential, we're adding the gradient in the magnetic flux. And this gives us, it just kind of like adding an offset in the electric current. I mean, this current was already moving in this frame. So these two things, what they end up doing is, if you're subtracting from the voltage, then you're increasing the scaling factor in the denominator, which gives us K E naught. And if you're increasing the magnetic gauge potential, then we're increasing mu naught because we're adding more to it than it had before. So we end up with K mu naught. And so you can think of this as it's the equivalent to like standing waves, where the scalar photons are being radiated by charged particles. And as they're radiated out through a refractive index, you get partial reflection. And in a partial reflection, the electric flux cancels and the magnetic flux adds. So it gives you a basis for having an increasing magnetic flux density, scalar magnetic flux density, toward the source of matter. Okay, so it makes sense in that regard. And one can think of this as a superposition of fields or superposition of potentials. Next, we're going to talk about a superposition of fields. And in this is similar to what I was demonstrating with the Helmholtz coils. And I have a field between them. And then I have here the beam of electrons with its magnetic field wrapped around it. And when I superimpose the two in that bulb, what you're seeing in the bulb is really the mercury vapor as the electrons hit the mercury vapor, but it's what you're seeing is the magnetic flux on one side has constructive interference, and on the other side, it has destructive interference, and that causes the beam to go in a circle. And this is identical to what you get here in a warp drive. You get, consider if like, as this little warp ship, we're going around in a circle. And if it's going around in a circle, then you're getting destructive interference in the middle and constructive interference all the way around, just like we were just saying. But now in the case of a warp drive, we have the destructive interference in the front and constructive interference in the back. And it's this passing through that gives us, the warp drive. So okay, so a lot of people, including myself, wonder why a warp drive can go faster than light. And Sabina has a video on warp drive, and basically the reason is because we assume it can. There's nothing in the literature up until very recently that ever talks about how to accelerate something from 0 to faster than light. In fact, Alcubierre's original equation is symmetric, so it has no front or back. It's not in any way a propulsion system. It's simply a piece of space moving relative to the rest of space-time, dragging its contents along with it. Now, he says, and everybody says, well, the interior is flat, so there's no gravity. Well, if the interior is flat and there's no gravity, then when the bubble takes off and accelerates, it's going to leave you behind. So it needs to drag you along. So it's frame dragging is what it really needs. And that's comes along with in the paper of with Bobrick and can't think of his name right now, the realistic warp drive paper. they talked about the shift vector, and that's what's needed. And here I'm using the same relationships I did before to get a gravitational potential. And then we take the 3 gradient of that potential and we get a shift vector. And it's this shift vector, which is the gradient in this magnetic flux ratio, that gives us the warp drive. Just like I explained in the video, it's the warp drive takes all the protons and all the electrons in your body, in your ship, everything. And it's like a particle accelerator where you're the one getting flung out of the accelerator. So all the protons spin and you pump them up using a magnetic field to run them up to a higher frequency, then put them in a gradient, a reducing gradient, and let them free fall back to their natural state. And it's doing this to everything synchronously that allows it to move with geodesic motion and without the passengers getting slammed against the back. So that's pretty much the presentation for tonight. And there is a slide with conclusions here, but I'm not going to read through them. I will putting up these most recent slides on my ResearchGate. So, so Tim, we can open it for discussion.
Okay, wonderful, wonderful. And how are you doing, Todd? Are you feeling okay? I know you were struggling a little bit.
Yeah, it hurts, but all right.
Oh, okay, okay. I think, you know, we got hay fever season coming up too. So let me do this actually, for just a moment. Let me mute you back out, and everyone, please put your hands together for Todd. And Todd, that was an awesome presentation. I had no idea you were holding that out on us, and it had the visuals with the warp drive and all that. So, okay, so let me put you back up, and then let me see. Let me go to Eric first. Eric Hermanson, sir.
Hello, hello, Todd.
Hey, yeah. Hey, sorry.
Hello, Todd. Yes, how are you getting the neutrons? How are you getting the neutrons to pull to get pulled?
They have a diamagnetic ratio too. It's almost identical to a proton, because it's not really the neutrons or the protons that are spinning, it's the quarks, and the quarks all have a charge and magnetic moment.
Okay. So if the fields inside the craft are not, I mean, if the fields inside the craft are not perfectly uniform, you will rip things apart, right? You've got to have I mean, there can't be any mistakes at all in the structure, because then you'll rip your body apart.
Yeah.
But when this craft goes, will the person feel any acceleration?
They shouldn't. That's the objective, is that because it's causing all the particles that make up the ship and the passengers and everything in it, they would all accelerate together.
Mm-hmm. Now, would you call this the equivalent of I mean, if you can speed up the clock at the very front of the ship, I'm sorry, slow down the clock at the very front of the ship and speed it up at the back of the ship in a tremendous dilation and expansion of time, and you have the time, no time dilation inside the ship, then the ship would also move, correct?
Yeah, if you could do that.
Okay.
Yeah, the problem is projecting anything outside the ship. The way this works is that the field, the only thing you care about is where the field intersects those subatomic particles of the ship and the passengers and everything else. Anything outside of that is irrelevant. It's like it has to affect the particles, and then you're charging those particles up like you're ramping them up a hill, and then letting them fall back down. And as they fall back down, they're going to radiate kind of like a laser and you're basically the gradient in the field is directing which way that's going to go.
But aren't the electrons in the cyclotron radiating due to Bremsstrahlung?
Yeah.
And so part of the energy loss you talked about, isn't that just plainly due to Bremsstrahlung?
Yep.
And you're adding that onto the equation. You're not incorporating that.
It's part of it. I mean, it's like I say, at the end of the day, when you're back at the bottom of the well, so to speak, when you're back to your starting potential, is that you have an equilibrium at the quantum scale between the losses and the 0-point field that supports it. So you've got this balance, this symmetry between the two, and you're charging up one side with a high potential and letting it fall back down, but that's as low as it can go. So, and this is all sublight. It's not FTL. Like I said, there's nothing yet to date that tells us how to make it go FTL, how to accelerate it beyond the speed of light. I hope it's possible, but from what I've seen so far in terms of just how much it's offset from the galaxy and the sun and the cosmos, it's like 1 part in a million. So if you could negate the effects of all those things in our local neighborhood, it would only raise the speed of light by 1 part in a million. So it's really hard to make it go faster.
Thank you. So Todd, let me go to Michael Boyd next, sir. There we go.
Hello. Hey, Todd.
Hey.
I'm sorry I missed the beginning of your presentation. I was dealing with my taxes. But I'm curious about, I heard you talking about the relationship between matter and resonance and that kind of stuff. I'm curious if how that would affect the equations if you, in a state where there isn't matter, like empty space. How would the gravitational field behave differently without the matter being there? I'm curious if you have considered that.
In empty space, I'm modeling. The model is modeling gravity as scalar magnetic flux density, as due to gradient in the scalar magnetic flux density.
So magnetic flux density.
Yeah, so it's like a magnetic flux density, but it has no direction. It's because it's random. It comes in any direction, any strength, any form, in a very wide bandwidth spectrum.
So if you were thinking about magnetism, positive, negative magnetism, it would be like an erase state.
Yeah, it'd be like you pretty much
like you erased it.
Yeah.
So all the little magnets were pointing whichever way. Correct?
Right. But the magnets are still there.
They're still there. They're just not. They're not polarized.
Exactly. That's the 0-point field. You erased it.
Okay. And then I heard you mention 0-point field, and I'm curious about your thoughts about, which I've asked this question of a number of other physicists, is do you think the 0-point field has a band gap like a semiconductor?
In a sense, it's got the electron positron gap. If you put a strong enough electric field and hit the Schwinger limit, you'll create electron positron pairs, which you could look at as dielectric breakdown.
So it does have a band gap. So you basically, I think of empty space.
But you have to be in the presence of matter to do it. I mean, it's not gonna. It supposedly happens spontaneously, but there are some arguments against that. but in the presence of matter, it's much easier for it to happen, because electrons are so damn small and protons are so damn small that the field strength is enormous, and you can get to the Schwinger limit where particles and antiparticles can be created.
So the way I think about it is in a semiconductor, you have the N and the P side, and then typically you'll take a material and you'll dope it, or you'll hit it with something, and that'll make it a P side. Essentially, but the material has what's called intrinsic carrier concentration. And so what my thought is that the intrinsic carrier concentration of the protons in the flux, a proton flux, would create a magnetic flux like you're talking about. Because you have moving protons, that's going to create magnetic field, right?
So I mean, I think it's pretty much a product of the motion of everything everywhere.
Everywhere, exactly. Everything's moving everywhere. Yeah. And what I'm saying is in outer space, there's still protons moving, but the intrinsic level of those protons is different than what it is over here on Earth when we're sitting on this rock.
Yeah. And that's why, like in Hal Puthoff's model, which you referenced there, based on that model, the speed of light up in orbit, up by the moon is higher, it's faster than the speed of light down here on Earth.
The speed is different, but the speed is the same, but the reference frame is different. So what Hal's saying is, when you're in expanded space-time, where time moves faster, length stretches. Right. So the velocity stays the same. You follow?
No,
but from your frame of reference moving, it doesn't change. But if I'm looking at you moving really fast, it might look to me like you're moving faster than the speed of light, when you're really not. It's just because from where I'm looking. And that's what he's trying to talk about when I couldn't really show that video of his, but he's talking about how, well, if one of these UAPs takes off really fast near you, you don't want to stand near it because you might get radiation sickness.
Yeah.
So it's thanks for your thoughts. I appreciate it.
Thanks, Michael. Okay, let me go to Will. Will, let me see. Thank you for joining us. I didn't know you were. Well, you've been here for a while, I guess. Just hiding out in the back. Oops, and Will just disappeared.
Yeah, just hiding out in the back.
Oh, there we go. Okay, no, you disappeared from my screen, the chat thing. Welcome back, sir.
Up until now, I didn't really have any good questions. Or maybe any questions. So 2 questions, really. So one, do you have a schematic where people can repeat your experiments? And 2, I noticed that you were talking about fermions early on in your presentation. How does the new discoveries at CERN, where there's now a belief of intermediary particles taking place in these types of reactions, so how does that affect your model?
Barely at all. I mean, in a sense, my model is that the universe is full of random magnetic flux, and what they found is there's extra magnetic flux. So that's what's throwing off the G-2 experiment. So there's extra magnetic flux there that they haven't accounted for yet.
Okay, but you still have your index of refraction and so on. So certainly there must be some effect.
Right. But they're not accounting for it. They're not accounting for gravity at all.
So do you think that's what the new thing is?
I don't know. I just came out. I haven't, 10 years from now, I might figure that out.
Yeah. So, and then also the first question, is there any way that people can replicate your experiment to to determine, whether or not it actually works the way
Yeah,
that the way you say. Then this is one of the weaknesses in this area.
Right. I publish pretty much everything onto ResearchGate eventually, and then Falcon Space has a database where they collect a lot of stuff, and we're totally open, open disclosure, open source lab. So, anybody that emails and wants it can have it. But eventually I will, when I get done with some real experiments, because this with the Lorentz force experiment demonstrator, that's like an off-the-shelf cabinet I bought, and then I wound a coil to cause a gradient, and it makes a nice demonstration of something that's too small to see, and it makes it macroscopic so you can see it. And that's a point I want to make sure everybody understands. It's not a warp drive, it's an illustration of what a warp drive does. And so you can see it visually, what's going on when you're spinning protons and neutrons and things. And then I have another experiment that I'm still working on with nuclear magnetic resonance and measuring the weight. And I had some setbacks with work and all, and not having a good enough power supply to run my Helmholtz coils. But now I have a nice new set of Helmholtz coils and a nice power supply to go with it. So hopefully I can get back to that relatively soon and have some data with that. And, that whole experiment write-up will be, on ResearchGate.
Yeah, well, I'm actually happy to hear about that. You're able to demonstrate how to make a gradient transformer, because I have gradient transformers that are using NMR in my lab, and they're quite expensive devices.
Yeah.
So that's actually what I think one of the tricky parts is, making the gradients without having, anywhere from $15,000 to $80,000 worth of hardware.
Yeah, well, in this case, it's all low frequency, so I'm not dealing with megahertz. I'm dealing, with kilohertz and just a 2 centimeter diameter beam.
Okay, thank you very much.
Thanks, Will. Okay, so HT Alvarez had asked me to ask for him because he's having some sound and video issues. He's wondering if there's a direct quantifiable relationship between the warp bubble energy and the amount of gravity in the moving ship at any acceleration and speed. And that one's in chat, Todd, also. Okay. Yeah, sorry. So I think basically what this him or her is asking is what the energy relationship is, right? Like if you want to go X speed, then what is Y energy?
Essentially, if you're really doing warp drive, it should be Newtonian as opposed to relativistic, because there's no time dilation involved. And so if there's no time dilation involved, then energy doesn't go up exponentially as you approach the speed of light. And so your energy requirements become Newtonian, 1/2 mv squared. But in the case of sublight warp drive, like what I think I'm talking about here, it's relativistic. It's the same as any other form of propulsion. Momentum is conserved. You have to output, as much momentum behind you as you're moving it forward. And so you need a source of energy to move it. But at least the source is electromagnetic, not, gigatons of propellant.
Awesome. Well, thank you. Let me see. And then I think David Mathis had, where was it? I saw it here. Oh, David Mathis found the Bobrick and Martyr. He found the archive.
Yeah, that's the one. Martyr.
Okay. Yeah. And so I'm just trying to see if anybody else has questions here. Well, let me do this. Let me ask for anybody else to raise their hand if they've got questions for you. And okay.
I do have a few more videos on my YouTube channel, Warp Drive Tech. Like and subscribe. And if you have an idea of what I should try or comments on any of those videos, you can leave me a message there. I read them all. And I'm going to be doing more videos of all the experiments I'm working on.
Well, this was a great one. I thought this was a great presentation. It was kind of a different approach, right? Because you've presented on the NMR stuff in the past. This one switched things up a little bit. And then I liked the demo also. So I thought this was really cool. I'm really excited. So thank you. Thank you for presenting.
All right. Thanks,
okay.
everyone.
Well, so yeah, let's do that again. Oops. Okay, I will mute Todd out, and everyone, please, big thank you for Todd. Okay. So everybody, let's go to Mark next. Mark Sokol, who is hiding. There we go.
Hello, everyone, and give you a short update. I don't know how much stuff I actually have to show, but I know Jeremiah was doing a couple experiments over the past few weeks, and there was some stuff coming out from Wayne as well. But here in the lab, the most exciting thing that has happened is the 3D printer has arrived, and we started printing out some stuff. We started out by, I got this material called ASA, which is a very strong dielectric. It's this white plastic material over here. The first print that we got on it was, it sort of warped. I had to raise the bed temperature. What we're using the plastic for is going to be inside the waveguide chamber where we're going to test the Alzaphon experiment. This is going to act as a support or sort of a skeleton for the copper chamber. This way, if the chamber is out of tune, I can merely change the size of the plastic and, change the dimensional size of the chamber. Because it's a strong dielectric, the microwaves will pass right through it. It'll essentially be invisible to microwaves. There was a couple iterations of the outer ring. I had to print it a little tight in order to make sure that it was a tight fit. Turned out it was too tight. I wasn't able to get it on over here. So I'm trying to stick it on over here. I even put a little lip at the edge of it. And right now we are printing out another design for the outer lip. I'll show that to you with the printer. So this is a section of the lab that we cleared off in order to make room for the 3D printer. So here is the computer, basically using SketchUp to model out these designs. In this design over here, it's basically going to be the same ring design, and we're gonna have these plastic wedges over here that you can stick in for different sizes. So as you make it smaller, you're able to stick the wedges in deeper and get a nice tight fit around it. Here's the controls for the printer. Here's the printer itself. It says we have about a half an hour left for that print. See the wedges are kind of done already, and it's just doing the large outer ring. Also, we got lots of different types of plastic: PLA, TPU, ABS, PETG. There's also conductive materials and magnetic materials that we're getting. The conductive arrived already. Magnetic's on its way. That will allow us to print some really cool experiments. There is also a material that has tiny microscopic beads of copper embedded in it. It's non-conductive, so it's basically the Banduric, the dot product disk experiment right there. All you got to do is print it out on the printer, and you got yourself a dot product disk for that experiment. Also, this is kind of cool. Polycast. This is a 3D printing material that you can print out, and then you cast it with sand around it and stick that in an oven to warm it up, and the plastic just disappears. It turns into fumes and stuff. So that will make you a perfect casting mold. And here's some spare parts. So that's pretty much what's been happening here in the lab. We've been we had some trouble setting it up, and we were in contact with the manufacturer, and that is what's going on.
Awesome. Well, that's actually, I like the way you have the monitors. That's the part that got me. When you walk in, you have the monitors angled towards you. That's cool. That's cool.
Yeah, standing desk.
So now in terms of the 3D printer, I mean, I know that you've got a few projects going on, but is that the kind of thing where you could substitute? I mean, you could probably print pretty much anything out with it, right?
There's a lot of experiments that we could print right now that we have a 3D printer of this size. This is actually my 4th 3D printer, and all the previous ones died from overuse, just from failure over the years. I've had 3D printers going back to the Solid Doodle 1, which was back in like 2013. So yeah, and those were the kind of printers that kept on breaking and changing parts and all that stuff.
Well, and you can print stuff in too. The reason I'm asking is stuff like Hector Serrano's gravity capacitor, or I'm thinking of his older designs, but you can print a sealed enclosure with conductors inside of it too, right? So
yes, yeah, you can. With this conductive PLA material, we can actually print like circuit board kind of setups. It does have pretty high resistance. It's a couple like 10 ohms or something like that per centimeter. So we're not talking about level of copper or even aluminum. It's pretty down there in how conductive the material is. But yeah, it's pretty amazing that we're able to have all these capabilities: a strong dielectric and an okay conductor. Also, we have materials with magnetic properties. They have bits of iron in them. That material is actually pretty interesting. It has enough iron in it to actually oxidize. So if you don't cover it with something, it'll rust.
Interesting.
Yeah, which is pretty cool.
Yeah, no, that is awesome. Well, thank you for sharing that. So yeah, I mean, I think that was everything that we had on the schedule. Should we go to open discussion now? You guys want to go to open discussion?
Sure. If what's his name? The material scientist dude, is he here?
Oh, yeah, Thomas.
Yeah, Thomas. If he's here, we can talk.
Well, let me see. No, it looks like he might be back. I think he might have had something else going on. Yeah, no, this has been an interesting conference. This has been a really interesting conference. I'm really excited. I'm excited that Michael was able to present his whole thing, and I was really surprised by Frank actually because he'd just done. I didn't know there was that much data available. He just kept pulling stuff out, and I was like, "Wow, that's amazing." So,
well, he put together the reports. He's the one who should know.
Yeah.
Also, we should mention, guys, we're on Wikipedia. This conference officially made it to Wikipedia, and we were mentioned in Popular Mechanics.
Yeah. Yeah, no, that's exciting. That's exciting. And well, and who knows if we keep covering the UAP stuff, we may get a couple of surprise mentions here in the near future.
That could very well be. Jeremiah, do you have anything to show?
You know what? Let me see it. Yeah, he's here. Let me ask him to unmute.
There we go. Yeah, it's still set by default for everybody to be auto muted. So just an FYI, if you want people to be able to freely unmute themselves, you're still set to so they can't. I don't have anything set to present. I don't have the info or the picture is set up, but I can tell you I've been working on a few experiments that were mainly just disqualifiers. So we found out what was ions. Again, more ions. But interesting phenomena where we can produce very large quantities of ions very quickly and produce sort of a percussive pulse that is able to push a soda can pretty hard, actually, almost like it's been punched. So that was fun. We just had to figure out what was going on there because we were like, oh, this is an interesting phenomena. I wonder exactly what it is. The interesting thing that I was looking at, and recently we went back over the Bonson lab videos, and we were looking at some of the diagrams there, and they were so critical to look at those diagrams because they're only shown in those videos for maybe 1 or 2 seconds, but some of those diagrams are critical, and one of them is interesting. There's a light bulb with a heated filament, 2 long lead wires going down to a battery power supply, and then that's hooked up to his pulse power supply, and that light bulb is taking the place of the small electrode on the underside of the parabolic reflector. So I will show you real quick, and I can bring it over. So this was just the basic little test to see. I finally found a good quality vacuum bulb. It's a, it's a genuine vacuum bulb. So this is not an argon filled or gas filled. And it's interesting because it doesn't produce any plasma or anything. The only thing that happens when you activate high voltage is that the filament on the inside, which probably you can barely see, but that filament will pull towards the anode here, which is then just going through a rectifier, a single stage rectifier. So no smoothing capacitance, simple pulse transformer. It fires 10 times a second, 20,000 volt pulses with a 1 millisecond rise in fall time. Primarily asymmetrical on the positive side, and it also helps that it's rectified, so no reverse flow. But this is a non-heated cathode system, and this is just to sort of prove the idea that it doesn't necessarily produce force or much force at all without that heated cathode, because the electron emission won't happen at 20,000 volts in this kind of a vacuum capacitor, where the filament is one of the two elements of the capacitor, unless there is some current flowing through that filament. So we're going to be checking to see if Brown had anything there, and there are several theories that state electron momentum within a system where you have electrons in one part of that system at the emission or the emitter traveling at a low velocity, and when they strike the collector, or strike in this case the glass plate that's in the way of the collector, they'll have a high velocity. The relativistic difference between their velocity and the consequent forces that the system experiences in independent parts of itself are theoretically different, according to two different papers that we've recently gone through. So we're going to go and check to see if those papers have any validity and trace it back to Brown if we can. That's the recent experiment about vacuum bulbs, and it's one that we haven't done before, so we're pretty excited about it. We've tried it before with a non-vacuum bulb. It doesn't work with argon bulbs, I can tell you that. We already found that out at the Falcon Space Lab a couple months back. But that's all I have for now, folks. I will have more next time. Hey, go ahead, Ron, Kita. You got to unmute, though. You have to unmute again. Not quite yet, Ron. You're still muted.
What I wanted to mention, it may not be related. It's just through a connection. I've been mailing out a lot of, did you ever hear of Morton Spears? Capacitive theory of gravity?
No,
Morton?
I haven't. Morton,
okay.
S-P-E-R-S?
Okay, it's Morton, M-O-R-T-O-N. Last name is Spears, S-P-E-A-R-S. Is called CTG for capacitive theory of gravity. And
I'm searching it now.
He is an MIT graduate from 1943.
I will familiarize myself with his theory. I've not heard of it yet, but it's a very interesting exploration. Thanks.
Okay, that's about all. So I just, wherever I can, I missed the earlier part of what Mark was doing. I didn't know. I'll come back and watch it on the YouTube. So Mark's discussion of, I was not having lunch. I'll come back and catch Mark later. Okay, thank you.
Thanks for the information, Ron. I appreciate it. It's always good to get another direction to search for and learn things from. Thanks.
Jeremiah, let me jump in really quick. So unless Zoom is hopefully Zoom is doing okay. I have it set so it's allow participants to unmute themselves. So by default, everybody is muted, but I set that so that you can unmute yourself. So I know Will has his hand raised. Will, do you want to give it a shot? Try and unmute yourself and jump in, sir. I started locking that during presentations, but it's unlocked now. So if it's not going to let you do it. Okay. Maybe I'll quit. Maybe I'll quit using that then. Okay. If I click ask to unmute, does that now you can do it?
Yeah, it works.
Okay. So something must be stuck in Zoom because it says, let me try and set it and then unset it again. Okay. Anyhow, I'm sorry. Well, go ahead, Will.
Okay, yeah, I wanted to say who's the guy who just talked?
Todd. And I'm not sure if Todd is still here. Todd was having some, I think all of us are struggling with hay fever and stuff like that today. So.
Yeah, the one they had the experiment, right? That's Todd.
Yep, there's
with the light bulb.
Oh, Jeremiah. Okay. I'm clicking.
Yeah. So anyway, I just wanted to say to him that actually what he has in his hand is an X-ray generator.
Indeed, it is. Yes, we're quite aware. We don't sit next to the experiment when it runs.
I actually made these in junior high for my own experiments back in the 70s. So it's actually quite an old idea. But be careful because those things do generate X-rays, and that can be very dangerous for you.
Yeah, I had well considered it, and I set these things up where they're remotely triggered. So what I didn't show you guys was that on that system, in fact, with all the boards that I'm building now, all the small battery powered PSUs, they all have photo triggers on them, so I can remotely activate them from 20 feet away, no problem, with a laser or any other device. So it's quite convenient, and that's how we operate the experiments. It also helps too, because I don't want to be near it. My body generates heat, and that affects the experiment. It's a very sensitive scale. It basically rests on razor blade edges sitting on aluminum beads, so that one doesn't wear out, the other.
I'm sorry. I didn't mean to. Okay, you know what? I got it set now. I think I got it set. It wasn't sticking for some reason. Mark, do you want to give it a try? Go for it.
Yeah, it's working now. Okay, good.
Okay. Right. I'm sorry. I'm sorry about that.
Good.
So on the X-ray generators, I don't think 20 feet away is good enough if you don't have a shielded room. I work with X-rays all the time, and X-rays have a very good range effect. So just be very careful.
Would you consider to still be in danger at half a watt?
Between you and the X-rays.
Do you have lead shielding?
Gain X-rays.
Yeah, I do. We do.
Do you have lead shielding, Jeremiah?
Yeah, I have access to it. What I'm asking is, would half a watt at 20 feet away realistically be a serious danger at 20 kV, for example?
X-rays is X-ray, gamma ray, these types of all radiation is a time effect. So it's like if you go to take your X-ray, most hospitals won't let you take more than 2 a month because you're already close to the dose range. Now, of course, these are much bigger than what you're using, but if you're spending hours with it.
Oh no, it's normally about maybe 30 seconds to 60 seconds per test.
Yeah, but it's the same thing as what you're going to get when you go to the hospital. So
well, luckily we just started playing with those, so I probably will throw up a little edge shielding cage then, and it'll be good to run inside of a Faraday cage anyway. So I'll just build the Faraday cage out of lead and just call it a day, 2 in 1. That sounds like a good idea.
It's a good idea. So, but as always, if you're working with X-rays, it's good to have an X-ray badge.
Yeah.
Looks like Glenn, is that your hand up?
Yeah. Or get a you can get a radiation meter like I have this one right here that I bought. It's called
Mark's got a bunch of them too over there in the Falcon Space Lab that I've had a chance to use. Actually, I think he's got one almost identical to that, don't you, Mark?
We have that right over here. I actually have a couple different radiation meters.
Right. So the reason I got this GMC 600 is it's the only one of them that I could find that measures alpha. You need to be able to measure alpha. Most of them just do gamma and betas. So but so X-rays will show up as a gamma. It should show up on your meter, okay? And it's good to have the meter. It's good to have it connected up so that it's hooked up to your computer, so you have a record, okay? Yeah. So that you can determine your dosage.
I think I'm going to do that.
Records are very important when you're working with X-rays. Sorry, I'm a qualified tech, so I had to go to school for all this, so I just tried to pass on my knowledge to you, help you out.
Good news is I only have about 5 minutes of operation with that thing at a distance, and it's only a 20 kV, and it's a non-heated filament, which basically means there's pretty much no current flow. It's probably in the microamps.
20 kV is pretty.
But luckily, I haven't been exposed much, so I have time to do things a little differently. Then, thank you, folks. Thank you very much.
So I had this job where I worked with a small linear accelerator that was used as a medical device to treat brain tumors. And they had a stereographic X-ray imager where they had these two-dimensional, they're about a meter square. And then they had two X-ray sources up above, and then they would make a stereographic image of the person, okay? And those were all 20 kV. And this setup was in a bunker. It had 3-foot thick concrete walls and a big giant door, you know, like literally like a bunker. That's what they call it was. And so that's the kind of shielding you need when you're doing this stuff. So, I mean, it's just a safety thing for your well-being.
Well, fortunately, materials are better today. So, and we know a lot more about X-rays, but 20 kV is a very excited X-ray.
It also depends on the current and the total wattage. So he was mentioning it was less than half a watt. I can't imagine.
Doesn't need it much. So 20 kV is pretty good X-ray. You know, they have hard X-rays, you have soft X-rays.
It's not giving you any X-ray. You need current.
You have to worry about secondary radiation too.
We generate X-rays with you say like 50 kV at 2 milliamps. That can, in time,
that's 10 watts.
Can hurt you.
So that's 10 watts. He's doing half a watt, which is 1/20th of that.
Yeah, well, cell phones use less, and some people
microwatts,
brain tumors. So,
but that's not ionizing radiation.
Yeah, exactly. It's not ionizing. But you know, ionizing radiation is the worst of all of it. So fortunately, I don't believe that that's a problem. But like I said, it's a time issue. So the more time you spend with it, the more risk you have. It's really a time issue.
Yeah, I mean, to be honest, X-rays are concerning, but there's a lot more dangerous things in these labs than the X-rays emitted from these little experiments. And Jeremiah can attest to that. We have basically a lightning machine, a Marx generator that can pulse almost 1 million volts. And yeah, that'll hurt you a lot more than some X-rays.
Oh, sorry. Let me jump in really quick. Michael, while you're back on the call, because I know you had to leave for a bit, do you have a bio photo that you could send me to put up on the website? Because we put one up for each of our presenters, and so I don't have a bio photo for you.
Oh, geez. Yeah, I'll have to find it.
Oh, okay.
And I'm on my computer right now, so I just had to take a picture for an ID or something for my archaeology.
Yeah, no, that'd be perfect.
I'll just
whatever
send you that.
Whatever you feel comfortable with. And sorry for interrupting, guys.
Well, sorry.
Tony Robertson said he wanted to join in the conversation. You're unmuted, Tony. Can you hear us?
Yeah, I wanted to first mention that secondary radiation through lead can be worse than the first radiation. I recommend you use at least a 1/2 inch instead of a 1/4 inch if you use lead shielding. Also want to ask you if what size the bed on your 3D printer was.
Oh, it's 310 by 310 and 345 millimeters in height. So it's basically like a foot cube.
Yeah, I think I built a 1 foot cube one. I think it's about 330 by 330 millimeters. Your piece that you did that was kind of bent. Are you using the glue on your table?
No, the table has a piece of basically it's a magnetic plate, and then there's a piece of spring steel, and on top of that is like a plastic layer, and it prints on that, and then you can pull the entire sheet off the magnetic tray, bend it, and all your 3D prints pop right off.
Yeah, it looked like it was some kind of G10, or they call it R4 or something or another. But I do that too. I use about a 1/4 inch, a 1/16 inch G10 where I can take off and bend it if I have to. But I still use the glue sticks, because I do get that what you have happen sometimes. Sometimes it even happens with glue stick, but not very often. So I recommend it. Just make sure you do light glue sticks, and the glue stick needs to have latex in it, or because there are some glue sticks out there that don't have that in it and don't work. Also want to let you know that I have a machine to do circuit boards, where I cut the circuit boards with the pointy pin type of thing. If you need any circuit boards, give me a holler. And I've printed circuit boards with surface mount stuff on it too, so I can get pretty fine cuts. I also have learned how to etch the boards with the vinegar and hydrogen peroxide and salt. That works very well. It's a cheap way to etch all the other copper off you don't need.
What kind of resist do you use to make your circuit board? What do you put on it to keep it from etching the parts that you don't want to etch?
I sort of kind of bolt the cladded board down to a plate that moves. I don't know what you mean.
Well, in the semiconductor industry, how they make a circuit is they take a semiconductor and then they spray this stuff on it. It's called photoresist.
I don't use that. I just cut the board with a little sharp cutting tool.
Oh, I see.
Guys, we have Wayne Ojala here. He has a demonstration he wants to show us live.
Cool.
He has to run.
Yeah, just real quickly, you guys are talking about the soda can repulsion test. I'll just do it quickly here. It's pretty cool.
Can we pin that full screen, Tim?
Yeah, let me find Wayne here. Let me see. Spotlight for everyone. How's that work? No, and did we lose him? There we go.
There we go. Oh, interesting setup now. That's a change up from last time.
Yeah, it's just another.
So Wayne, can you explain this a little bit? The screws are kind of interesting. What made you go with the screws? This is kind of a cool.
A little more dangerous. This is a neomagnet. So I was thinking, the magnetic field causes ions to move into curved paths. So I thought it might constrain the column of the ions coming off this thing a little better. So, yeah, I don't know if it actually helps too much, but I'm just impressed with the amount of force I get off this. It's pretty cool.
So that's a aluminum can, right?
Yeah, it's a pop can, and these are just. Yeah, so the ions are going to be coming off these screw points here.
The point being, aluminum is a non-magnetic metal.
Correct.
Have you tried it with a jar, with a piece of glass?
I tried it with a little plastic bucket, and it pushes the bucket away, so it's basically repulsive on everything I've tried.
Have you tried taking the two wires and switching them? And
polarity doesn't matter. It's always repulsive.
Oh, interesting.
It does. I can shield it though. Like if I put a little piece of plastic.
So Wayne, if I could jump in,
yeah.
The pop can, it looks like it's hanging from a string, right?
Yeah, it's just hanging from a little piece of thread.
Okay. And so it's just, oh, I get it. So you're basically just pushing it away. So you've just got. But it's not a high voltage. It's a magnetic field that's coming out, right?
No, this is a high voltage. It's probably 60, 70 kV.
Okay.
It's a multiplier here.
Oh,
coming out of here. So
okay, just be careful. Be careful.
Yeah, I'm careful.
It's hard to do this. How much current we talking there? A micro amp, maybe?
Oh, I have no idea. I mean, I'm using this neon sign transformer here. So, what does that say? 1 to 4.
Yeah. Those. And you're doing a multiplier, but
you're a 50 watt. So yeah, that's not very much current. So.
Then there's a lot of leakage here too. I mean.
Yeah.
So, yeah. But it's not really about current. It seems to be about the rise time of the potential.
So what happens when you put the insulator in between the two?
It's hard to do with just two hands, but I'll try to here.
Don't get a shock.
I'll try. Oh, it actually works. Last time I tried putting this barrier, it just it didn't repel at all.
Okay, so now can you move the barrier closer to the can? So increase the distance so we can see if the field strength.
Yeah.
See, it changes the field strength the farther away you get, correct? Looks like it's sticking to the plastic. Is that true?
I need a lab assistant here.
Oh, yeah, it'll get a surface charge. Yeah, lifters had that problem too. You get that surface charge if it gets too close.
Like it sticks to the plastic here.
Yeah, that's a surface charge. You get that. Yeah, we had the problem. Lifters won't take off if they're flush on the table because of the surface charge.
Right.
Yeah, I mean, I'm still learning about this ion, these properties of ions. It's
and there, oops.
There he is. He's just
and when you're working with high voltage and ions, you get so many messy things. Like you'll get like with computer equipment and electronics and stuff, a lot of that stuff will die early because ions will actually climb up the ground wire into electronics, right? Because the voltage is high enough.
I do testing for that. It's they call it TUV testing, where you do what's called radiative emissions, where you take a spectrum analyzer and an antenna, and you measure all the radiation coming off your instrument. And then there's another one called conductive immunity, where you go and instead of you're trying to inject signal into the ground, okay, and it has the same effect. If it's not working right, it'll shut the thing off. It'll actually stop working. And then the third test is called ESD, or electrostatic discharge, which is close to what he's doing here. And so what'll happen is it looks like a welding iron. And you walk up to the stuff and you just zap it with 2 kV of power of a short pulse, and it'll shut stuff down. And a lot of stuff, the only reason it would shut their computer down is because the network cable, the RJ45 cable, wasn't shielded, because it didn't have shielding on that cable. It would shut everything down. So lesson learned there is, whenever if you got a hardwired network, get the shielded cable.
It's interesting. And if you have this is something else I used to, especially like late at night when I was playing with lifters, you could kind of see streams of ions. Oops, Wayne, it looks like you've got your screen share going.
Oh, is that me? I don't think that's me.
Here, let me. Who's screen sharing? There we go. Yeah, but late at night, I used to notice you could actually see streams of ions going through the air. You could see how they would affect like cobwebs and stuff like that, right? When it's really still, there's not. Yeah,
especially when it's dry.
They're messy. They're really messy. They get everywhere. Oh, this is Jeremiah.
Yeah, just
that's not me. I tried to share my screen, but this isn't me. Sorry.
That's Wayne.
Oh, that's not me.
Okay.
Huh.
No, my screen here is I got this little dome-shaped thruster.
Yeah, that's what we're seeing your screen. What's up?
Yeah. So I'm just editing a video right now where I did some comparisons of some different basic shapes of these thrusters, and soon I just got these superconducting wires. I'm going to be doing some work with that. Different kinds of experiments. So that'll be interesting. Got some.
You're taking on the challenge of making YCBO superconductors.
Like
I got these accelerometers.
Accelerometer. What's that? What's the accelerometer using? Is that
well? They're going to plug into an Arduino.
No, I'm just curious what the actual device is. Is it a piezoelectric device or something else?
Oh, probably a MEMS device.
MEMS.
Probably.
Yeah, I've worked with piezoelectric when I had a job at a environmental test lab. That was one of the tests, was a drop test where you'd have to drop it to try and break it.
Problem with piezoelectrics and high voltage is that they can really skew the numbers. It's hard to shield them properly.
Yeah, you know, Mark, Tony was putting in chat that YBCOs are easy to make, and I know Tony's made a bunch of them. He made
the one for NASA that was 12 inches.
Yeah, and then Tony told me, in fact, he might mention this today when he comes back. I'm not sure where he's at, but he had a theory about the skin on the superconductor. When you make them, when you center them, Tony, do you remember you were telling me a long time ago that there's a skin on the superconductor, and it basically comes from the sintering process. The chemical structure on the outside is different than the crystalline structure on the inside.
I think you're talking about the Plekhanov impulse experiment, where he said that the gases in the chamber actually got pulled towards the superconductor due to the high voltage and turned into a white cloud. And this white, my theory behind it is that this white cloud turned into a Bose condensate due to proximity effects associated with Josephson junction type effects. And the reason I say that is because he claims that when they discharged the voltage, the white cloud moved as a single body rather than dispersing, and went and hit the chamber wall and actually damaged the chamber wall.
So is there a difference in the stoichiometry of the crystal structure near the surface of the yttrium barium copper oxide that's different? Is it more or less regular crystalline? I would think because there's skin effects from the high voltage, that there would be a region where the crystal lattice was better. There were less impurities or dislocations in it on the outside than on the inside. Kind of like when you temper steel. You know what I mean? When you temper steel, the way you temper steel is you heat it and then you pound on it. And that changes the lattice structure of the steel near the surface.
That was what I had thought that he was telling me, actually, and maybe I misinterpreted it. But
according to Plekhanov, the superconductor was two-layered, and then it was melt textured, which means the surface that was exposed to the vacuum chamber and the gases would have been a crystal lattice rather than just a bunch of powdered centered together. But even then, there would be cracks, voids all over the place. These crystals just don't grow as a big single body across a big, large plane. In fact,
it was amorphous crystal. It was an amorphous, like so you can buy the old solar cells. They called it amorphous silicon, for example.
If you look up superconductor crystals, it's whatever it forms kind of like from the seed they put on there. It forms like a pyramid and a hexagonal shape into the crystal, but the crystal even will grow out. The biggest ones I've seen is about 1 inch in diameter in a hex pattern, but they put a whole bunch of crystals on the surface. So you try to get all these hexagons to form together. So if you do it right, then your whole surface should be at least the density near the density of the crystals, with separation between the hexagon shapes, so it won't be completely a single piece. It'll have some separations in it on the surface.
So I imagine that would affect the efficiency of it, would it not? How good, strong the field is or anything?
it probably does. He also had a magnet on it. So, and I'm not going to say how, but if you could repeat his experiment with this white gas, there's actually 2 Nobel Prize type experiments there.
Cool.
But I won't tell you what those are.
Yeah, it's a secret sauce, huh?
Yeah. Because I would do the experiment at some point.
So that person just showing the video for the superconducting wire, he showed the wire, but he didn't really show the wire. Which wire? What company is he using?
Was that Jeremiah or?
Todd has just sent superconducting wire to. Oh, sorry about that. Let's try that again. Yeah, Todd has just sent some superconducting wire to Wayne. So he now has, I think, 2 different types, maybe some very thin stuff, and it looks like some strip. Its transition temperature, if I remember correctly, is just about 80 to 90 Kelvin. So it's considered a high temperature superconductor. He sent us the charts earlier. See if I can pop those up. If Wayne isn't on, give me just a minute and I'll get back to you.
Well, Jeremiah, I believe the reason Will asked is Will is working with superconductors out in Japan, right? So, I mean, and Will, you're working with a ton. I think you're working with graphene now mostly, right? But
well, actually, we've invented new superconductors, and but we're of course we're a laboratory. So, and yes, we also work with graphene, and we've been doing that for 8 years. But graphene got boring, so we're working with superconductors and stuff, and we're merging graphene and superconductors and stuff like that. So yeah, so
it's BSCCO to answer your question.
BISCO,
or RB or REBCO. It's one of those 2.
Mm-hmm. And do you know the maker? Because there's quite a few makers out there.
I think Wayne had to go, but we'll try to get that info from him. We can get in contact you via email. That would work.
Yeah, that's fine.
Yeah, and be kind to Will. It's I just looked it up. It's 9 a.m. your time now.
Yeah. I've been up since 3 o'clock this morning.
Yeah, that was what I was going to say. It's 9 a.m. Sunday. 9 a.m. Sunday in Japan. So
I don't think my wife would let me get away with that one.
Yeah, I've had a few comments lately as well from the better half. Yeah, I'm not sure where Tony went. He might be looking at some of his superconductor stuff. And then the other thing that he had told me, and I'm trying to think back again, this was over 10 years ago. He'd suggested something about one of the ideas he was working on was that electrons inside of the crystal lattice were going up or down, which might be creating, I don't remember the exact details of it. And again, this might have just been a working theory, but and in that, Tony, do you remember, and again, I could be misinterpreting you. I believe you mentioned once that there were, the way you explained it, it seemed like there were almost like spindles inside of the superconductor, and that electrons, the Cooper pairs, might be going up or down.
The magnetic field forms these magnetic loops in the superconductor, and the resistance through these loops are like those crap, what do you call them? Not the buckyballs, but the carbon loops, where they have no resistance through the center of them. It behaves the same way. So electrons could actually go through those loops through the superconductor faster than the speed of light.
Here, Tony, this is the print plate.
It looks like G10, yeah.
It says PEI on it, and all you gotta do is just bend it, and the 3D print just pops right off.
Yeah, what I use too on top of my aluminums, but I use the glue sticks because I still have a problem with it not holding down to that.
What kind of material are you printing though?
It's the same as that, except it's yellow. They call that R something 4, but it's also G10. It's 2 names. But I use some stuff I bought a long time ago, so it's yellow instead of green. But I have bought some green stuff recently. I do recommend the glue sticks. I can send you the name of the one I use if you want.
I'd appreciate that too. Hot glue is a huge deal for me. Mark will tell you, I've asked him to send me specifically some hot glue sticks he's found, so that would be very
I'll get one and I'll show it to you.
Yeah, please.
Well, what is the significance? I feel like I've stumbled
This is
into
the
a
secret sauce, right? The glue.
Yeah, this is the secret, and it's. But the way he described it, there was something in his eyes. It's like it's like, you know, it's not just it's not just glue. It's yeah. See, and he's like, this is the good stuff.
This comes from made in Germany. It's UAHU.
Can you turn it? There you go. Say something.
Well, if you show my video on the full screen, I could tell what I'm doing.
Got it.
You can see it just fine. Say something.
I'm here, but
no, I can see it. The Uhu stick.
Yeah, it's made in Germany, and it has latex in it. Not the reason, but I've used some of the stuff. I forget what the name is that you can buy from Walmart, and it don't work at all.
Yeah, Michael, it's $2.
This actually came with one of the printers I bought, but this is just a bigger stick than what came with the printer.
Are you using green screen?
Yeah, he is. He has, and I forget that too. Tony's green screen is really good, so I keep forgetting that it's a green screen, and then that's why the Uhu stick was disappearing, because it was trying to backfill.
It looks like a green screen effect.
Yeah,
that's my lab in my back. Yeah, with Zoom I can put a background. So with some of these other video programs I can't, but Zoom I can. I'm in my bedroom. I don't want you seeing my bed and everything right here.
No, I don't do one because it clips people's hair and but it's not clipping you. That's the other reason why it looks so good that I forget. And
pretty close to this monitor. I use a 55-inch TV screen as my monitor, and the camera takes up the viewing screen a little bit. So I set it in the floor. That's the reason I'm not in it sometimes. As long as you can see my screen, I'm still here. Anything else? You were talking, Tim, I think, about the
You can also use this one too. This is the one I use.
Now, so you guys are using those for 3D prints then? You use them to hold the...
Yeah, this is for FDM. So, yes. So, yeah, as you know, Tim, we have FDMs, SLA, ceramic, or just about everything, actually.
Well, the reason I asked was I don't 3D print at all, and so when you guys are showing me the glue sticks, is it to hold the print down?
This is hold the print down so that it doesn't move. Sometimes it'll release itself from the bed.
Okay.
And of course, this one. Each type is good for different kinds of filaments. So you need the one that matches your filament. So also, if you just buy I found, especially with PLA, the glue sticks that, the ones that you buy in the store for gluing the paper, like, for your envelopes and stuff.
Yeah.
Actually, they're very cheap and they work great. And yeah, I mean, they don't work as great as these because these are, chemically superior. But as a general and low cost way, the other glue sticks are just great. So on our cheaper machines, we tend to use those glue sticks. But these are what we use for our industrial printers.
Interesting.
So my wife just came by and she asked me is this what you geeks do on Saturday?
Well, there's always Star Trek reruns, right? You know, it could go either way, but
I of course was honest.
You have a great wife.
I would be writing a paper in my lab instead of this.
well, no, I appreciate you joining us, though. I appreciate everyone joining us. You know, I mean, the thing, and Mark and I have talked about this so many times, but it's really exciting to have a community forum, right? And it's pretty mellow and laid back and tolerant, and you know, like Michael was saying earlier, right? And that's the whole idea, is so that people can exchange ideas and insights, and that doesn't always lead to anything, but sometimes it leads to, you know, brilliant problem solving. So
I see a lot of similarity between the work and even some of the stuff, even what Todd was talking today, kind of related to the paper I want to talk about next time.
yeah, well, so yeah, and then Tony, you're presenting next week, and Tom Vallone was going to ask Eric Davis, but Eric has been rather quiet lately. So the only person who really hasn't said anything to me in a while is Martin Timar. He's being very quiet, but
I mean, he's not being quiet in the news. He's getting all the headlines, and actually, that's how we ended up on Popular Mechanics, because Robert Scheuer had the opportunity just like 2 days later to respond to that, and that was the rebuttal article from Popular Mechanics on the M drive. That's how we made it up there.
I would love to have Martin attend, though. You know, I know he has created a little bit of friction lately, but at the same time, you know.
Well, you know, he really was the first one to stick his neck out. If you think about it, he's really a trailblazer in my mind. So.
Yeah. Well, no, he used to go to the STAFE conferences too, you know. So yeah, I mean, yeah, Martin's he's a nice fellow. I think what changed was, and I'm not positive about this, but when he became a professor, and then they gave him a bunch of students, and his responsibilities changed. And I remember him. This was several years ago. He told me when this changed, he had almost no free time for experiments, and everything that he was able to do, he had to do with the students, right? So that he could kind of couch it in those terms. So that's my understanding, you know, but.
Gotcha. You became more of a bureaucrat.
That's a pretty typical professor thing, which is why I have had to turn it down. So
well, that's why I used that cartoon in my presentation about, you know, the doesn't matter.
Yeah.
My opinion is the professors who are worried about tenure will not come out and say stuff like this is real. It will always be false. And I'm worried that Timor might be put in that same situation.
Well, I would think that applies to people in the government equally. And there's lots of trailblazers in the government that we don't hear about what happened until they retire.
Yeah,
they can actually talk about it. So that's it goes back to that reward punishment thing I was telling you about. It's not about our well-being. It's about who's correct.
The exception to that is UAPs, though, and this is just in the last year where we've gone from having an iron curtain where the government won't reveal anything to now they're in the news saying, "Oh my God, please help," which is actually in a weird way more terrifying. You know?
Well, no, we are. That's what we're doing, and I think they're afraid because of, like I said, it's a cultural thing. We don't understand that this is, you know, it's not normal to just always be everything that's based on violence.
Well, it's interesting too, you know, and I'm sure Tony could speak to this at NASA. Dennis Bushnell also has spoken to me a bit about this. NASA has a lot of cultural stuff too. And one of the things that I've been hearing lately was how NASA has learned to accept like the SpaceX model, right? And I guess there was a lot, my understanding was there was a lot of pushback against that. And now there's more acceptance, you know, and
right. And
so,
and it's better for all of us because it's through the commercialization of this space that we're actually not just getting better stuff, but we're getting stuff that costs less.
well, you know, the other part too is, I mean, the area where this is just my personal opinion, but the area where NASA really shines is with the rover program. I've just been so impressed by that, you know. And then if you look up there was the Spirit and Opportunity rovers. I wrote a story about one of those last year. You look up mission life expectancy and equipment and component life expectancy on that. They exceeded the life expectancy of those rovers 55 times over. They originally planned the mission. They said this rover will last about 2 years. I think it was, what was it, going on like 16 or something like that. So
yeah, but can we still make stuff as good today as they did back then? When we look at the products that we buy today,
but
they're not as near good a quality as that stuff back then. I mean, it was slower.
I like the new rover though, and rover is a misnomer. If you look up the dimensions, because I was like, oh, look at that, they're doing a new rover, that's cool, it's gonna, you know, they're gonna land this new rover, right, the one with the helicopter, Perseverance,
right?
But then when you look up the dimensions, it's not really a rover, it's more like a monster truck, which makes it even cooler. It's a nuclear powered monster truck. The thing is, like, it's 12 feet long. The tires are like a foot in diameter each. And I'm like, that's not really a rover. I was like, you could literally run Martians over with that. That's what makes it awesome. So,
well, maybe that's what they're doing.
It could be. That's right. You know,
I mean, you know, Death Race 2000, right, on Mars.
Yeah, so I like Perseverance, and then the camera kit too. And I'm not sure what the mission expectancy is for that, but you know, they've got like a 3 sensor system looking for signs of ancient life. And what was it? One of them, if I remember right, it can look for stuff like methane signatures in rock. It can do it from a distance with a camera, and then they can go up close and sample it and break it down. And so just in terms of that I mean, I love what NASA is doing with robotics. That's amazing, you know?
Yeah, Mars has some pretty cool geology. I mean, it's something pretty big smacked into Mars to destroy its magnetic field. And there's some, but I don't see how we could ever have a life on Mars. It's pretty damn cold and dry there. And unless it was 1 billion years ago or something, I don't know. It seems a little unhuman to think about being there.
Well, you make a good point. I lived in Phoenix for a year, and you know, and the thing about Mars is it's going to be cool for about 10 minutes. You touch down and you're like, I'm on Mars, and 10 minutes later they're going to realize I'm in the middle of a giant airless desert, you know, and I'm going to be stuck here for 2 years.
Well, yeah, but you see, that's only if the, you know, I seen this very interesting picture, and it showed the Martian lander, and then it showed the big screen being held up by 2 aliens showing the desert in the screen.
Oh yeah, yeah.
I thought that was really cool. So,
well, I'm actually really excited by the lunar program too, and I think the reason there is just because, you know, we have more staying power, right? We're able to go there and stay, and we're able to do stuff, mine helium-3. Ed McCullough, who used to run the Section E of the STAFE conference, he did a breakdown, and he said something like, there's enough free hydrogen trapped in the lunar regolith that for large portions of the moon's surface, number one, you can pull helium-3 out, but number two, for large areas of the moon's surface, you can literally just heat up the regolith and water will come out, or at least that was his belief.
Oh,
Yeah, there's a lot of NASA reports on that.
Here's the result of the 3D print. Basically, these are little wedges that I could stick in here on all four sides, and it allows me to change the shape of the chamber ever so slightly just by changing the inner piece, and I can still use that same outer ring and change the shape of the chamber. So that's how that design's going so far.
So this is your waveguide, right?
This is the waveguide chamber. This is where the experiment is going to take place for the C-band experiment.
And the size of that matches your C-band?
It's C-band uses I think it's W137 waveguide, so this is quite a bit larger than that. This is going to be the tuned cavity where the sample sits, and we need to make sure that it's tuned properly. So that's why this is.
Okay. Cool.
Now we're just printing a second one. It should be ready in 3 hours.
No, that is interesting.
Looking forward to seeing your outcome.
So am I. Been at it for quite a while.
It's always good when an experiment starts to come together, isn't it? Starts to feel really, really good, especially if you're waiting for a while.
Especially when there's a lot of components and the possibilities from this experiment is basically a new state of matter. It'll change life as we know it if it works.
I just got let me see. I have an email from Bruce Cornett. Let me see. Reading newspaper obituary. Reading newspaper obituaries. Let me take a look. But that may not be. Oh, this is the same place, Mark. Never mind.
NASA needs to go away and new more research organization made to replace it. Yes, I can agree.
Well, but the problem is with that is that NASA is not one organization. NASA is half Air Force and half civilian. There's actually two parts to NASA, the military component and the NASA component.
Well, there's and then there's AFRL, right? And AFRL is working with NASA. I think that's, yeah.
That's
Down
right.
in Corbell, they laugh about it.
Is that not actually in NASA, but it does work with NASA.
Yeah. And so, yeah. And then NASA has kind of a multidisciplinary mission too, because they do a lot of earth sciences stuff. So.
Yeah, on the civilian side, but they also do a lot of military stuff. This is one of the reasons why, the Delta Clipper, when it was created, I can't prove this, but personally, I believe that the Delta Clipper was actually killed by the U.S. military component of NASA, because what Elon Musk is doing today is what Delta Clipper did in the 1990s. And had NASA continued down that road, they would have had, they would have had Elon Musk, many years, decades earlier. So my opinion is that the Air Force killed Delta Clipper to kill space travel for the civilian component. So. Just my opinion. No proof.
It could, yeah, I don't know. I'm not even going to hazard a guess.
But Elon Musk was very smart because he did hire Delta Clipper engineers.
Oh, the DCX. That's what you're talking about. Yeah, I always call it the DCX.
Tony Robertson wrote that NASA has no military or DoD component, but they do support them.
That's my understanding, is that
down in Huntsville, the standing joke is that NASA's pretty much welfare for rednecks, redneck welfare. And Yeah, they can spend millions of dollars to not make a rocket and just sit around at drawing boards all day. Right now, they were dumping all this money into their SLS project, and now they awarded it all to SpaceX. So what happened to all that research that they were dumping into their brand new rocket? It's not
well, but see, then in a weird way, so if SpaceX, this for me, this is what's exciting. If SpaceX is able to bring the cost down, right, then that allows NASA to do more of what they're good at. And some of it, like, again,
what are they good at?
They, in terms of probes, I've told you about the rovers, but then in terms of,
isn't it?
well, those are NASA probes. I mean, what was the one that there's the probe that's the new solar probe.
Oh, no, I'm getting weirded out by all the talk about probes.
Oh no! hang on. Let me. I think it's the Parker probe.
Oh yeah, the Parker Solar Probe. Yes.
Did you know that is yeah? So that technically that is flying close enough to the sun that it's actually in the sun's atmosphere. Like technically, it's in the outer envelope of the sun's atmosphere. That's kind of cool.
And hot at the same time.
So, I think I think it's cool. I mean, if you could, if NASA is able to effectively relocate, if they're able to get, if they're able to hitch a ride with Elon at a lower cost, then they can put money into astronauts, they can put money into probes, they can put money into,
They signed the contract earlier today. Actually, I saw the articles coming out that Musk got like $2.8 billion contract to take NASA to the moon.
Well, the other nice thing about that is when you get into stuff like the SLS, NASA gets their funding yanked every 4 years, right? Somebody comes along and says, nope, you got to do it like this. So,
that makes basically every project has to be at least a 5-year project. This way, when you're unsuccessful by the 4th year, you get to start anew.
Yeah. Yeah, there you go.
NASA is governed by engineering rules, which means if you aren't successful in 2 years, then your project is basically canceled. And that means you can't do basic research because basic research is decades-long process. That's the reason why there's no new propulsion systems at NASA, and they're continuing just improving on what they have because there's no funding for a basic propulsion research in the US at all. It may be within the DOD and military organizations, but not within NASA, not within the National Science Foundation. There's not. In NIAC, people say it is, but NIAC is not to fund research. It's to fund studies. And people use that money to do research, and they're not really supposed to. They're supposed to do studies.
Okay.
So basically, Tony, what you're trying to say is that they would put a certain amount of money for 2 years of research, but the project needs to last for 10 in order to have a result, right?
Basic research projects are long-term projects. You can't say, you can't stand up right now and say, I'll have warp drive in 2 years. But if you were in front of an engineering audience who are going to fund you, you have to say that.
Yeah.
Warp drive is probably 60 years out at best, maybe sooner, but it's a long-term project to do that. Even if you wanted to take something like the Sawyer drive and put that in space as a vehicle, you're looking at 10, 20 years out just for a test.
Yeah, that's what I was going to say. Basic research tends to be about a 20-year period.
Now, guys, should I cut, and I can, should I cut the complaining about NASA part from the YouTube?
Yes.
Okay.
No, that's American way, man.
Well,
it's ugly, but that's America.
If you want to be politically correct, you better cut it.
Yeah. I don't want to get Tony in trouble. So that's.
Jonathan B wrote "Bong hits for Jesus."
Okay, well now we're definitely.
I never signed anything when I retired that said I couldn't complain about NASA.
What is Bong?
Really? They have what's called a non-disparagement agreement that you're supposed to sign.
In fact, In fact, I told him I probably would write a book about how bad NASA was while I was there.
Jeremy, you want to tell Will what a bong is? You're muted, Jeremy.
Can you guys hear me now? Can you hear me?
I don't know that word.
And the way he answered it, it sounded like he was holding one. Can you hear me now?
Can you hear me now? Hold on, let me put it down real quick. Yeah, it's a bong is what people smoke marijuana out of to get. It's like a chamber kind of device, so you can get like a real big, strong hit of weed when you smoke marijuana. That's what a bong is.
So they don't use cigarette wraps.
Well, they do. It's just when you want to get like a huge concentrated rip, or a concentrated smoke cloud, you'll use a bong. And
well, technically, yeah, I'm definitely doing some editing now, but
yes,
technically, I think what you're talking about would have been in the 60s and the 70s. That would have been the era of the joint. That would have been the joint, right? Yeah.
Okay, yeah, I know that one. Yes.
Bongs is what
Chong
Chong went to prison for selling bongs on the internet.
Did he?
And
yeah, Tommy Chong.
He became a movie star in the cop shows.
Well, yeah, and things are changing now. You know that, believe it or not, that's becoming a multi-million-dollar industry here in Washington State, probably in many other states too. But
yeah, here in Mass and Rhode Island, it's definitely a booming business.
The government likes it because of tax.
It's taxed, yeah. That's what it comes down to, right? So
yeah.
Yeah. By the way, in the 1970s, I grew up in the Midwest, and yeah, we never used that word. So
you did the mushrooms then.
The peyote, right? Out there.
Oh no, I don't like mushrooms.
Well, the main reason why marijuana is becoming legal is because of CBDs. They're trying to make it into a medical.
Hey, you guys. I know you like to talk about marijuana, but I wanted to show you this crustal magnetism in Mars that I'm kind of talking about earlier, that I think something must have hit Mars to really mess it up.
Oh, I thought you were circling where the marijuana is on Mars.
No, those are actually the magnetic. This is Mars crustal magnetism from the Mars Global Surveyor, and you can see this region that's circled here. That's something happened to the South Pole of Mars that created these features, which interesting. That's what it looks like on the surface of your hard drive. If you're looking at the magnetic domains, that's what they look like. Just like, so it's like something hit Mars and just messed with its magnetic field, and it got permanently stuck in that like that.
So would it be somewhat accurate to say that it maybe almost like degaussed Mars? Would that be
exactly good? That's exactly what it looks like. Something degaussed Mars.
Because if you have now, I know on Earth, right? Our magnetic field comes from the dynamo inside the Earth, or at least, but Mars is more solid, and so their magnetic field. So like anything that's magnetized, if you shock it hard enough, you can degauss it, right? You can
right, but well, for example, in archaeology, there's this one dating technique. It's called geomagnetic dating, and what happens is some tribes have this practice of breaking rocks. They'd get these cobbles and they'd go on these what were called the Salt Song trails. They go between Utah, California, and Arizona, and they would like go on these pilgrimages, and they would along the trail they'd break rocks, and they could go back and look at those rocks, and because when they broke, they basically erased the magnetic field on the rock and locked it into time when it was broken. And so they could go back and look at the pieces of rocks on the surface and then trace back the Earth's magnetic field and how it possessed. They could say, oh, this is from 250 years ago, or this is from 1,000 years ago. And so essentially it's what you're talking about. But in this case, it got locked into place. So it was like, so what I think happened is that sometime in the past, Mars was like Earth, and it had a protective magnetic. So our Earth's magnetic field actually protects we have an atmosphere because of that magnetic field. Life's here because without that magnetic field, the heavy radiation from the sun would have probably made life impossible. So it's a protective shield. It creates a protective shield around the planet Earth. Apparently, that was the case in Mars too, but at some point in the past, that went away, and it seems like it's related to volcanism. You know, like our Earth has molten. You know, it's called volcanoes. It's got a shell on the outside, and it's basically liquid, superfluid, whatever. But that's not the case for Mars anymore. Mars doesn't have a magnetic field like the Earth. Something happened. And that's why I wanted to show you guys this image.
Well, you know, and that's interesting. I mean, so on Earth, and I remember I interviewed Tom Van Flandern, and at this time, this was 2004, I think. And back at that time, this idea that the Earth the moon was created by an asteroid impact or a planetary impact.
Yeah.
That was way out there back then, right? He was fighting against the power. I don't remember when that was accepted, but now I guess that's supposed to be the prevailing wisdom. And so,
no, actually, there's people that think it's not true because they think the moon is the structure, you know, the composition of the moon rocks are so much similar to Earth. But what's wrong with that thought is the actual evidence is that the outer part of the Earth, the crust, is extraterrestrial in source, that it came from outside, and that there's an inner part of the Earth. And the way that they can prove this is using helium gas. There's different isotopes of helium gas at a certain level. They go to a certain depth, and there's this helium well, I think it's in Australia, where they did isotope analysis on the helium, and they find the type of rock that they have in the moon is more like the outer crust part of the Earth.
Okay. Yeah.
So the moon, maybe the moon got spit out when this collision occurred, but there was a proto-Earth, in other words.
Exactly. Yeah. Well, and then I think complicating things further also is what is it? The Earth and probably the moon also pick up, was it hundreds of millions of tons of space dust every year, right?
Oh yeah.
And that's been going on for billions of years. And so I'm not sure how much that adds up to, but it's probably a lot.
Well, you know, our Earth, there's reason to believe our Earth's gravitational field has changed over time, because, you know, there were periods when we had gigantic animals like the dinosaur age, where huge critters were growing that I don't think they could work nowadays. You know what I mean? So the gravitational field, and also the rotational time has changed over time.
Yeah, I know the rotation is slowed a little bit, if I remember right.
Not constant is the point.
Yeah. There's been some change.
Okay, thanks for letting me share that.
Oh, sure thing. Well, here,
he was just confirmed by his cousin on Facebook that he did pass away.
Wait, did she confirm it, or was she just responding to your post? Because I saw that as well.
There was another post on his page that from a cousin of his that he actually did pass away. And that what you just brought up over there sort of reminded me of Mark, because he was very big into the war on Mars theory.
Oh,
And
cool.
if everyone has a glass, we can raise a glass to Mark McCandlish. You guys have something to drink? Okay. To Mark.
Okay. Yeah, I will raise a glass to Mark.
To Mark.
Well, he certainly did pioneering work in the UFO UAP area. I mean, he was an aerospace illustrator, right? And he did tons of aerospace illustrations, and a lot of those I don't think ever got the recognition that they deserved. But I mean, I think that he really staked his claim in terms of UFOs, you know. So,
does anybody know how old he was?
68. 68.
Oh, wow.
That's a lot of what happened, but he was 68 years old.
yeah, and he was very active too. He was still working. I think he was doing volunteer work at an animal rescue shelter. And,
yeah,
you know,
he was on a conference in October or November. It was. Yeah. Last year. Did a very nice presentation, and it's great that we had APEC together, so he was able to give one more presentation about. I think he presented on stuff that he's never presented before here.
well, and that's for me, that's one of the things that's exciting is trying to capture some of the legacy, right? Is trying to capture, you know, the legacy of ideas, because this community generates so much information, you know, and I mean, it's just,
Also,
it's a
this community's
tragedy. I
lost
think.
a lot of information. So much has been lost by people who didn't talk out. You know, it's glad that we had Mark to come on and share that information while he was still with us. And it just shows you everyone that life is short, and it's important that he was here and shared that with us, man. That's awesome that we got that interview.
Yeah, and there were, I mean, there have been several, lots of folks in our community, I think, that we've lost, but
oh yeah,
you know,
So I actually got a shut. I have to go. I have a friend here who wants to be fed.
Oh yeah, it's that time of the.
So and I had fun. I appreciate it. Thanks for having me, guys.
Well, thank you for
Hey,
Michael.
Michael. Oh, I just wanted to say something. Michael. Hey, they discovered a shark fossil here right outside Albuquerque, New Mexico, and they call it the Godzilla shark. It was a news story last night.
And it was huge, right? It was like a 6-inch shark's tooth or something like that.
They call it the Godzilla shark, and I didn't hear it. It was either 7 feet long, or it was 70 feet long.
Yeah,
I think
it was 70.
Really?
Yeah, 70.
I thought you might like that.
Normal. Great whites are 7.
Yeah.
Oh, okay. This is what they call it, Godzilla shark.
Some of that could be related to the I don't remember what they call it, but the nuclear winter that happened after the impact. Because from one of the things I'd read was there may have been some gravitational changes, but I also read that supporting that much body mass, right, it takes a lot of food, and you know, for like hundreds of thousands of years, basically all life was scavengers. So all those heavy body weight animals died out. They just couldn't maintain that much body mass.
Right. And the food, so the point is, though, in the past there was more abundance than there is now, a lot more.
Yeah.
So I got to go though. Thanks again, folks.
Thanks again, Mike. Have a great day.
So you said Mark McCandlish was 68. Is that what the age was?
That's what it said in the obituary website.
Well, yeah, we will definitely remember his legacy, and I'm glad he was able to join us on the conference. And I think he contributed a lot to, to this community, to the UFO community. He contributed a lot. So he was busy. He was on Coast to Coast AM quite frequently, as I remember. He was a busy person. And I think he changed a lot of lives, and he was doing volunteer work. And what I know is he touched the lives of people around him in a big way too, right? He was a very caring person. He had a lot of personal friends that he was helping, So it wasn't just publicity. It wasn't just UFOs. He was actually trying to change lives, in front of him. So that's a good thing.
I got a couple emails from him. I was just looking back, mostly through Facebook, going over like all the details on the experiments that I was running, and he really took a lot of time out of his day in order to communicate with us and work on all that stuff. And he put together a sick-ass presentation for APEC, and really appreciate that. And catching that legacy was key. Who knows what happened? We haven't heard yet what happened to him, but I'm sure we'll hear in the coming days what happened.
Yeah. Well, so do you guys, should we wrap things up for today then, do you think? That's my child. Did you hear that? You heard? Yeah. Because I have my mic open. That's my 11-year-old. She wants to video chat with her friends.
Getting ideas from her dad.
I guess that means it's time to wrap it up.
Yeah. Okay. Well, thank you all for joining us. You guys have a great evening then. And
thank you. Thank you. Good night.
I got someone else who wants to be fed too.
Okay. Have a great evening, guys.
Take it easy, folks.
Thank you all.